Hey guys, and welcome to the Python Developers course with your host Michael Roberts. I'm so excited to be able to deliver this course to you. But I do have one thing to say before we start. And that thing is that success doesn't happen overnight, and becoming a developer doesn't happen by accident. So please, guys, make sure you put in all the effort and time that's necessary to become the successful developer that you dream to be. Now, I wish you all good success, and I really hope to hear your good reviews. And I hope you guys enjoy every aspect of the course and take full advantage of all the materials that are available to you. So, on that note, I wish you good luck again. Let's begin. So, what exactly is Python? Now, Python is the fastest growing and most widely used programming language that we have to date. And as of 2023, it's the number one most demanded skill by employers in the tech space. Now, 11.7 million active Python engineers is an astounding number, but it is the number of Python engineers that we have globally as of date. And Python also is the seventh out of the 10 highest paying programming languages as a skill globally. Now, the average US annual salary for as a Python developer is $124,742. Now, to appreciate Python further, let's take a look at the history. Now, Python was designed by a guy called Guido van Rossum in the late 80s, and the first release of Python was the 20th of February, 1991. And as of 2023, we have 11.7 million Python engineers. So if you look at this, in just over 30 years, Python's gone from 0 users to 11.7 in a relatively short space of time. So what's fueling this massive adoption for Python? Let's take a look. So why exactly Python? Now, if you look on your left here, I'm sure you can see many companies, all of the tech giants and other companies that I'm sure you're all familiar with. And with that being said, Python is used in every single one that you see to the left here. Now, many of the largest and most successful companies in the world use Python today to provide the world with cutting edge technology that we use daily. And the reason why Python is so preferred is because it has a very simple, easy, and concise syntax when it comes to writing code. Now, to look at this further, let's take a look at Python's use cases. Now, these use cases here are the top used applications that we have in the world today. Now, this doesn't limit it to just these. There are many more. Python has, if not tens, but hundreds of different use cases. But these are the top three based on survey data. Now, Python is a dynamically typed language, which enables us to build real software applications and web applications. So in other words, being able to build back-end and front-end applications. Now, coming in with the largest number here at 55%, 55% of the use case for Python is for data science. So with libraries like Pandas, TensorFlow, NumPy, and SciPy, which are just a few of the most powerful libraries that we have, interestingly enough here, Python is not just used by developers, but is used in many different industries and by many different types of professionals around the world. Now, the next use case we have here is AI and machine learning, which is at 40%. Now, I truly do believe that this number is going to skyrocket as the years go by. And as of 2023, if you're watching this video, well, you know about ChatGPT, which is one of the most amazing and most historical internet breakthroughs that we have apart from the internet. With 100 million users coming in within 3 to 6 months, I do believe that AI technology is just the beginning for it and is only going to continue. And Python sits right in the center of the AI and machine learning space. Now, Python also has dedicated libraries for AI and machine learning for things like computational mathematics to enable advanced computation, data analytics, and much more. Now, the other side of the use case here, which is the front end side, is for web development. And 50% of the use case on that side goes towards front end web development. Now, Python offers an extensive range of tools for web development with popular frameworks like Django and Flask, along with other elaborate standard libraries that also enable things like backend web development for building APIs and server-based technology. Now, the advantages of Python can be seen even further when we take a look at some real-world examples. Now, Python offers a wide range of amazing benefits and opportunities, and a major advantage of Python, as we looked at earlier, is the ability to have simpler syntax. But not only just that, but along with the simpler syntax, we can have the same or even faster code execution with this simpler syntax, which is why it's a go-to and the highest in demand skill set currently for use for developing applications. So, for example, let's say we wanted to extract the first two letters of Python, which will be py, in code. Now, in order for this to work, I'm going to give you a look at some programming languages that you may or may have not heard of, but let's take a look at these three languages together. So we're going to be comparing C#, JavaScript, and Python. So if we wanted to extract the first two letters out of the word Python, which would be py, this is what it looks like in C#. This is what it looks like in JavaScript. And this is what the syntax is for Python. So immediately here, you can see that we have a much shorter syntax to produce the same result. Okay, we can see a lot less letters as we go from right to left. Now let's take a look at execution time. Now these execution times are based on 100 repetitions of running this code, but the execution time for extracting the first two letters in the word Python is 112 milliseconds for C#, 202 milliseconds for JavaScript, and 23 milliseconds. So almost 5 times less than the next largest execution time for Python. And again, these executions are based on running this 100 times over. Okay. So you can see here why Python is such a powerful and important language in not just the world's journey, but for your own personal journey. Becoming a developer doesn't mean you have to be complex. Learning a very simple syntax doesn't make the language itself not as usable or not as useful. Okay. So let's take a summary here. Now, to date, Python is one of the most popular programming languages and the top 10 highest in-demand skill sets that are being looked for by employers because it's easy to use, has a large community of users, is cross-platform enabled, which cross-platform enabled means that we can use it on Windows, we can use it on Mac, we can use it on Linux, and we can still get the same results because the code base doesn't get altered by using a different operating system. Now we have fast execution speeds, as we just looked at earlier. We have it to be easy to read and a large code ecosystem. And not to mention that the US annual average salary is 124,742. And so for you as a developer, specifically as a Python developer, this opens up a great opportunity for you to get paid well and to also build really cool applications that add to society and bring powerful solutions to our world today. I'll see you guys in the next video. Hey guys, and welcome to another video. And in this video, let's take a look at code editors. So one of the questions that I get asked a lot, and this is why I like to teach from questions, is where do I build Python applications? And more than that, I get the question, where do we build applications in general? Now, there are over 100 plus different software applications that Python and many other programming languages can be developed in. So where are the apps built, you may ask? To answer that question, the first aspect we need to look at is development software types. Now, the great thing is that of all those hundreds of software that I'm talking about that you don't actually need to know. We can classify them in two distinct groups. And these two groups are, on our left here, we have what we call integrated development environments, or an integrated development environment, or an IDE. On the other side here, we have a code editor. Now, some people do call it CE. Most of the time, though, funny enough, people use the full word code editor, but for integrated development environments, we just call them IDEs for short. Now, what's the difference here? Now, in order for you to understand the difference, we need to put some definitions in place. So there are many code editing software applications, as we said, and these distinct groups have their own definitions. So I'm going to start off with our integrated development environment, or IDE. And I think that's the last time I'm going to use the word integrated development environment. It's such a mouthful. Anyway, so an IDE is an all-in-one advanced software solution for app development, containing most or all of the features for development. And the key here is at installation. A code editor is an application that has tools that allow you to write and edit code flexibly and efficiently. Now, you're probably wondering, I don't think that definition really helped me. Well, I have expanded it so that we can have a more detailed view on exactly what's going on here. So if we have a look at what exactly we have here, let's take a look at the four main features to look at when making this comparison. Now, there are more, but these are the four main ones that allow us to see a clear distinction between the two. So the first feature we're going to look at is platform. Now, with IDEs, most of the time, they run on Windows and Mac only. Okay, this is a key thing to note. With code editors, though, they run on Windows, Mac, Linux, and also Linux type operating systems, which covers most of the operating systems that exist for computers and laptops. Now, let's talk about tool sets now. Now, with IDEs, they have most of all, if not all, of the advanced writing, editing, testing, and debugging solutions and tools at a point which I call out of the box, which also you can call at installation. Now, with code editors, they're designed to make coding faster and less CPU intensive. So they always have, in their bare bones state, a fraction of the IDE level tool stacks. Now, a tool stack just means a stack or a group of tools that are available inside of a software, usually as a component of that software. And so code editors by design have a lot less features at the beginning when you first install them, or in the stage that I call out of the box. Now let's look at pricing. So IDEs usually have a free and a paid version, which goes anywhere from the basic range all the way up to enterprise level toolkits for users to build with. And so if you're working in a company like some of you will be corporately, if not all of you who want to take the corporate route, and even if you're working with freelance and you want to have cutting edge tools, you'd want to work with the enterprise level toolkit so that you can build the most efficiently with the most tool sets available. Now, with code editors, they are usually free. And to be fair, it's really quite rare for them to have some sort of paid service. Now, the code editors themselves, I haven't seen any till now that are actually you have to pay for. I do see that there are services within the code editor, which we're going to look at in the extension section, that you do or you may have to pay for. Now, again, IDEs, when we're looking at extensions, are out of the box ready, which means that as soon as we have them, everything we need really to get going is there straight away. And so, for example, if we're using an IDE that we want to build some enterprise application, it would be rare for you to be downloading what are called extensions, which in essence are a group of files that have tools in there that can be added on to extend the ability of the software you're using. Okay. Now with code editors, I wouldn't say they rely on extensions as some people may say, but there is a very big need to use them. And the reason, again, if we look at point 2, is because they're designed to be faster and less CPU intensive. So they only have a fraction of the tools that you may need to build out what you're trying to do if you're trying to build a full scale application. Now, many of them that are free, and it's very rare for them to be a paid service. If they are, they're usually some sort of AI assistant or something along those lines. Okay. So in summary, when it comes to using and developing applications in Python or any other programming language, it's always better to look at this from the aspect of which one do I need to build for right now? Both of them are very useful, and IDEs, of course, seem like the go-to option to become a developer. However, code editors are far more efficient tools that I recommend for all of you in every course that you're going to take and every language you're going to learn in the Developers Academy to build your career. Now, the recommended code editor for the rest of this course that we will be using is Visual Studio Code. It is the most robust and the easiest to use and the fastest to get started. So in the next video, let's take a look at how we can get Visual Studio on your computer. Hey people, and welcome to another video. And in this video, I want us to take a look at Visual Studio Code and how you can install it on your computer. Now, for the entirety of all the courses within the Academy, Visual Studio Code is our recommended code editor for all of our code endeavors. So, to install Visual Studio Code onto your PC, the process is pretty simple. Open up your favorite browser, and you can either do a Google search or another search engine of your choice. But what you want to type into the search is Visual Studio Code. Now, please write out the full words Visual Studio Code and not anything else, because Visual Studio Code is not the only software for code editing built by Microsoft. We also have Visual Studio, which is a code IDE, and we want to make sure that we install the right thing. So write out the full words. And when we do this on our search, you should see this blue symbol over here and the words Visual Studio Code. Once you see that, click on the link and follow through onto the next page. Now, after a few seconds, it's going to take you to a page that looks like this. Now, on this page, I believe that this button tracks what operating system you're working with. And so depending on what operating system you're working with, it may say, for example, if you're in a Mac, download for a Mac. I'm currently using a Windows machine, so it says download for Windows. Now, if you don't find this ability on your button and it says download for Windows, but you're on a Mac or Linux or another platform, click on this drop down box over here and you'll be able to find Mac and Linux. And if you still don't see what works for your machine, click on other downloads. Now, the version I recommend for you to install is the stable version. Now, the insiders version, if you want to know, contains all of the features that are available in the stable. Plus, it also has a few experimental features, which over time will be implemented into the stable version. And so this is used for developers who want to explore and expand the limits of using Visual Studio Code. Okay, so once you have that done, all you need to do is click on download. Once you click on download, I want you to open the download installer and follow through with all of the required and recommended settings. If you've done so correctly, you will come up to a window that looks like this. Now, I currently have Visual Studio already installed on this PC. And so when you first open Visual Studio Code, you should have a window that looks like mine. So I'll see you guys in the next video. Take care. Hey guys, and welcome to another video. And in this video, let's take a look at the structure of code editors. Now, I usually get this question asked to me a lot, which is there a right way to write code? And the short answer is yes. Now, why is it a yes? Let's take a look and see why. So there is something that I call the fundamentals of coding. and specifically working with code editors. Now, whilst there are different styles and approaches to code writing, there are 6 fundamental principles that must be consistent in your coding experiences and will be, if you do listen, no matter what your coding style is. Now, for example, we have something called the top-down approach, which is what I call writing the answer before asking the question. And so that is a very popular style of writing code where we build out the end and then we fill in the gaps in between. And this is a coding style. However, within that coding style, the following principles that I'm about to share with you will always be consistent in your experience. The first one is unit testing. The second is debugging. The third is code snippets. The fourth is linting. The fifth is code formatting. And the sixth one is auto-completion. And so these 6 fundamental principles are experiences and processes that occur when coding using a code editor and when you're building your software applications. Okay, people. So let's take a look at variables. Now, a variable is pretty much like a container. If you want to store water in a jug, you have your cup and then you pour your water in. And anytime you want to drink some water, you need to grab your cup. And this is the same thing with variables. So in Python, if you want to declare a variable, we have to create a name. So let's just say we wanted to save our name in a variable. So we give the variable a name, which will be our label, and we set it equal to something. So in this case, I'm going to call myself here just Michael. So we have a variable called Michael. Now on the left-hand side would be our container. On the right-hand side would be the value that's inside of the container. Just like you have a cup and then you have your water or a drink inside of the cup. So there's a relationship here that anytime we want to access my name, we can find name and it'll give us Michael. And if we want to find what Michael is saved as, we can go to name. So with variables, it's a way for us to store information within a program so that we can use it at another time or refer to it at another time. So now if I wanted to print out a piece of information, let's say I just wanted to print out a nice message, I could say print name. Now if I do this, and we're going to give this a run, we're going to go to our terminal here, do our command line as I've taught you, and we're going to type in Python or Python 3 if you're in a Mac, and then the name of the file, so demo.py. And there you go, it says Michael. So these are how variables work. We can store values in here. Now in Python, the variables that we store, we can store over here any data type. Now currently, my name, which is represented as Michael with these speech marks here, is what we call a string variable. Now in the next video, let's take a look at string types and how we can make use of them. See you in the next video. All right, so in this lesson, let's take a look at variables. So what is a variable? Now, a variable is a storage place that we can hold information in. So let's say we wanted to store our name. Now, when we want to create a variable, we need to give it a label. So in this case, I want to call this name to represent my name. And on the right-hand side, I want to represent my name as Michael Roberts. Okay. So on the left here, we have our cup, which is our container. And on the right-hand side, we have our drink or thing to store inside of the container. So anytime in our program, we refer to the word name, the variable name, the value that's going to be retrieved would be Michael Roberts. So we could print this out. So we can call our print function, and instead of just writing a message here, we can just type in name. Now immediately you can see that using a variable compared to just writing a string in here, which is what this type is called, would be a lot more efficient, because now anytime we want to change the name, maybe tomorrow, the name is going to be Andy. We don't have to keep going inside of our print function and opening our speech marks and then writing it in. Gets a bit messy. So a variable is a fantastic way to store information inside of a container that we can refer to anywhere in our program. Now, variables don't only just store names. Now, the type of this variable data is what we call a string. So this is a string data type. Now, variables can store any type that we give it. So let's say, for example, I wanted to store Andy's age. So I want to put in here age, and we're going to put in 28. So if I wanted to print out the name of Andy, I can simply plug in name here as I have it. And then at the bottom on our terminal, we can simply call Python or Python 3 if you're in a Mac or Linux, and the name of our file, which is demo.py, and press enter. And you see, shows Andy on the screen. Equally, I can do the same thing and plug in age. If I do so, run the same thing. So we're going to call Python demo.py, press enter, and there you go, we have 28. Now, repetitively writing Python and then demo.py may be becoming tedious to you, so I quickly want to show you a way that you can speed up how your code runs. Now, on the top right here, I have a play button which says run code. Now, if you don't see this on your Visual Studio Code terminal window, I want you to follow me very quickly before we move on to the next video on how you can make sure that you can run your code on automation. So if you go back to the extensions tab, we're going to get rid of Python, and I want you to type in code runner. Now, code runner is a very powerful tool and a very, very handy tool to run code without having to continuously write the name of your file and Python. Okay. Right here, we have Code Runner, which is, as you can see, downloaded by 24.5 million people. Now, over here, you can see that there's a very long list of different programming languages that you can use with this, which includes Python here. So I want you to click on Code Runner and install it. Once it's installed, it may ask you to restart your VS Code again. By now, you're used to the drill. It will only take a few seconds and bring you straight back to where you left off. Now, once that's happened, before you didn't have the play button, you will have the play button here now. And so instead of having to write Python, we can simply just run our code as follows like this. So we just click on the button and you see over here, it gives us our value. Now, the only difference is that when the code runs here, it gives us a read-only version. Okay. We can't interact with anything. We just have our code running and that is it. All right, guys. So in the next video, let's take a look into a bit more detail about this string data type. See you in the next video. So let's take a look at the string data type and see what exactly they do and how we can work with them. Now, again, let's say we wanted to store some information about a location. So I'm going to call this location, and I'm going to set this to be London, which is where I'm from. If you can tell by my accent, I'm a Londoner. All right. Now, with strings, we can represent information that is alphanumerical. So we can also represent, for example, an email. So in here, we can say example@hotmail.com. The way that we define a string is to have these two speech marks
one on the left and one on the right. Now, when you put your speech marks in, if you just press the shift key and click on the speech mark, you'll see that immediately two speech marks appear, which is very handy with our cursor in the middle. So we can just fill in information here. Now, strings, by definition, are actually what we call an array of characters, which means that when our computer looks at our variables, location, and email, it looks at the values that are contained inside, it actually sees them as a list of characters. And for that reason, we can use properties that exist in Python, which is the ability to select a single or a range of items within a specific word. So for example, let's say I just wanted to print out the first three letters of location. So what I can do is I can get the print function here. And now this time, instead of actually just calling the variable name location, I'm going to open up these square brackets here, which are a very special tool that we can use. And in here, we can describe the position or the index of our words. Now, again, because these are what we call an array of characters, each of these characters are individually counted and monitored by our program. So L would be index 0. So I'm going to put this here. O would be index 1, N 2, 3 would be the D, 4 would be O, and finally N would be 5. So we have 6 values, and the index position starts from 0. So if we wanted to print out LON, I want to show you here what we do. So first we start off with the first location. Now at the end here, if we put the value 3, okay, this is an important point, it's going to print out everything apart from 3. So it's almost like saying from 0 to anything less than 3, which means 0, 1, and 2 positions will be printed. So if I plug in 3 here and we run this from our code runner now, up here, you can see it prints out LON. Now, apart from that, we can also print out other useful pieces of information. So let's just say we wanted to print out the last value at the end of our string here. If we plug in a -1, which is something which is special to Python because of the way Python works, it should print out the last character. So I'm going to put this here, print out the last character of our string. So if we run this, we should see N at the end. And you can see right here, it prints out N. So working with strings gives us many opportunities to manipulate and control what information we display in our program and on our terminal. Now, in the next video, I want us to take a look at a few more functionalities that exist with strings, which we call string methods. I'll see you there. Take care. All right, guys, welcome back. Well done if you've made it this far. I'm really proud of you. Let's continue. So, in this lesson, I want us to look at how we can represent variables and create custom messages in our print function. Now, so far, we've had a good experience using string methods and also using the length function. Now, what we want to do here is learn the ways that we can plug in variables to our print and print custom message. So I'm going to go over here. I'm going to create a new name, and I'm going to call this name Andrew John. Okay. Now, also, let's create an age, and we're going to set this to age 24. Now, notice when I use speech marks to represent this age right here, this is actually a string, even though I've written a number. Now, there is a function that we can use to test out and know what type we have. So if we go over to print and we type in type here, whatever we pass inside of here, this time Python is going to return to us what data type it is. So if I plug in age right here and I run this, notice what it says. It says we have a class called string. So in essence, the type that we have here is a string. Now, if I take off the speech marks over here and run this again, now it says that our class is an integer. Okay, so a whole number. So our speech marks do make a difference as to what type we have operating. Okay, so I'm going to put the speech marks back on. Now, let's say we wanted to have a custom message for someone who has a name and an age. Now, there are two ways to do this. The first way is through a method called concatenation. So we can say, for example, hello, and then we can use the plus sign here and add the variable. Now, when we do this, what's going to happen is that hello and then the name variable will run, and it should say, hello, Andrew John. So let's test this out. Now you notice that we have a little bit of an issue. There's some spacing here that hasn't happened. Now, when we use our speech marks, any space we leave here actually reflects in our print function. So if I leave one space here and I run this again, you notice now we have some space because it's being read from over here. So even though it seems like, of course, there's nothing here, there is something here, which is white space, and it is counted. So if you wanted to send a message and say, hello, Andrew John, it is so nice to meet you. Okay, that's what we can do here. So let's try that. Now, again, if we run this as it is without the space, I just want to show you what's going to happen. Now, we have an error here from our linter. If anyone picked up on that, well done. Let's see what our linter says. It says that our bracket was not closed. Now, when you're looking at this, you're probably wondering, wait, the brackets are closed. We have one here and one at the end. When you see an error like this and your brackets are closed, it usually means that you've missed out some sort of symbol. In this case, because we're doing concatenation, we forgot to put a plus sign here to connect name to this sentence. And you see, as soon as I do that, the error goes away. Now, if we run this as it is, we're going to get the same issue here because we're not going to have the space. So I'm going to put a space here. And if we run this, here we go. You see, we have a message that says, hello, Andrew John. It is so nice to meet you. Okay. Now we can continue and add more information. We can say now don't forget your speech marks. Your current age is, and then leave a space, add a plus sign and say age. Now this method here is what we call concatenation. Okay. Concatenating means that we're joining words and variables together in a print function, or we could save this in a variable also, and we're printing it to the screen. So instead of doing it here, which we've done, we can also take this entire expression as we have it, okay, and save this in a variable and do the same thing. Now I'm going to leave it here in the print function for now, and I want to show you a much better way to do this. And this is what we call print formatting. So with print formatting, we have a much easier and cleaner way to represent this code. So what we can do is we can go for our print function. Now, when we do our print function, I want you to follow along with me. We want to place an F here and then put our speech marks. Now, when this F turns blue, that means you've got things right where you need them to be. And now with this format over here, it means we can actually write our code in here and our variables and strings without the plus signs. So I'll show you a demonstration. So in here, we can type in hello. Now, if we want to plug in the name, all we have to do is get our curly braces, which are these outside here. This is what they look like outside of the print function. Let's pop them in. And you see, right in here, we can plug in our variable. So right here, I'm going to plug in name. And you see name lights up blue. Now, if we leave a space here, it's going to recognize the space just like what we've done with our speech marks here. And then we can continue. So we can say, it is so nice to meet you. Okay, full stop. And we can say your current age is. Now, what we can do here is leave a space, curly braces again this time, and plug in the age. Now, if we do this, I'm going to add one more thing at the end. So I'm just going to put here plus C, which means this is concatenation. And over here, I'm just going to leave a little bit of space and say this is formatting and leave an F, so that when we look at the terminal, we'll be able to see them both. So if this is done correctly, let's give this a run and see. Here you go. Take a look, guys. So we have the exact same message, and you can see that the bottom one is immediately cleaner because we can write our code as a sentence. And this is what we call print formatting. So when we want to represent strings inside of our print function, this is the #1 way to go in order for us to represent data. Okay, so I'll see you in the next video. Take care. All right, my people, welcome back to another video. Now, in the previous video, we took a look at how we can display our variables and our string words all in one place. So we use concatenation and we also use print formatting, and that was a really good time. Now, out of the two methods that I've taught you, the optimal method and the one that is widely used in real-world applications is print formatting. Concatenation, although it's good, comes up with a few issues in terms of managing our spacing and just the sheer length of the amount of writing we have to do compared to our print formatting. So I'm actually going to delete this line right here. Now, I still have an issue because if you were to run this code right now, from a code perspective, it works fantastically well. We have no errors, no issues with any formatting or linting problems or whatever may come up. We have absolutely zero of those. But when it comes to readability of our code, we have a bit of an issue here because we have a sentence here that has a full stop, and then we have a new line which continues on the same level as the first line. Now, for readability purposes, this wouldn't be good if we were displaying this to a user who was using our Python application. And this is where the use of something called an escape character becomes highly beneficial. So over here, you can follow along with me, leave some space, and write the word escape character. Now, escape characters, plural, are symbols that we can use to tell Python, make sure there's a capital P here for Python. They are symbols that we can use to tell Python that we want to modify the way our sentences appear on the screen. And that's as simple as it gets. Now, there are many different escape characters that we can use, and I want to start off with fixing the problem that we have. Now, to use an escape character, the escape character that starts off the process of representing data is a backslash. Now, you keep hearing me say escape. Now, the escape doesn't mean we're running away from our print function. In this context, what it means is that we're escaping out of our string sequence to modify or represent information in a specific way. So if we want to create a new line so that the first line, hello, Andrew John, appears on the first line and your current age is on the second line, we hit the backslash and then we hit N. And once you do that, you notice that we have a slightly different color for this symbol here. Okay, so \n is the way that we can cause our printing of our statement to appear on 2 lines instead of 1. So let's run this together. We'll hit the run and take a look. You see it says, hello, Andrew John. It's so nice to meet you, full stop. And then we get a new line that says, your current age is 24. Now, this is another reason why using the print formatter compared to concatenation is just no competition at all, because it's so easy to plug in things like these without having to worry too much about having the incorrect spacing. Okay, so let's write this here and tab along as we're going. I'm going to write this right here. So a new line is \n. Now we can have other characters. Let's say, for example, we wanted to add speech marks around the name Andrew John. Now to do that, again, we're going to have to escape out of our escape character feature here. And we're going to put a / and we're going to put a \/ and a speech mark here. Now, if we do 1, let's run this here. You see that now we have a speech mark here. Now, this escape character initializer means that we escape out of the string for a moment, and then we can put in our own way of formatting this string. So if you want to put 2 speech marks, what you're going to have to do here is you put another \, right? And then what you want to do is put your speech mark here. So when you put your speech mark over here, notice we have these lighting of orange colors. So we have the first \ and then the speech mark, and then we have a \ over here, and then one more speech mark to close our speech mark representation. So if we run this now, what we're going to have is, hello, speech marks, Andrew John. It is so nice to meet you. Okay, so we have another one here, which is our speech marks. And again, it starts off with the escape character and then speech mark. Now, what I'm going to do here is that if you want to put in a value here, so I'm just going to put the word value here. And if you want to add the second speech mark, we do the reverse. We do another \ and speech mark to end it right over here. And this is how we can put speech marks around a word. Okay. Now we have others. Okay. So if we want to add a \, okay, we can simply just do one escape character and then the \. So let's say we wanted to put the age in a \, we can do / twice. And you see, we see the escape character show up. If we do it again, you see it shows up here. So now we should see your current age is \24 and then another \ to close it. So let's give this a run and see. Run our code. And boom. And you see it says your current age is \24 \. Okay. So these are the escape characters that we have available when writing our code. Now I want you to give this a try. I want you to represent your own sentence and make use of all of these different escape characters that I've shown you. And I'll catch you guys in the next video. Everybody take care and have a great day. Hey my people, and welcome back to another video and tutorial. Now in this video, I want us to take a look at working with numbers in Python. Now the number data type has 3 subcategories within it. And the whole idea of the number type and all the other types we've looked at so far is just for one thing. It's to be able to model human activity in our programs. All of the programming languages that exist in the world, they all aim to model human activity as accurately as possible to our world. Now, within the number type that we have in Python, we have the first one, which aims to model whole numbers. Now, whole numbers, for example, can represent an age. So let's say, for example, you're 18. Okay, now I know some of you like to say stuff like I'm 18 and a half and 18 and 3/4, but on paper, in official documentation, you're officially just 18 until you go to your 19th birthday. All right. So whole numbers are what we have in the real world. In Python, we call these integers. Integers. So these are integer types within the category of numbers. Now, we also have decimal numbers, which I'm sure all of you are familiar with in some form or fashion. The most common one will be, for example, something like a price. So in Python, we have an equivalent to represent decimal numbers, which is a data type called a float. Now, the final type we have is algebraic expressions. And these are used to express or describe mathematical functionalities. Now, within Python, we call these, just as the name is here, algebraic expressions. Now, there isn't any specific type created for algebraic expressions, but what there is that in Python, we have the capabilities of expressing such values. Okay, so let's take a look at whole numbers. So let's save a variable called age, and I'm going to call the value 18. Now, for us to see these types in action, I'm also going to save another variable called price. And let's just say this is the price of an Xbox, which should be about £249.99. And finally, the algebraic expression, which we'll look at in a moment. But for now, before we get there, I want us to take a look at just the age and price. Now, if we use the print keyword, we have a special functionality called type, which is going to return to us the type, specifically the data type of the variable data that is stored in any of the variables that we pass it. So in this case, it takes one parameter, and let's say we passed in the age here. Now we can print this on the terminal and it should return us our type. So if you follow through, it says that the type we have is an int. So an integer is called an int for short, and that means we're dealing with whole numbers. Now, to test this to make sure that it's working, if I add a 0.0 here, now to us as humans, 18.0 and 18 is the same amount in value. It might not look the same, but in terms of amount and value, it is the same. Now, if I run this again, take a look on your terminal, and on my terminal, you'll see it says class is a float. So by adding a decimal number here, it converts age from being an integer to a float. And if you hover over it, you see type float. So these are the ways that Python helps us to represent numbers as whole numbers or decimal numbers in our program. Now, what about algebraic expressions? Now, with an algebraic expression, I'm going to leave a note up here so that you can follow along with me. Algebraic expressions describe mathematical functions. So let's just call this math function right here. Now, this time I'm using camel case, and we're going to create an expression. Now, usually with algebraic expressions, they involve a mixture of numbers and letters. And usually, for example, it would be an I or an X to describe some sort of value, which has usually a changing amount depending on the situation. Like, for example, when we're drawing a trend line, a lot of times we used to have the mx plus c, which was to describe a straight line. So we can take use of that. I'm going to put here 2x plus 1. Now notice, when I try to express this algebraic expression, we have an error here. And the error is in red, which comes from pylons that says that statements must be separated by new lines or semicolons. So, as you can see here, we can't actually express algebraic expressions directly in this manner. Now, to get this, I want you to see here that 2x is the same as saying 2 times x. Now, in fact, when it comes to representing a multiplication or a times in, we actually use an asterisk. Okay. Now, these two things are the same, 2x and 2 times x. They mean the same thing. So in order for this to work, we have to save another value called x over here. I'm going to just set this to 10. And you still see that we have an issue. So the next thing that we need to do is that we actually need to create brackets around here first. And then we need to add our asterisk here, which represents the multiplication. And so now we have 2x plus 1, which is the same as saying 2 times x plus 1. Now with these brackets here, for those of you who may be maths heads, will probably be wondering, now does the brackets get recognized in the order of processing our mathematical expression? And the answer is yes. So in Python, we have a concept that is derived from maths called BIDMAS, which stands for brackets, indices, which we also can call exponents, division, multiplication, addition, and finally subtraction. Now, BIDMAS, for those of you who may not know what this is, represents the order in which we process mathematical equations. So in this case, what we have with math function, the brackets here let Python know that we should times 2 by whatever x is first, and then from that result, we add 1. And this is an important point because when it comes to mathematical functions, the placement of the brackets can actually change their value that we're trying to demonstrate here or what we're looking at. So for example here, now, for those of you who have already done the calculation, this should equal 21 because it will be 2 times 10, which is 20. And then we're going to add 1. So that should equal to 21. Now, by shifting the placement of the brackets, we can get completely different results. And I'm going to show you both. So first, let's print math function. Okay. And let's go to the bottom here and you see it says 21. Now, if we shift our brackets, so now I'm going to say this is math function 2. And what we're going to do here, we're going to do 2 times x plus 1. But this time, we're going to wrap the brackets around the x plus 1 here. Now, if we print this and we take a look at this, now, I want to give you guys all a quiz. I want to make sure that our formatting for our print is nice. So I want you guys to take a few seconds. I want you to pause here and use what I taught you about print formatting. And I want you to write a custom message for each of these print functions here. Okay. And then plug in the value also and present it on the screen. I give you a few seconds to do that, and then we'll come back and look at the solution. Okay. So I hope you guys enjoyed doing that and you were able to get some good results. Now, the first thing we need to do, I'll start off at the top here, is we're going to need to call our f function and then put our speech marks here. Now, for now, I'm going to cut this away and we just want to leave a message. So let's just say this is math capital function 1. The results are, and over here, remember, we put our curly braces and then we can plug in math function. And then we can do the same thing down here. We can say F, speech marks. This is math function 2. Let's put this is here. And then what we can do is we can say the results are space. And then in here, we can put math function 2. So this looks a lot prettier. Let's see what this does on our terminal. I'm going to comment this out so that we can just see purely what we've got here. Let's go and do that. Comment it out. And then let's give this a run. So notice with our first math function, with our brackets around the 2 times x, we get 21. Now with our brackets around the x plus 1 first, we get 22. And so you can see that the placement of brackets is determined from here to the execution. And whatever we put in here for our brackets will determine the output that we get down here. And so Python has used the BIDMAS system to calculate our values. So in the next video, let's take a look at mathematical operations. I'll see you in the next video. Hey my people, and welcome back. Now in the previous video, we took a look at working with the data type number within Python and how it's connected to the real world with all of the different data types that exist in that umbrella. So for example, integers to represent an age, so we can have an age equals to 20. Let's get the right formatting on that. Or we can say the height of someone, which let's say is 1.71 centimeters or meters. So hopefully it's not centimeters, eh? But anyway, we can represent different types of data through our different data types that exist in the number data type in Python. Now, also algebraic expressions, we can save a variable like x equals to 10, and then our expression, we can set something out. Let's say we wanted to represent over here 2x plus 1, which is a very common expression that I used to see in statistics all the time in school. So we can represent 2 times x and then set that plus 1 to represent our algebraic expression. So there is no type for algebraic expressions, but Python is fully capable of allowing us to create our own custom expressions. So in this video, I want us to take a further look into mathematical operations. Now, I call them math operations or math ops for short. Now, when we use math operations and all of the mathematical operations available to our disposal, which are many, we want to make sure that we always have good context for why we're using them, and also make sure that we have the right setup with our variables. So for example, let's just say we wanted to represent each of these here with the print function. So I'm going to save 2 values here. I'm going to call this one y and set that equal to 12. And then another value, which is going to be our x here. I'm going to take it, change it to 3. So we have y and x, or x and y. Okay, and these are our values that we're going to be working with in order for us to work with the information we have here. Now, I wanted to point out something really important with the way that Python and other programming languages work, but we're dealing with Python right now, so specifically in Python. And if you notice here that even though x exists down here, we have an underline, which is a warning that says x is not defined. And so this reveals how Python reads our code. Python reads our code line by line from one end to the other before going to the next line. And the Python interpreter is going to take on the job to make sure that we have all of our variables in the right places, and they do exist. If they don't, when it runs, we'll get into errors. Now, pylons make sure that with our linting, we don't have any of these errors. So if I was to cut x and put it back above here, all of a sudden the error goes away. And so this is just an important point I wanted to point out to you when it comes to dealing with these values. All right, so let's just say we've got A, we'll set that to 12, and we'll do B so that we don't get that error and keep it here. So we have our values A and B. Now to represent an indice, now another way to see an indice is a power, or what we call an exponent. Exponent. So these values are values that are to the power of something. So let's say we wanted to have 3 to the power of 2. What we could do is we put 3 here. And then to represent to the power of, we do a double asterisk. So 3 to the power of 2. Now, if we've done this correctly, it should give us 9. Fingers crossed, and let's run the code. And hey, you see that we have 9. So if we take a look at what we have with our expression here, this is how we represent an indice expression. and this is an indice operation. So the next one we have is division. Now there are two ways of describing division. We have the first way, which is, let's do this here. So if we wanted to divide 12 by 3, which we can simply do A divided by B. Now for my math heads out there, what is 12 divided by 3? Okay, if you've guessed it correct, it should be 4. Now, if we do a division operation in this manner, this division is going to return a literal value of type float or integer. And this is an important point here. Now, because 12 divides perfectly into 3, right here, we should get 4 on the terminal without any decimal points or anything like that. So if we run this here, you see, we get 4. But notice when we do this division, we get 4.0. Now, right over here, this 4.0, if we were to store this in a variable and look at the type, we will know that this would be called a float. So by default, when you do division, you either get a literal number. Now, when you get the integer, it would be, for example, if you divide 1 by 1. But apart from that, if you divide any number, even if it's 2 integer numbers by each other, automatically the result would be a float. So if you want to represent some more values here, now if we did 3 divided by 12, which is 0.4, now let's make it a bit more cheeky. Let's do 3 divided by 14. Now if I do a double slash over here, this is going to strictly return a integer, in essence, whole number value. Now to compare this, I'm going to do another one down here, and this print, I'm going to put here 3 divided by 14. Okay? If we put these two things together, this is going to return a float. So let's take a look. Now, for the sake of this, I'm going to comment out these two so that it's not in your way. You can follow along and do the same thing. Let's do that over here and one over here. Okay? So let's run this and take a look. Now, the first one says that 3 divided by 14 is in actual fact 0, which is not right. Okay? And this double forward slash, okay, causes our division to strictly return a whole number. Now, because of rounding, anything that is at a decimal point and is 5 or more gets rounded up to 1. Anything less than 5 gets rounded down to 0. Okay, so we have a little bit of a rounding effect taking place when we use this double forward slash. Now, in our second print function here, 3 divided by 14 is actually 0.2 and all of these numbers afterwards. So in terms of accuracy, the floating point number is going to be more accurate. And so with this double forward slash, when you use it, you have to be very careful because using it in a wrong application will cause you to have very different numbers, which could really mess up a mathematical setup of an equation that you need maybe to carry out some sort of process in your application. Now, if I uncomment this one right here, which was A divided by B, so in essence, 12 divided by 3, we have 4. Now, we had 4.0 when we used a single forward slash. Now, if we use a double, take a look. Now we go from 4.0 to just simply 4. And so this is the power of using our double slash here. And this is one of the cases where if you wanted to make sure you strictly return a integer type, you can use the double slash to do so. Okay. So always remember, I'm going to write it here. By default, the division operator of even two whole numbers, so integer numbers, returns a decimal number. In other words, a float. So this is something important to remember. So moving on, now when it comes to working with multiplication, the process is pretty much the same. So if we wanted to multiply a by b, we use the asterisk and put b here. I'll take off the white space. Now 12 times 3 is 36. So we should have 36 as an answer. So let's take a look. Wonderful, we have 36. Now for addition, we still have the same math operator like we do in the real world, which is going to be a plus b. Okay, and this is our addition. Now a plus b would give us 15. And then we have our subtraction, which will be a minus b. That will give us 9. So this is our subtraction. So these are the basic mathematical operations we have. Now we also have special math operations. Okay. So we're going to go here and put in our special operations. Now, sometimes we have to do mathematical operations that are outside the scope of BidMaths, but they're inside of the scope of maths. So for example, let's say we wanted to find the remainder of two numbers. So find the remainder. Now I'm going to slightly alter these numbers so that we have two numbers that are a little bit more difficult to find some whole division through. So let's do 17 and 5. Okay, so down here, if we wanted to find what will be the remainder of dividing 17 with 5, because we know that with most odd numbers, if you divide an odd number by an odd number, you're always going to have a remainder, which means we're going to have some numbers left after dividing. Now, in this case, if we did any sort of operation to do with a remainder, we use the percentage key, which represents modulus. So a modulus b, okay, should return us the remainder that is left behind from calculating how many times is 5 divisible by 17. So if we do this correctly, now all of these numbers here are going to be wacky. So I'm going to put these off because now we're going to get completely different results from what we looked at. So I'm going to quickly comment these out. Let's put that here, here. Right over here. Bam, bam, and bam. So once we have this, now I've just done too many comments, so we need to put that back here. And let's run this. Here you go. And you see, it says we have modulus 2. Now, how is that calculation happening? Well, we know that the closest thing, for example, so we have 5 plus another 5 plus another 5 equals to 15. So the maximum amount of divisions we can do would be to do 15 divided by 3. Now, the remainder that is left would be what we can't divide by, which is 17 divided by 15, which equals to 2. So this would be 3 remainder 2. Now, modulus specifically provides us just the remainder. So that means it will be 2. Now, it's very common to use a modulus function to figure out certain numbers. And in our trading programming course, when we take a look at how we can use modulus to calculate important values, like our position size, our lot size, and etc., it becomes such a useful and handy tool to work out crucial pieces of maths. Okay, so that is our modulus tool. Now, I want you to give it a shot in your own time, practice everything I've shown you, and then you can move on to the next video. See you guys there. Hey people, and welcome back to another video. And in this lesson, I want to take you on an introductory tour into the built-in modules and also the built-in functions that Python offers us to enhance our abilities of working with numbers. Now to import a module, now a module essentially here, I want to leave you a note. A module is a folder that contains useful code that we can use for our applications. So up here, we can hit the import key, which is a special keyword that tells Python that, hey, we would like to extract some data from somewhere. Can you bring it in for us to specifically this file? Now, in this case, we want to import a very special module, which is built in, which means it exists in Python as soon as we open the wrapper of this gift to the world. And we type in math right here. Now you see that it will light up green, which is indicative of the fact that this is a module, as you can see. And look at what this says. It says this module provides access to the mathematical functions defined by the C standard, which is the C programming language. So how do we make use of this? Now, if I call math and I put dots, you notice that there's a whole list of different mathematical operations that we can make use of. So for example, we have pi, which is the constant that gives us the value for pi. If we go up a bit here, you can see we have these special values. Now we have one called math.ceil or ceiling, which in essence rounds up values that we pass in. We have square root, which whatever value we put in, it square roots the value for us. I'll give you an example right over here. So let's save a variable and we're just going to call this square root. Now I'm using camel case this time. Now for us to make this work, it takes in one value, which is going to be the value we want to square root. So let's do a quick mental math test with everyone. What is the square root of 25, guys? Now, whilst I'm writing the print function, if you've got this correctly, the answer should be 5. So let's print this and see what we get. And bam, you can see here that the square root of 25 is 5. Now notice again, when we use this math.square root method, it returns our value as a float, even though we passed in an integer. Okay, similar to what we had with the division. Let's give another one. What is the square root of 144? I'm going to give you guys a few seconds. Okay, so if you got this right, the answer should be 12. So let's have a look and you see we have 12.0. So this is some of the many functionalities that are available to us to extend what we can do with our maths operations in this module called math. Now we also have functions here. So let's talk about our functions. Now inside of our scenarios that we create when it comes to building out our applications, there are times where we would need to use things that may not exist in the common scope of our human experience. So for example, a very strange mathematical calculation to calculate, okay, how many footsteps it will take to reach the moon, let's just say. So something like that, or to have any sort of calculation like this, we're going to need to figure that out with other functions. So we have a function called absolute, and this function converts anything that we put in here from a negative value to a positive value. So for example, let's say we have a value here, and I'm going to set this to -3. So if I pass in value over here and I print this, it should give us a +3. So let's take a look, and you see we have +3. So this is what we have in the absolute function. Now, anything that you don't find, and this is the rule of thumb I want to go down the road with, anything you don't find as built-in functions within Python without having to import anything from a module, you'll find it in the maths module. And this is the way that we can work with values. So let's say, for example, in here, we wanted to do a math and we wanted to get the power of something. So if we want to get the power of something, we go for POW. Now over here, POW, whatever value we have, it's going to return x to the power of y, as you can see over here. So let's say we wanted to get to the power of value now, minus 3 to the power of 2 in this case, or to the power of whatever value. It's going to return us, what do you think? Someone tell me the answer, even though I can't see you. All right. The answer should be, now you see, we have an issue here, and I want to show you something. Now over here, this power of accepts 2 arguments. Now, when I said to you guys to the power of 2, some of you are saying, yeah, it's going to be 9. But this is where I want to open up your eyes to see how our methodologies work. So certain functions take only 1 argument, which will be 1 value. But then there are others which take more. And in this case, it makes sense because even though we're given the value, this function doesn't know what to do to the power of. Could be the power of infinity, we don't know. So we place a comma here, and then over here it says supports a float or an index, and here is asking us for what we want to put or how much we want to go to the power of. So let's say we wanted to do minus 3 to the power of 2. We place 2 in here. Okay. Now notice in this case, before I continue, that when we got this error, we didn't actually have any issues in the linter. There was no issue detected by the linter. But when we ran our code, the Python interpreter gave us a traceback message, which is an error message that lets us know that, hey, you have an issue. And this is why I want to say this to you, that the linter doesn't pick up on every error you make. The linter's focus is on syntactical errors. And syntactically speaking, we had nothing wrong with our code. But from a code perspective, we did have an issue because we forgot to pass in 1 argument over here. So if we run this again, here you go, we have 9. And this is an introductory look into how we can work with our built-in module maths or math, and also work with built-in functions to work with numbers. So I'll see you guys in the next video. Everybody take care and have a great day. Hey my people, and welcome back to another video. And in this video, I want us to take a look at a very important aspect of working with Python. Now, whether we're working with numbers or strings or any type, I'm sure you've probably been wondering by now, are we always going to just keep on printing information to the screen from our code? Is there not any way that we can input our own data and have the choice over what we print to the screen? Now, in fact, there is. And the way that we can do that is by a very special function called input. Now, the input function allows us, as the name entails, to input data from the outside. Now, I'm going to show you a demonstration of how this works. So let's say, for example, instead of doing all the maths ourselves, let's say we wanted to carry out a process and do some maths ourselves. So I'm going to call A right here. Now, if I call this input function over here, in here, it gives us information and asks, would you like to input some information? And the way it does that is by giving us a prompt. So I'll demonstrate here. So let's say we wanted to demonstrate a prompt here and say, what is the first number in your calculation? Okay. Now, if we run this as it is, take a look at what happens, guys. Now, in this terminal over here, I want to say something. Now, in this terminal, at the moment, there isn't any space to write because when we use the code runner over here, I want you to notice that this is read only. So we actually can't write anything to the terminal. Now, another thing I want you to notice is that the stop sign here, usually when we run our code, it runs and then it stops. And before you know it, we're back to just our play button here. But you can see here that the code has not stopped yet because this time the input function in our program is waiting for a response from us, the user who is using this program. Now I'm going to stop this for now, and I want us to go over to our terminal. Now, for this lesson, we want to use the command line version of running Python. So again, if you're in a Windows PC, I want you to type in Python. If you're on a Linux or Mac, I want you to add a 3 at the end. And then we're going to call our app. Mine is called demo.py. And we're going to give this a run. Now take a look here. Now we have this question here that says, what is your first number in your calculation? What is the first number in your calculation? I'm going to pass in 12 here and press enter. Now you see nothing's happened. Now the reason why nothing's happened is because we haven't asked for anything else to happen in our code. So let's beef this up a little bit. Let's say that every time we pass in this number, it prints it to the screen. So on the next line, we're just going to print A. Now when we print A, I want to be very specific here. We're going to be printing the input that was given by the user on line 6. So on line 6 here, when we run our code, we have an input. Now for better understanding, let's just call this user underscore input. And I'm going to take this here, I'm going to copy it and pass it in here. So let's run this again and see what happens. Now, again, don't make the mistake I made. Don't use the code runner. Make sure that you run it from our command line on our terminal. So we want to call Python, and then we want to go for demo.py. Here we go. Now you see, it says, what is the first number in your calculation? I'm going to place in 12. And notice on the second line, it prints out 12. Now, if that's not so clear, let's do this here with our string. And let's say the user's input is, and then we can pass this over here. So let's drop this right in here with our curly braces and put this right here. We go right here. So if we run this again, one more time. Now we run it from here. So Python demo.py and run it here. And let's pass in 12. And you see, it says the user's input is 12. So this is how the input function works. Hey, my people, and welcome back to a new section of our course. Congratulations for making it this far. I'm so proud of you. Keep up the work ethic and keep on pushing in your studies. Now, I'd like to also say, even though you're watching this video, but you know in yourself that some of the stuff I've taught you, you're not completely clear with it, there's no rush and no harm in pausing this video and going back to those sections to make sure you understand everything I've taught so far. Okay? In the academy, everything about us and in my heart, what I really want for you guys is to have quality over quantity. Okay? But again, I'm so proud of you for coming this far. And I want us to kick off this topic with confidence, you feeling assured that you know what you're doing and that you're ready for new challenges. So to kick off this section, I want us to take a look at a very important topic, which is the whole idea of this section, which is called control flow. Now, the concept of control flow is very important in every programming language. And since we're in the Python devs course, I want us to take a look at control flow from the angle of Python. So I'm going to create a new file, but equally, if you have all of your data that we've been going through, all of your files in this folder, I've called mine demo, whichever one you've called, calls yours to be called, or called yours to be called. What you can do is create a new folder, and then inside of that folder, you can create a new file. So I'm creating a new file here, calling it control.py. And let's take a look at control flow. So control flow, what is it by definition? Control flow is the ability of your code to control the outputs of your code based on the inputs that come in to your code. Okay. So control flow is the ability of your code to control the outputs of your code based on the inputs that come into your code. So from the terminologies I'm using over here, the key word is the inputs and the outputs. Now, control flow is all about being able to control how our code runs and how it executes depending on the information we pass to our code. Now, in this section, I want us to kick off with looking at a very important facet of control flow, which is called comparison operators. Now, this may seem like a big and scary word, but I promise you it's not. Now, from the last lessons we've looked at, you know that anything that has operators has something to do with a symbol, or in this case, symbols, plural. And comparison just means something that we're going to compare one or more things together. Now, by definition here, because you know I like to provide definitions, a comparison operator or comparison operators are symbols in Python that we can use to compare two or more data pieces together. So comparison operator or comparison operators are symbols in Python that we can use to compare two or more data pieces together. Okay, and the key thing here is to come to a decision. And this is really important, this part right here. Now, as we go along in our course, you understand what I mean more, but I want to demonstrate for you what I mean. So I want to take a scenario here, and let's just imagine that we're going to a theme park. Now, if you've ever been to a theme park or to any sort of ride, you know that there is what we call the minimum height requirement. So I'm going to create a variable here. I'm going to call this ride height min to represent the ride's minimum height. And let's set this at 1.4. So this is 1.4 meters, by the way. So the minimum requirement to get onto any of the rides in our theme park is you need to be at least 1.4 meters tall. Now, let's say we have a new customer. So let's just call this customer underscore height. And let's set this to 1.5. Now we can use a comparison operator to model comparing the comparison of the default minimum height, which is 1.4, to the customer's height. Now, I know in a real world scenario, if it's not going to be done with a digital machine, in my days, they just used to make you stand on a piece of paper that's got lines that measure your height, and they just bring like a big red line and mark off your height. And if it crosses the minimum, you can jump on the ride. If not, you're going to have to sit on the bench and eat popcorn until everyone's done having their fun. So let's imagine this is a digital operation and they're going to walk through some scanners that are going to scan their height immediately and give us a result on the computer and let the person who's controlling the ride know exactly what's going on. Now, I like to think in pictures. So if you're inside of this story, just like I am, let's continue to get to how we use comparison operators. So with comparison operators, remember, we need to come to a decision and we need to decide whether the ride height minimum is going to be greater than the customer height, because if it is, we can't let them on the ride. But if the customer's height is greater than the height minimum requirement, then they can be on the ride. So we can model that in our code. So we can say ride height minimum. Now, the first comparison operator I want to show you is the greater than symbol. So we can say, is the ride height minimum greater than the customer height? So this is a question. So if we were to write this out as a sentence in whatever language, I'm speaking in English, so we'll go for English, right? We're asking the question, is the minimum ride height greater than the customer's height? That's the question. Now, the response that we're going to get from Python is not going to be a yes or a no directly. The way Python responds, so the response we get to this comparison is a Boolean data type. Now, Booleans only provide two answers, either true, which means equivalent of a yes, and also is also equivalent to the number 1, and I'll show you why later on, or false, which means no, or it means 0. Now, to prove this to you, I'm going to save this variable, and I'm going to call this our decision. So this is our decision. All right. So let's print out the decision right here, and let's know exactly what we're going to get. So if I run this, let's see what happens. Now, I want you guys to think about this. If this is going to be greater than this, so the height minimum is greater than the custom height, should we get a true or a false, or a yes or a no? Okay, so if you guessed it correctly, let's take a look at the answer, and you see the answer is false. So the result of this comparison is false. Now, there are many different operators that we can work with apart from just greater than. In this case, we can also work with less than. Now, I want you to notice that the direction, especially for things like greater than and less than, is always a confusing topic, which one is which, because when you're reading this in English or in your mind, this is also asking if this customer height is greater than. But I always want you to remember that the beginning always starts with from left to right. So kind of how we read English. So over here, this is greater than. Right here, this means less than. We also have operators here for equals to. So equals to is a double equals, which is different from a single equals. Okay, a double equals means we're asking a question if something is equal to something else. So this is equals to. Okay, now the reverse of this is we use a exclamation mark and it equals, and this means, now I need to put a bit of space here because if you do this, it actually brings up a different kind of error. So what I want to do is I'm going to do it like this, and I'm going to go for using a triple equals here for now, and put one on the other side, and put this inside, just for now. So this triple equals here is just for us if we want to write long sentences as a string, but I just put it here so we can have some space. Now this means not equals to. Okay, not equals to. Okay, this is the next operator that we have here. How do we use this? I'll show you an example. So let's say, for example, we wanted to equate a few numbers. So now that we've looked at equating with numbers, I want to show you in the next section how we can take a look at some more values. So let's take a look. All right, my people, welcome back to another video. Now in this video, I want us to take a look at the types of comparison operators we have. Now, you're well acquainted with one of them, which is the greater than sign that we have here. So this is our greater than operator. So I'm actually going to create a new file for this one. So you can follow along with me. Let's create a new file called operators.py. So we have a few here, and I want to list them out to you. Now, greater than, we know, which is greater than. Now, the value that we're checking with, so item 1, this is going to be the item we check with. So item 1 is the one we're asking the question if this value, okay, is greater than this value. Okay, so the comparison starts from left to right. Whenever you're reading this, always read it from left to right. Okay, then we have less than right over here, which would be item 1 is less than item 2. Right? Now we also have equals to. Now equals to is like this. It will be item 1 is it equal to item 2? Now notice we have a double equal sign and not a single one. Now a single equal sign is we're trying to equate something to something else, which is what we do with variables. But in this case, we're asking a question. We're asking for a Boolean response. And so we use a double equals for that. Now within this section, we also have scenarios. Like for example, let's say we had an age of our user and the user was 19. Now let's say that the minimum age for you to work in Starbucks for whatever reason was also 19. Now with the current operators we have, let's find a decision. Now let's check to see if our user fits our model. So we need to check. Now the best way to do this in readability, now we can do this in several ways, but personally for me, my favorite readability would be we're asking if the age of the user, okay, is greater than the minimum Starbucks age, because if it's greater than, then we know that we'll be able to get our user to work for Starbucks. So if we run this, we get false. But the issue here is that the user is actually fitting the quota for the minimum age. Okay, he might not be greater than 19, he's also 19, but the minimum age is also 19. So we have another operator for this, and this is what we have as greater than or equal to. So by adding another operator here, so greater than or equal to, now if we run this again, we should have a true, because the user's age 19 is the minimum age that is required. So if we run this again, notice we get true. So this is greater than or equals to. And I want to put this here so you can see it, greater than or equals to. So equally, we have less than or equals to. Okay, less than or equals to. Put equals here. Now, less than or equals to is the same question, but just in the opposite direction. So we say less than or equals to. Okay. Now, what about if we want to find out if something is not equal to another thing? So we can use the equals to, but we can also use this one here. So we will say, for example, now I'm going to plug in item 1 and item 2 here. You can do the same so that you can have a visual representation of what we have. Item 2. So if we want to check if something is not equals to, or two things are not equal, we don't always have to ask the same question all the time. Are these two things equal? And then wait for false, which means they're not. We can also do the inverse and say, are these two things not equal? And to do that, we represent it with a exclamation mark and an equal sign. That means not equals to. Okay. So this is some of our main operators in their singular form. Now, the reason why I'm saying some is because when we chain these together, which we'll look at in a moment, then we can create elaborate mazes of checking if one value is equal to another and etc. Okay. Now, the question would be here, what about if we're working with strings? Because so far, Michael, you've been working with numerical values only. So the question is, does strings work here? Now with operators, for comparison, they work on any data type that we give it. Any simple data type, so an integer, a float, a string, they work on all of those. Okay, now with strings though, there is some caveats that I want you to note before the end of this lesson. So I'm going to give you a common example that you may find. So let's, for example, imagine that we had a spelling bee, a digital version as an app, and we wanted to input an answer. And let's say the user is a cute 4-year-old who is working on word association. And so the user puts in the word cat in uppercase because that's what they know to do. So when we're cross-checking this with our system to make sure that they've got the word right, we want to find out if cat is equal to cat. Now, if we print this, I want to show you what we actually get here. Now, to us as humans, cat and cat are the same thing. The only kind of difference in terms of how they look is that one is capitalized, but one is not. But in terms of meaning and the word, cat is cat, whether it's uppercase or lowercase. Now, according to Python, this answer is false. Okay, and I'll prove it to you one more time by removing this. Look at it again. We have false. Now, what's happening here? Now, when we have a comparison of strings, it is still numerical. Now you might be wondering, how is it numerical when we're using strings? I'll explain. Now we have something called ASCII code, which are numerical representations. And I want to write this here for you so that you can make notes of the alphabetical, or let's just put alphanumerical values. Now on our keyboard, we have A, B, C, D, Q, W, E, R, all of these different values. Now our computer doesn't actually see a character called C or a character called A. What it actually sees is the number association to that value. So every time we press, for example, A on the keyboard, there is an associated value that the computer sees, and that's how it returns the value A on the screen. Okay, so the ASCII code is like a table for comparison to a number to a letter between our alphanumerical values and what the number is, or the ASCII code number is for that associated value. Now, this saying false, what this is actually saying is that somewhere one of these two have a greater or a smaller numerical value than another. Now, there's a special function that we can use to find the ASCII code value for a letter. Now, if we want to find the ASCII code value for a letter, we have a special function we can use called ORD, and I'm going to write it here. So when the comparison is taking place, the first letter is what is being compared right here, by the way. So I'm going to go over here and I'm going to print out first an uppercase C, and let's take a look at the value. So when we run this, we have uppercase C here, right? Now, if I wrap this in ORD so that you can see what happens, let's wrap this in ORD. All right, and let's go again. And you see that it gives us the value 67. Now let's do the lowercase one. So if we put a lowercase c over here and run this, take a look, we have 99. Now, numerically speaking, 99 is actually greater than 67. So the reason why we have a false here is because when Python interprets our code and when the computer also works along with Python, it's seeing that 99, which is this value here, is greater than 67. So this statement, it will evaluate to false. Now to prove this, let's change things around. For readability, I'm going to make cat on the left, and then I'm going to put lowercase cat on the right. And we're going to ask a question. We're going to ask if cat is greater than lowercase cat. So let's print word and let's see what we get. So when we print word and we run this, look at that, we get true. So this is how we work with comparison operators. I'll see you guys in the next video. Welcome back, people. So let's take our comparison operators to the next level. Now, by now, you should be acquainted with the different types of operators we have and how to use them. Now, with every single one of these operators, when we were to translate them into a readable sentence, they read out as a question. For example, is the age of this user greater than or equal to the minimum age to work at Starbucks? Okay, so it's easy to visualize or model what we actually are looking for in the real world in our application. So imagine if this was actually a real application in the real world, and the user had to put in their age, our system will check whether their age fits this criteria. If it does, then they can be accepted onto the next stage. If not, then we send a message. So to take our code to the next level, we need to introduce another concept called comparison statements. Now, comparison statements or conditional statements, which is the actual term for them, is what we want to do in order for us to be able to control the different outcomes we can get in our program. So I want us to build an app together. We're going to create an app called Alarm. So this application is going to work on the outputs of what we get based on the inputs. Okay, so I want you to create a new folder called Alarm. We're going to close all of our work we've done so far. And within this alarm, let's make a new file called app.py. Now, for this scenario, I want you to model a real world example in your mind. Let's just imagine we wanted to set a reminder, and the reminder is of a certain time. So let's say that our reminder is that we want our alarm to ring at 12 in the afternoon. Okay. Now, bearing in mind, we're going to be using a 24-hour clock. So what we want to do is we want to create an app that allows us to have a reminder at 12 o'clock every day. And this is, in essence, how real-world applications work. Any alarm you've ever used on your phone, whatever type of phone you have, when the alarm rings, is going to be based on what we're doing right here. So copy along, you can save reminder. Now I've put reminder up here. You can drop it down a bit if you want. But in our reminder, this is what we want to have. This is 12 o'clock. So when it comes to conditional statements, what are they? A conditional statement is simply code that allows us to execute an output based on a comparison between two or more data points. So building on top of what we already have, we know that when we use a comparison operator, we're trying to compare between two data points. Now, the conditional statement is what allows us to actually execute something based on the comparison. So when we get the result, whether it's true, if something has happened, or if it's false, based on this true or false, we can carry out code. Now, the first thing we need to do is we need to work with what we call the if statement. And just like in English, we say, for example, if this happens, then I'll do this. If that happens, then I won't do this. This is what an if statement controls. It controls the outcomes of what happens. So let's say that our reminder is set for 12 o'clock. And let's say that the current time is 11 o'clock. So what we want to do with our alarm is that we don't want our alarm to be blaring every single second of the day, because then that alarm is no good. We only want it to work when it's our time of the day. So we can say if, and then inside of here is where we can put in our conditional statement, which will be a comparison operator. So we can say, in this case, if the current time is greater than or equal to our reminder time, then we want to do something. So we put our colons over here. And if I press enter, look at what happens. Now, in the early videos, I taught you about the PEP8 Python enhancement proposal, which sets out how code formatting happens. And I told you it does happen automatically. So whenever we have an if statement, we are always going to have an indentation, which is going to be exactly 4 spaces from left to right. So this is why we have our mouse keyboard flashing cursor thingy that I call it over here. So we have our line here. So with this line, what we want to do is start writing out the condition. So we can say, for example, if the current time is greater than or equal to the reminder time, we want to print something out. We want to say alarm has triggered. Now, with the greater than or equals to, we will be having an alarm ringing. As soon as it hits 12 o'clock onwards, the alarm is just going to be ringing, which might not be the best thing. Let's say we just want this to ring only at 12 o'clock. Now, I want you guys to change this comparison operator to a better version that we can use. I'm going to give you a few seconds and then I'll come back to the video with you. Okay, so if you run this, first of all, nothing happens, which is great. So that means that the current time is not greater than or equal to the reminder time. Now, in this case, the better operator would be an equals to, because we want to check to see if the current time is equal to the reminder time, because we want our alarm to hit off straight away. As soon as it hits 12 o'clock, it starts to ring. Okay, so let's test this. Let's say that it's been an hour since I've been talking, because I know I talk a lot. And then let's hit 12 o'clock and see what happens. And boom, there you go. So look at that, guys. Now our alarm has triggered. Now the question might be, can we not just do two if statements? One that if the current time is equal to the reminder and one that's not. Now, yes, we can. And this is what we call the else if statement. So just like in any language, if we say, if this happens, then I'll do this. Else, if another thing happens, okay, then we'll do that. This is exactly what an else if statement is. Now, an else if statement in Python specifically is the elif statement. This is what it looks like. So right here, we want to come out of our indentation and we can say elif, and in here, we can say if the current time. Now, a better rendition of this, instead of saying if the current time, for example, is greater than or less than or whatever we want to do, a better rendition to do would be to say not equals to reminder time. Now, in this case, if the current time is not equal to reminder time, we'll say over here, alarm is not triggered. Okay, so let's test this out. Let's say, for example, that the current time is 13 hours, which is 1 o'clock in the afternoon. Let's see what happens. Now look at this. It says alarm is not triggered. Now, if I change this back to 12, okay, current time. Now we have a different execution. So this is the foundation of control flow. We're able to control the output that we have based on the values we have here to carry out different executions of our code on our terminal here. So in the next video, we'll take a look at how we can work with more of these logical statements. See you in the next video. All right, guys, welcome back. Now in this video, let's take a deeper look into conditional statements. Now I want you guys to critically analyze with me here what we have going on. So right now, the operation of our application is that if the current time is equal to our reminder, we're going to print alarm has triggered. And if it's not equal to our current time, then we're going to go for alarm is not triggered. So when we look at these two statements here, the app works perfectly fine. If you run our code right here, you see it works perfectly fine. However, there is a way to make our code more concise and more readable. And it's an additional keyword that we have in the conditional statement scope of things called the else statement. Now, before I actually write the code, I want us to take a look at our scenario here. Now, in this scenario, let's break this down. The first thing about this scenario that we want to look at is that when it comes to the current time being equal to reminder or current time not being equal to reminder, we have only two possible outcomes. The second characteristic here we have about this scenario is that only one outcome can happen at one time. So in essence, we can't have the current time being equal to reminder and not equal to the reminder at the same time. It's not possible because it's not even logical for it to be so. Okay. So when you have a situation, when you have only two possible outcomes and only one of the outcomes can happen at one time, then what we're going to use here, instead of an else if, we would use an else statement. Now, the else statement is pretty special because we don't actually need to put any condition in here. The else statement, if we were to read this as a phrase, now my first language is English, so I'm going to read it in this phrase, it would be, if the current time is equal to reminder, print an alarm. Otherwise, print alarm is not triggered. That's how it reads in English. So right over here, what I'm going to do is I'm going to go for print alarm is not triggered. So right over here, our code will be more concise because we don't actually have to say if current time is not equal to reminder. The else statement acknowledges that if this is not happening or this condition is not true, then do this. So I'm going to cut this off and drop this here. So let's run the code and make sure this is working. So right here, alarm has triggered because the reminder time is equal to the current time. Let's choose a different time. Let's say that our reminder time is now 1 o'clock because we want to sleep for another hour and the alarm tried to go off and we don't want that. So if we give this a run right here, look, the alarm is not triggered. So the question will be, what about an else if statement? When do we use an else if statement, the elif? So to use an elif statement, I'm going to give you the key as to what to do. We want to use the else if statement if we have more than two possible outcomes. Now, what example can that be? Now, let's just think about, for example, a sport like, for example, football. Okay, whether it's US football or American football. Now, in this scenario here, let's do an analysis. What's going on? So let's go over here and put scenario number 2. In this scenario, you can either win, you could lose, or it can be a draw or a tie. Okay, let's put tie slash here. So right here, we have 3 valid potential outcomes. Now, in this second scenario here that we're looking at, what else can we say? So I'll put number 1 over here. We'll put number 2 right here. The other thing we can say is that only one of these outcomes can happen at one time. So in a scenario like this, we would choose an else if statement over a else statement because we want to make sure that we can describe each of these scenarios accurately. So this is the difference between using an else if and an else statement. So in the next video, let's take a look at how we can refactor our code to make it even simpler. So I'll see you guys in the next video. All right, people. So let me show you how we can turn our if and else statement that we have here into a more concise form. Now, what we're doing here is we're creating a ternary operator. So for us to do this, I'm going to declare a variable called alarm. And within this variable, I'm going to lay out how we declare a ternary operator. So first, what we have to do here is we want to put here the outcome we want if our statement is true. So in this case, we want to print out a message that says alarm has triggered. Next, we need to write out the condition of this if statement or the statement that should evaluate to being true. So in this case, we want to say the alarm has triggered if current time equals to the reminder. Now, the final thing we have to do here is we need to set out the premise of what happens if this is not true. So right here, we'll say else. Now, in this case, if the current time is not equal to the reminder time, then we want alarm is not triggered. Okay, so let's break this down. I'll put it down here. So what's the first step? So step number one right here is we need to declare the outcome if the if statement, okay, or the condition is true, because current time equaling to reminder will return us true. Second step. So step two would be to write out the condition. Finally, step three is we need to write out the outcome if the if statement conditions are not true. And I want to put capital not true. So when we break this into three parts, step one would be to declare the outcome, which is we want alarm to be triggered. Then we declare the if statement that will define whether we actually get this outcome. So if current time equals the reminder. And finally, we put our else statement here that we write a condition for the situation that this statement here is actually not true, so false. So to test this implementation here, I'm actually going to call a print statement here and set up our alarm. Now, second thing I'm going to do is I'm going to comment this out so that we can see just the code we have here. Now, in fact, I'm going to leave it on, in fact, and we're going to compare between this statement and this statement to see that we have the same thing. Now, we don't need a print statement. This is going to run automatically. Now, currently reminder is 13 and current time is 12. So we should see alarm is not triggered twice. Let's run this and see. And boom, alarm is not triggered, alarm is not triggered. So this statement is exactly the same as this one. And for final reference, let's set this as 12. Now this should evaluate to alarm has triggered now. So let's see. And you got what exactly we were expecting, which is alarm has triggered. Perfect. See you guys in the next video. Hey, my people, and welcome back. Now, I want us to take a look at a different aspect of the concept of control flow. Now, so far, we've looked at comparison operators, and we know that we can create conditional statements from these comparison operators. Now, in order for me to show you what we are going to look at today, I want to bring out an important point. Now, when this expression is running, Python is going to compare this variable to this variable to see if they are equal. And based on this, will give us either alarm has triggered or alarm has not triggered. Now, this expression itself, the evaluation that happens is going to give us a Boolean statement. Now, to prove it to you, I'm going to drop this over here and put out our print statement right here. So current time is equal to reminder. Let's take a look at what we have. Now, what I'm going to do is I'm going to comment out this expression and just leave our if and else block and our print statement. Let's give this a run. So you see that this expression says alarm triggered and this says true. Now, whenever a Boolean expression is taking place or a Boolean result is going to come from this if statement, what we have to do is test out our implementation. So what I'm going to do over here is what if I put here true? Okay. Now I want you to notice two things. If I put true here and I run this code, we can get rid of this for now. You see, it still says alarm has triggered. Now there is a difference here. If you look at the else block has been grayed out. And if I hover over this, it said code is unreachable. Okay. Now what's happening here? Because this is always correct, or this statement here, this conditional statement is always correct. According to Python, this code will never run. It's unreachable. And this is an important point to point out to you before we continue with the next aspect of our teaching. So when we have a Boolean expression, it always derives from comparing at least two variables together or two data points together. Now, in this section, I want us to look at logical operators. And by doing this, we can expand the abilities of our control flow. So we can undo this. All right. And I'm going to delete this. And I want to introduce you to how we can work with logical operators. Now, what are they? Now, we're done with our tertiary operators. So if you're following me, you can delete this, or you can save this in another section if you want to. So we have our logical operators. Now, with our logical operators here, I want to give you the actual operators first and then explain them afterwards. So we have the AND operator, we have the OR operator, we have a special keyword which is called NOT also. Okay. Now, with these three logical operators, how do we use them? Now, in our example that we have here, our alarm is pretty simple. If it is the time to remind someone and it's also equal to the current time, the alarm is going to trigger. And if not, the alarm isn't going to trigger. But what if we wanted to expand the alarm and we wanted to have it to ring if the first alarm has gone off and the person has ignored it like we all do, but we want it to give us another reminder maybe after 15 minutes, okay? Or after 1 hour, okay? So let's have a new variable called second reminder, okay? And over here, we want to go for new current time, because the current time that we have for the alarm at some point is going to go past, right? So what we can do is we can work with our different statements. So the AND operator, how it works is that when I write AND over here, the expression that comes up on the right-hand side and the left-hand side both have to be, in essence, evaluated to true. Okay, so we could say if current time is equal to reminder time, and now in this case, if we stick to our current time, we also want to check that current time is less than our second reminder. Okay, so when the alarm rings, we're checking if the current time is equal to reminder and the current time is also less than the second reminder, because we don't want the alarm to ring every single second, right? We want it to give us an alarm ring as a process. So let's do this here and let's give this a run and take a look. Look what it says now. It says that the alarm is not triggered. So now current time is equal to reminder time, and it's also asking if the current time is less than our second reminder, which is not. They're both equal. And you see that it evaluates to false. Now, if I set this to be the right time, and let's say that it's 13, say it's 13 hours, 1300 hours, which is 1 o'clock, and we run this. Now we get the alarm has triggered. So in this case, both this statement and this statement evaluate to being true. So if one of these are wrong, then we will get false, okay? So what we have here is that both or more expressions have to be true. If they don't evaluate to true, we have an issue. Now, similarly, if I put this back to 12 again, and just to prove it to you, right now, our alarm is not working, it's not triggered, okay? Now we have the OR statement. The OR statement that we have here now, which is our second logical operator, reads as this. We're saying that if the current time is equal to reminder or the current time is less than the second reminder, we want to run this alarm. So either one of these have to be true. Just like we say in English, is either or. Either you do this or it's this. Either one of these will work for me. This is the exact same way it is with our logical operator. So right over here, if I run this code, we know that this aspect is true, but this aspect would be false because 12 is not less than 12, is actually equal to 12. So let's run this and let's take a look. And you see here, it says alarm has triggered. Now, the final one is a special operator I said called not. Now, what we can do with this operator here is we can say an and, for example, but with our operators here, we can also add the not. Now, the not is a very important one because what this means is going to be if something is true, then it will flip it to be false. So true means false, and false means true. Okay. Hey, my people, and welcome to this section of our Python devs course on functions. Now, in order for us to get started here, I'm going to make a new file. So as I taught you, you can use the keyword code, and then you want to put in the name. Now, I'm calling this functions.py. Okay, and if you follow along with me, you'll see that we have a new file right here. So, whether you know it or not, you've been working with functions and using them to carry out some amazing processes like we've been doing. So for example, we use the ORD function, which allowed us to know what the Unicode value is for a character. So if we type in A here, it will return us a number. We also use the len function, okay, which returned us, for example, if I put my name as Michael here, it will return us the value 7, okay? Now, the one we've used the most is the print function, which is whatever we put in here. So if we put hello, my name is Michael, is going to return us some information. And we can run all of these pieces of code right here. So you see right here, says, hello, my name is Michael. Now, by the way, guys, if you see the file over here called a temp run file, just hold Control and S if you're on a Windows computer, or Command and S to save the file, and you'll see that it will appear here. Okay, when you use the code keyword, the file isn't saved yet. Okay, just in case you're wondering where it is when you create it. So these functions here are a group of functions that we call built-in functions. Let's put here built-in functions. Now, what is a function? A function is a block of code or a line of code that allows us to execute some sort of functionality that is available within Python. Okay, now specifically with built-in functions, they are the tools in the toolbox of Python that have already been created that we can utilize for our own purposes. So for example, with our print function, if you want to display something on the terminal, all we have to do is call the name print function, put our value in, and when we run our code, we get this value on the screen, which is hello, my name is Michael. Now, the angle that I want us to look at for this section of the course is on custom functions. Now, why would anyone want to make a custom function when we already have built-in functions? Well, I'll tell you why. Now, with applications that you build in the real world using Python, you're not going to have access to every single functionality off the bat because they don't always exist, okay? Not every function that we have in Python will be able to do what you need it to do. And so you have to make custom functions so that you can supplement for that and build your application. Okay, so for example, let's say we wanted to create a function to send a custom message. We don't have that built into Python by default, so we have to create it. And Python has given us the room to do so. How do we do that? We use a special keyword called the def keyword, and then we can create over here a name of our function. Now, I'm going to call this function our messaging function, okay? Now notice the way that I've written my syntax. I have capital letters for the first letter in each word. And this is the Pascal naming convention, which is what I want you guys to follow for the entirety of our course and in your real world programming. Okay. Now on the line below over here, what we want to do is write in here what functionality we want to be executed when we use this function. So in here, let's say we want to take in a special name. Okay. And this special name is going to be an import, and we're going to ask, what is your name? All right. Now we have another special keyword with functions, which is called the return keyword. And the return keyword, we can use this to tell Python that, hey, when this function has got to the end of its running, we want you to output this piece of data. So in this case, let's say we just wanted to get a nice custom message that's printed on the screen. So we can say print over here, and we can say hello and welcome. And then we can put the name over here. Now, of course, to do this, we're going to have to put our F keyword here, and we have a custom message. Now, if I get rid of the Python window and we run the code as it is, so we can comment these out for now. Take a look. Nothing comes up on the terminal, and you see that it's exited at the time it's exited in the number of seconds. Now, the question is, why did nothing happen? Why didn't we get an input on the screen like we were expecting? Because there's two parts to a function. Now, right here, this is what we call the function declaration. So this is the declaration of the function. So the functionalities that will be involved. So we want to accept a name as an input, and then we're going to return that name onto the screen. That's our functionality. But just because we declare a function, Python is not going to automatically execute that function unless we specify to do so. And the way we do so is by calling the name of the function here, or writing it out, and then putting our brackets here. Now, we're telling Python that we have the declaration of how this function works, but we also want you to execute it. Now, because this is going to be an input and the output here is read only with the code runner, I'm going to go to the terminal here, and instead I'm going to call Python. Now, if you're on a Windows computer, it's Python. If you're in a Mac or Linux, it's Python 3. And then the name of the file, which will be functions.py. Now you see here, it asks for my name, so I'm going to put in Michael. And take a look. It says here, hello and welcome, Michael. So this is how we work with functions. All right, guys, so let's take a look at a concept called parameters. Now, parameters are a specification of something we want to be added, okay? And I've written it down here already so that you can take a look at this whilst we're talking. Now, parameter in programming, and specifically in a function, is something we want as a requirement to be inputted into our function to have a certain output. I give you an example. So let's say, for example, we wanted to send a special message to each person who interacts with our application. In here, we can say that we want to specifically give them a special message which contains their name, and maybe it contains their age as well. So right here, these two values here that we have as name, so I'm going to write this here, name, and also age. These are both parameters. Okay, so these are values that we want to be added into our function to provide a certain output. Now I'll delete this call for now, so you can follow along with me. So let's just say that every time we print out a message, we want to include the name and the age of the person. So we could say, for example, here, have an F string, as I taught you, and say, hello, and then here we'll say name. Okay, your age is, and then we'll put the age of the person here. Now you notice that as soon as I use the names here, which are parameter names in our print statement, they go for being grayed out to light up. So I'll show you one more time. If I delete age over here, take a look, you see that it grays out, and it says age is not accessed. Okay. What that means is that we're not making use of this parameter at the moment. Now by setting up our function in this manner, we can create custom messages for anyone of any age. I'll show you what I mean. So over here, when we call in our function here and we put in our brackets, take a look. Over here, it says that we have a name, and it gives us this colon that says any, and then we have the arrow that says we have none returned, which means we have no output. We just have a process that takes place, which is our print function. Now, let's break this down in pieces. Firstly, over here, we have this thing that says any. Now, in this case, what this means is that we can import any type of data. Okay, so that means we can pass in there, we can put in a string, okay, number, and etc. That's the first aspect. Now, secondly, when we have these names here, when we declare in a function our parameters, we need to actually pass in the data here for this function to work. So if we try to run this function as it is, take a look. Look at what it says. It says we have two required positional arguments, name and age. Now, you're going to say, Mike, I thought you told me that these are called parameters. Yes, they are. And if you hover over our program, it says parameter. However, when we have a parameter here, this is a specification. So now we actually have to fill in the specifications that are required by this function. And it requires that we put in a name and an age here in order for us to get something on our print function. So for example here, if I type in Michael, and then I'm going to put 18 over here. Now, if we run this same function, take a look at what we get. It says, hello, Michael, your age is 18. And now we have a dynamic declaration because I can change this name from Michael to Alan, and I can change the name from 18, the age, sorry, from 18 to 25. And if I print out this message, you see, I can have a custom message that's printed out based on the inputs here. So right over here, Alan and 25 are arguments. Okay, whereas name and age are the parameters. Now, a very famous saying we say in programming to remember the difference between parameters and arguments is we want to keep the arguments outside. So in this case, we mean to keep our arguments outside of the function declaration. So parameters are in the function declaration and arguments are in the function call. Okay, guys, so let's take a look at arguments at a deeper level now. Now, so far, with the arguments that we've passed in, so Alan and 25, we've passed in a string and a number. Now, we know that with the type any, we can pass in any data type we want. Now, as good as that is, because we may want to pass in 25 as a number, or maybe want to pass it in as a string, if you put some brackets in here. At times, when working with functions like these, it's very easy for us to fall into ambiguity. And the way that we can solve this is by introducing something called a keyword argument. Now, it's something that helps for us as developers who are reading the code, and also for Python in specific instances that we want to make it clear which value we're dealing with when it comes to our parameters here. What do I mean by this? Now, let's say, for example, we're not dealing with just a name and an age this time. We're dealing with a first name and a last name, okay, or surname. So I'm going to replace this with last name. And if you're copying along, you can do the exact same thing in your code, okay? So we're going to say, hello, first name, your surname is this, okay? Now, right over here, let's just say that we're going to have two names. So let's just say we have Alan and we have Joshua. Now, Alan and Joshua could potentially be a first name and or surname, and it's not actually clear which one is which. Now, the way that Python works is that it looks at our arguments and our parameters from a positional point of view. So in essence, the positional point of view, and I want to put this right here for you, is a numbering system. So the positional point of view, for example, is that if we're starting from 1, first name is position 1 in our parameters and last name is position 2. Now, when it comes to the arguments, the values are counted in the same way and tracked the same way by Python. So this would be position 1 and this is position 2. The actual value we pass in here is not really as relevant as the position that is in, because the position will determine where it goes in our print statement. So let's just say that we have Joshua, which should be the first name, and Alan is the surname. So I'm going to write this here in this example. So in this example here, Joshua is the first name, and Alan is supposed to be the surname. By the moment we have them in reverse order, we can make it very clear which value is which by using what are called keyword arguments. So let's put this here, keyword arguments. Now, a keyword argument simply involves us using the name of the parameter and assigning it to the value that we have. So for example here, if we wanted to make it clear that we're dealing with the first name and last name, we can put the first name and last name here and then equal them to these values. Now, I just want to show you about positional arguments really quickly. If I get rid of all of our variables that we have here, all of our arguments, take a look. As an error, it says that we have two required. Now, the keyword here is positional, which lets you know how Python reads our code. So in position 1 is expecting whatever this name is to be here. Now, I could call this anything in the world. I can call it A or B. Doesn't matter. How Python reads arguments is in positional order. So to make it clear to Python which one is which, and to whoever is looking at our code, we can put first name. And you see, as soon as I do that, there's an equal sign that appears straight away. And we can make it clear that the first name is Joshua. Okay. And right here, we can say, for example, last name equals to Alan. Now, if we run our code over here, it says, hello, Joshua, your surname is Alan. Now, if I put this in the reverse order and I said Alan, okay, and I put Joshua here, take a look at what we have. We have now a different order. We have, hello, Alan, your surname is Joshua, which is incorrect. Now, what if I put over here surname? Okay, in this case, actually, it's last name. And over here, we have first name. What's going to happen now if we run this on the terminal? Let's take a look. Now, you see what happens? Now, even though we have first name at the second position of the argument, because we have the keyword here for Joshua, Python has reorganized it for us in the correct direction. And first name is Joshua, which goes here, and last name goes here. So this is the power of dealing with keyword arguments. Okay, welcome back, people. Now I want us to take a look at arguments from the side of our function declaration. Now in our function call, we use keyword arguments to define what should be the first name and what should be the last name. And in this case, we've switched these around. Joshua, we know, is supposed to be the first name, and Alan should be the last name. But because of keyword arguments, we can actually switch our values around interchangeably. Now, in a real-world application, we can never trust that the user is always going to do everything correctly. Let's say we have a user who's signing up to our application, and they give us a first name, but they forget to give us a last name, and they press enter. And let's just imagine we don't have any error checking. It's just going to accept what value they're putting straight away. Now, what we can do is that we can also create something that are called a default argument. Let's put this here, default argument. Now, a default argument is an argument we can place inside of the body of our parameter section of our function. So for example, in here by default, we can always return an empty string for the first name and an empty string for the last name. Now, what will happen is, instead of us getting the error that we get if we don't pass in any first name or last name arguments, is that Python is going to render our first and last name default arguments to the screen. So let me show you. So if I cut this out and we run our code, notice you see we don't get the same error that we had last time. Instead, we have hello blank. Your surname is blank, right? Now, if I do put these values in here, now we get hello Alan, your surname is Joshua. Now I want to explain a very important point here. When dealing with our default arguments versus our keyword arguments always have preferential treatment over our default arguments. So the default arguments are like almost like placeholders if we don't fill in a value. But if we do fill in any of these values here, these values will override whatever is written here. And these are what we would call our default arguments. So let's say, for example, I got rid of this last argument here and just left it as first name like this. Take a look at what happens. You still see what we have? We have hello, Alan, your surname is blank. So these are the kinds of combinations we can have when we work with keyword arguments and default arguments. Hey, my people, welcome back. Now, in this section of our teaching, I want us to take a look at how we can work with parameters and arguments in a deeper way. Now, I just want you to imagine for a moment, we want to send custom message to a list of people. Now, let's say we don't actually know how many people we're going to send this message to until they arrive to use our application, okay? So maybe on Monday, we might have 67 people using it. On Tuesday, we might have 4 people using it, and we don't really know. So we need to find a way to accommodate for this variableness of arguments. And we can do this with a special operator, okay? Now, to do this, I'm going to show you with our function here. Now, this function, let's call it custom message. So if you're copying along, type in custom message with me. Now, in our parameter section, for us to be able to accommodate for a varying number of arguments under the umbrella of one parameter, we need to use this special operator here called the star operator or an asterisk, and then type in the name of the variable for the parameter. In this case, we're going to use names. Now, what's going on here? Now, this star, okay, it means we want to include a varying number of arguments, okay? Or you can say it this way, a varying number of values. Now in Python, we call this xargs or xargs, where the x stands for any number of arguments. Okay, so it could be 10 arguments, 5 arguments, and etc. Now in this case, if we did have a list of names that we wanted to pass in here, we're going to need a for loop to be able to control how we print out our names. So let's say our custom message is going to be a simple welcome message. So first, let's create a for loop. So we can say for name in names. Now here, notice I didn't use the star again. We only use the star one time here. After that, the variable for the parameter here, names, is what we use to address any data that's going to come into our parameter as an argument. So down here, we can print a simple message. As you know, we can have an F string and say, hello, we and welcome to you, and then we'll give the name, which will be whatever it is. Now, with this additional operator here for our parameter name, it opens up some more possibilities of how we can work with our code. So when we call this function, so custom message here, we can pass in one argument. So let's say we pass in Michael. But additionally, we can call this function somewhere else in our program, and we can have another list of arguments. So we can add in here Joshua. We can add in Caleb. All right. Can add in Moses. All right. Can add in Miriam. Let's say we add in Meg. So right here, we have 5 arguments for this second function call. And we have 1 argument for this first function call. And if you run the code here, take a look. Notice right here, we get the 1 argument call for hello and welcome to you, Michael. But then we also have these 5 names that have all been produced with a custom message. So this star keyword allows us to have a varying number of arguments. And this is how we use our asterisk keyword for any number of arguments. Hey, my people. So welcome back. Now, I'd like to teach you how we can work with our arguments of varying amounts in a more specific way, depending on our application. Now, in order for you to understand this, I want you to think with me for a moment. Now, with our customers here, we're going to store our customers, okay, of course, in some sort of database, right? Now, in the database, we have 2 types of data for the customer. The 2 types would be required data. All right, so let's put a number 1 here so you can copy in the notes. And the second type would be optional data. Now, as a result of having both required and optional data for our customers, we're going to have a varying number of data set sizes. So our customers will have a varying amount of data for each individual customer, okay? Now, to represent this as a function, if we wanted to print out information or data for just one individual customer, we can do this. So I can declare the function called customer data. And in here, as you know, for now, with what you know, we can declare include a varying number of arguments operator here. And then we can call this data. And let's say for now, we just simply want to print out the data that we get coming in. Now, because we have a varying size of data pieces, there are going to be a few data points, as you can imagine, that we wouldn't know whether they are a name of the person or whether it is a username, nickname. We wouldn't be able to tell off the bat. So for example, if I call this function here, and we're going to work with Joshua. So Joshua could have a name called Joshua, but then Joshua could also be, let's say, a secret password called Joshua. And as a result, we're going to be confused as to which one is which. And this is where another form of working with arguments comes in, which is called a keyword varying number of arguments. And to do that, we need to add an additional star right here, or an additional asterisk. So if we write this here, this means include a varying number of keyword arguments, okay? And we represent this as XX ARGS, which means a varying number of keyword arguments, okay? So with this varying number of keyword arguments, we can now provide a setup where we can actually differentiate between 2 values. So for this Joshua, we can say over here that the name is Joshua. And here we can say that the secret password, so we say secret key, is also Joshua, because off the bat, we wouldn't know which one is which. Now, if we print this out on the terminal, I want to show you what exactly we're going to get when we run our code. So take a look. Now, down over here, I want to copy this and let's lay this on the side. Now, these curly braces here you haven't seen just yet, but this is a special complex data structure called a dictionary, which we'll take a look at in our later modules and lessons. But you can see here that for each of our keyword arguments, we have our values defined for each. So name is for Joshua and secret is also for Joshua. And by doing this, we can have a varying number of keyword arguments. So down here, we could do another one for our next customer, Caleb. And let's say Caleb has a name, okay? And his name is Caleb, of course. He also has a secret password, so we'll call it a secret here. But with his secret, it will be something different. His one is going to be called mouse. And apart from just that, he's also provided a little bit more of information and he's told us his email. So with him, we can accept an email. We can say caleb@hotmail.com. So when we run our code now, take a look at what we get. Now, for the sake of looking at the code, I'll comment this out so we can just see what we have in our terminal. Let's clear it here. Let's clear this out too. And let's take a look. So you see, we have a varying number of keyword arguments this time that help us to clearly define what data points we have for each customer. And this is how we can work with varying keyword arguments. All right, my people. So welcome back to a new section of our Python course. I hope so far the journey has been great for you. And again, as always, make sure you repeat any video you need to. Remember, I always tell you guys, quality over quantity. So even if you've watched 5 videos, but you understand them well, compared to watching 25 videos, but you understand only one piece of what I've said, I much more prefer the 5 videos. Now you can see by the name that I've set up here for this section, the folder name is called collections and the file name is also called collections.py. And now in this aspect of our Python course, I want us to take a look at a very important section of data types called collection types. Now from the noun that we have, collections in English, we're talking about something that has the ability to hold data or to collect something. And this is exactly what we're going to look at. So in this section, I want you to follow every challenge as always. Copy every line of code that's available. All right, so let's begin. Now, collection types in Python are exactly as it is in English. It is a data type that can hold or store values. Now, this is a very important concept when it comes to working with data because you want to be able to store data and use it or modify it or get rid of it where needs be so that you can create fantastic applications. So the first data type I want us to take a look at is the list type. Now, the list, I'm going to put a little comment on here for you, is a very familiar type to those of you who have been working with other programming languages. Syntactically speaking, it looks very similar to another data type we're going to look at, which is an array. Now, how do we declare a list? So in Python, as you know, we declare a variable. So let's call this names. Let's say we want to have a list of names. So in a list of names, we use these square brackets, the square bracket notation here, to be able to initialize a list. Now, this list is what we call dynamic because we can store a varying amount of values within this list and we can get access to them at any time. Now, to get access to them, we use a special syntax, which is called indexing. So let me show you. So let's say we had a list of names. Growing up in primary school in my time, I had a register and everybody's name was on the list in alphabetical order. And then, it goes down from A down to Z, either by your surname or your first name. So let's replicate something like that. So let's just say on the list, obviously we're going to have me here. So we're going to have Michael. Okay, we're going to have John. We're going to have James. We're going to have Anne. We're going to have Freya. And we're going to have Clara. Okay, so these are our names in our list. Now, how does indexing work? So once we store these values in our list, we can make reference to them to get access to each of these items in our list when we need to. How do we do that? So I'm going to set up a print statement here. Now, what we do is we call the name of the variable that we'll store in the list. So for example, names, and then in the square brackets, we can put in a number. Now, before I continue to finish off this line of code here, I want us to take a look at how indexing works. Now, indexing works from what we call the zero count. So the first item in any list is always the zero index. The next value would be 1, and it continues until what we say is the n minus 1. So in this case, if I wanted to print out the first name that appears on the register, I'll pass in 0 here. Okay. Now, when I pass in 0 here, we should see Michael on the terminal. So let's give this a run. And you see Michael appears on the screen. Now, we can also do other things. With the list, we have the ability to look at a range of values. So let's say we wanted to look at the values starting from Michael all the way until James. Now, if I remove our n minus 1, you know that this will be index 1 right here. So let's put some space. All right, this is going to be index 2. This is number 3. This is number 4. And this is number 5. Now, how can we represent this? So let's say we wanted to get these 3 values here. Now, how this works is important. The first value in our index is included in our list that we're going to search for. But whenever we put the last value, we're going to end up with the one less than that value. Now, maybe me saying that doesn't make much sense. Now, if we want to see Michael, John, and James, we need to put 1 to our 0 here, all the way up to our 3. If I put 2 and we print this out, we're only going to get Michael and John. I'll show you what I mean. So you see, in the terminal here, we only get Michael and John. So I'll comment that over here. Now, why is that? I thought you said that with indexing, we have the 0 as a count and represented as a value. Yes, we do. But when we're searching a list or we want to grab some values or query a list, the last value here is not included. It's 1 less than the value. So really what we're looking at is index 0 and index 1. And I'll write this here. So we're looking at names 0 and we're looking at names 1, but we're not looking at names number 2. Okay. So if I put 3 here, then what we get is what we're looking for, which is Michael, John, and James. Perfect. Now, aside from that, we can do other things. We can also go in reverse order. So let's say, for example, we wanted to find the last number here. Now, you remember the syntax I gave you of n minus 1? Now, we can take advantage of that. And if we pass print here and names, now inside of here, usually when you work with a list type object, so for those of you who have experience working in other programming languages, you know that in other programming languages, this looks exactly like an array. Now, they don't exactly behave the same, and this is why I said later on in our lessons that we'll look at, we actually can see a clear difference between an array and a list in some parts of Python. Now, what we can do here is that if I said, for example, -1, now reality is that -1 doesn't exist. If you look at this list over here, -1 shouldn't exist. Okay, if I put -1 in here, I want to show you what happens. Now you see, when I put -1 here, instead of it giving us an error, it tells us that -1 is Clara. So this is a very common syntax that you'll see when we want to get the last value in a list. We can use the -1 keyword here. Okay, now I want to show you other things you can do. So we can print here names. Now, with every single data type within Python and in every other programming language, we always have the ability to have methods. Now, by default, every type that we work with, so a list and other collection types we're going to look at, all of them have methods attached to them because they are a class. So the string class, strings themselves are a class, and attached to the string class, we have methods like upper or lower, capitalize, and etc. The same thing's true for a list. So over here with names, if I said names dot, and I said I wanted to get the index of something, so instead of me passing in the index, this time I actually want to get the index of a value, I could go in here and it's going to accept the index. Now it says return the first index of a value. Now this is important because in a list you can have multiple of the same item. But let's say we wanted to get the index of Freya and we didn't know where Freya was in our list. If we pass in the name Freya, then what we would do is we run this code and it tells us index 4, which is right here. So this is the foundation of how we can work with lists. Now we can also generate lists using the list keyword. And I want to show you this down here. So right over here, let's say we wanted to have a list of ages. I'm going to call this ages here. Now what we can do is we can use the list keyword, which would allow us to initialize an instance of the list class. And then in here, we can pass in some values. Now, for now, inside of here, we can pass in whatever we want. It doesn't have to necessarily be a number. It can be a string. It could be a range. So we could say, for example, range of 10. Now, I'm sure you guys are familiar with range of 10. If I was to print out what happens if we put our ages on the screen here, take a look at what we get in our terminal. So you see that we have a list that goes from 0 all the way until 9, which gives us 10 values. Okay, so you can actually have a list of values in this format, which can be very useful if we wanted to individually select or manipulate what we have in our list, the data that we want to remove or we want to add, and etc. Okay, so this is the foundation of lists. In the next video, let's build on this concept. I want you to take a practice with what I've given you here, create your own list, and then come back to the next video. See you there. All right, people, so welcome back. Now, as a recap, you know that we can work with lists and declare them in this format as we have here, which is the most common way to declare a list. But we can also declare a list in this format. So I can say, let's just say second list, and I can use the list keyword here. Now, one thing to note is that for every data type that exists within Python, there is a keyword that goes along with it that we can use to construct and get access to the properties and methods of that type. Now, what do I mean? So for example, let's say this was the string type. Whatever I put inside of the brackets will turn that value into a string. So even if I put the number 50 here and I print out second list here, because I've wrapped this value in the string class, this value 50, although it's an integer, will take on all the properties of a string, and this value will immediately be converted into the type string. Now I'll prove it to you by putting type here and wrapping second list over here. So let's take a look at this. So you see, we get the value 50, but notice what it says. It says the type here is of class string. Now, this same principle is true for any data type. So if I wrap this value list in here, and let's say I put my name in here, this value, which is my name, will also be turned into a type list. Now, one of the important points to note here is that a string is actually a list of characters, or you can also say an array of characters. Because it's a list of characters here, when we run a singular string inside of the list section here, take a look at what we get. So I'll print this and pass second list over here. Take a look. So we actually get my name, each character split into its own section in our list. So I could actually access one of the values here. So if I say I wanted to get my first letter of my name, I could pass in index 0 and take a look what happens. I just get the character M. So the question will be, why would we actually use the list constructor when we can just declare a list in this manner? And that's a very good question that I wondered for quite a while when working with Python. Now, in real world applications, data that we hold in a list or in an array will be very, very long and very, very large, because by default, the collection types were designed to be able to collect and store large amounts of data. Now, the rule of thumb here when using the list constructor versus declaring a list manually with the square bracket notation is that when we have a list that is physically long, so we're talking about a list of, let's say, 500 values, then we can use the list constructor and pass the object of data that we want to pass into this list. So if we had 500 values, we can simply put those 500 values as a reference point or the reference to the memory address, depending on how you want to do it. And when we use the list constructor, it will immediately generate us a list with those 500 values that we have. So if you had 500 names in the database, we wouldn't want to physically type 500 names in the database because number one, it would take up a lot of space on the screen, which then of course you can get into errors too. And it is physically tasking. But here's where we would use the list constructor. So I'm going to leave a note here. We use this for large data sets. Okay. And of course, the normal way to declare a list is for very small or relatively small data sets. So 5 values, 10 values, 20 are relatively small. Okay. Now I wanted to raise this point already so that as you're building your applications, you'll be very aware of when to utilize what tool when working with lists. Now, when building a list, we can also have more complexity in the way that we display data on the screen. So I'm going to clear this second list for now. Over here. And change how we write our code. Now, of course, if we wanted to add a list in the type that we need, because right now, if I have this printed out again, you know, it's going to give out my name. To fix that, what we simply do is just wrap this in square brackets. And let's print this out one more time over here. Second list. There we go. Now you see that if I add a value here, it'll be exactly as though I didn't change anything. So let's put John over here. And I print this out. See, we have the same thing. Okay. Now moving on, when working with lists, in the next video, I want us to see how we can work with more complexities that come along with a list. So come along with me and I'll see you in the next video. All right, people. Now, when working with a complex list in a real-world application, as you know now, it opens up opportunities for us to have different styles of querying and more custom querying of data based on what we're looking for. And that opens up really good opportunities to have a very versatile and dynamic application. Now, I want us to take a look at some methods for modifying our list that we're dealing with in our complex data. So to do this, we're going to call user data And we're going to use the dot notation. Now I want us to take a look at the first important method here, which is called append. Now, what does append do? Append simply adds a new object of any type to the end of the list. Now, because we're using the append method, we don't need to specify what list we're going to be working with because the dot notation takes care of that. Because we have the dot notation between append and our list, the append method is going to be called for this list anyway. So what we need to do, this is why it takes only one argument, is to add what we're trying to put into our list. So let's just say, for example, at random, I just put in my name, Michael here. Now again, with the append method, the return type is none, which means that this expression changes how our list is stored in memory, and it actually adds a real additional item to the list, which is stored in memory. And from this point onwards in our code, if we were to print or use our user data list for anything after this line, we're going to have a new index, which will be index 3, called Michael. So how do we do this? Now you can wrap this in brackets so that it can be expressed as a tuple, okay? And I'll show you how it looks. So let's print out user data and take a look. And you see, now we have a new item in the list called Michael. Okay, equally, we can add a new user. So let's just say we wanted to add a new user. This is going to be Haggle. Haggle has a password called runner, and his age is 26. So if I pass this in here, take a look at what we get. So now you see we have a new tuple at the end of our list. Okay. Now similarly to append, we have another one called extend. And I noticed that a lot of students get these two mixed up. Now the difference here is that with extending a list, what we're doing is we're extending the length of the list, which means we need to pass in an iterable. Now it says that extended by appending an element or appending elements from an iterable. So in here, we actually have to pass a list and not just a data type. And what's going to happen is that extend, and I write this here, is going to join two lists together. So in here, you can imagine in our real world application, let's say we have 3 new users that sign up to our application. So we're going to declare our list in this format here, and then we're going to pass in some values. So we say that Haggle is going to join us. His password is runner, and he's of age 26. We add a few more so you can copy the code as I'm writing. We're going to add Gunner, and Gunner is going to have a password of shoot, and then he's of age 18. And then finally, we'll have one more, which is going to be our user called long distance. And long distance has a password called lounge. And he is of age 22. So if we append, okay, so if we append, we're going to add a new item to the end of the list. If we extend, we're going to add a new list or join a new list starting from the last value that is available here. So let's take a look. Now I'm going to comment this out here so you can see exactly what happens. So you see here, we've extended the list by adding one list to another. Now you're probably wondering, why would you use extend and not append? Because if I use append here, let's take this. Can't I do the same thing? Well, I'll show you. So if I pass in the list here and do the same thing and comment this out, take a look at what we get. We get the exact same thing, but there's a problem here. Notice that right over here, the append method adds the data with our square brackets. So in fact, we have a new item at the end of the list, which is going to be a list of tuples. So we have a complex list within a complex list, which is not what we want. We want to add every single value that we have in our expression here to the original list, and it becomes one list. So this joins two lists together to become one. In this expression here, what we get is that we add a new item, which will be in this case index 3, which will become a complex list as a single item. So the difference here is the square brackets give this an item. Now, if you want to see what I'm talking about, if I print the third index, so user data 3, take a look at what we get. So the third index is actually a list of complex items, and not in the previous case that we had here, it would be just haggle, runner, and 26. So if I get the extends out and we do the same thing, and I comment this line out, take a look at the difference here. So in this case over here, let's run this again because I was hovering over the line. Here we go. Now you see now we have haggle, runner, and 26, which is index number 3. And the full list is all of the values from the two lists joined to one list. That's the big difference here. Now I want you to practice this as many times over as you can, but this is how we can work with lists. Now, when we work with lists in this format, we can also use what is called list packing and unpacking. So packing and unpacking. In the next video, I want us to take a look at how we can work with that syntax to control how data is expressed in a list. See you there. All right, guys. So as we looked at in the previous lesson, you know that we can take a complex list and we can add new items to the end of the list, or we can join two lists together, which gives us powerful tools that we can work with when it comes to collecting data. Again, I want to remind you that the list is a collection data type. And so because the list we have here is of the collection data type of type list, we want to make sure that we control how we store data. And this is the power of using lists within Python. Now, how about packing and unpacking? What do I mean by that? Now, the concept of packing and unpacking is something that you can find in many different programming languages. Now, within Python, the context of using this especially is going to be with our collection data type. Now, to show you how this works, I'm going to create a new list, a very simple list to give you this example. So let's call this our age list. And in here, let's just store the values that we have in our complex list. So 25, 27, and 21. And then add a few more, 22, 24, 34, 18, and 19. Okay. So this is our age list. Now, how does the unpacking side of this work? Now, in this form, the data we have in here is the packed form. The reason why is because all of the items are within one list and stored in one variable. So this is the packing, okay? Now, what about unpacking? How does that work? Unpacking. How does that work? Now, sometimes when we want to control how many variables or items we have, we need to use the unpacking methodologies that are available in Python to store data specifically to how we want it to be used for further processing. So let's say, for example, that we wanted to store the first 3 users' age within a single variable. How would we do this? Now, to do this, we need to call age list. And in this example, we're going to keep it to the left-hand side for the equals and the right-hand side for the variable. Now I know when we were using indexing, we were using the left-hand side for the variable and the right-hand side for the equal sign when it came to reassigning. Now here we're not reassigning, here we're going to be unpacking. So I'm going to give this variable a name called users. Now when I do this, we use a very special operator called the asterisk operator. And as soon as I do this, look at what we get in the terminal. So in the terminal, we get unpack operation is not allowed in this context. Now pay attention to the word context here. This is the most important aspect of working with Python. Everything is about context. Now the reason why we have this error is because we can't store all of the values here or unpack all of the items in this packed list into one variable. We have to spread it across multiple variables. So what we do, we add a comma here. And let's say that we wanted to store the rest of these individual values as individual users. So right here, we'll say this is user number 3. This is user 4. This is user 5. This is user number 6. Now what's going on here? Now with the first 3 values, they will be stored in users. The next value will be user 3. This will be user 4. This would be user 5. This will be user 6 and user 7. Okay. Now, really and truly, this should actually be user 4, 5, 6, and 7. So I'll change it because you're probably wondering, huh? That doesn't add up with the maths mic. I just realized it doesn't. So I'm going to change it for you here. So 5, 6, 7, and 8. So now that we've unpacked this list, we can grab the items that we need based on what the variables represent. So let's say, for example, we wanted the first 3 items here. If I do a print statement of users, notice that I have a asterisk in front of users, but this is still considered as a variable. Now take a look at what shows up on the terminal here. You see that we return a new list, not just the items, but the items within a list for this specific section. So what we have is that this list is being broken up into several list items. If there is more than one item in this case, we have a square bracket notation. And if it's a singular item, let's say, for example, users 4, take a look at what we get. Now, I put users 4, should be user 4. Let's try that again. You see now we get just the singular value of 22. So this is really cool. This is how we can unpack a list and work with our values. Now, the same thing applies to a complex list. So let's go for complex unpacking. Same rules apply. So we can call user data, user underscore data. And to the left here, let's say that we wanted to store the first 2 users inside of a special variable. We're going to call this our main users. So main underscore users. And then the final value here would be our other user. So we call this other user. And the same thing applies here. If I was to print out main users and run our code, take a look. You see that we have a list of items here. Now, because we have this as a list of items, I can access the index over here. So I can say, for example, index of 0 and take a look at what we get. We can access this value over here. Now, we can even take this further because this value itself has its own index. So main user 0 is a variable of its own that has 3 values. So index 0, 1, 2, and 3. Now, if I did this over here, take a look at what we get. Now, I've accessed the index of 0, which is our index here. And then we've also accessed the value within this tuple, which is the second value of 25. Now, this is called a 2-dimensional or 2D. I'll put dimensional in brackets here. List. And this is a very powerful way for us to begin to create more complicated lists that allow us to represent data for many different applications, especially mathematical ones. This syntax over here, where we use the double square, allows us to access a list of items within a list of items. And this is the power of using collections. So see you guys in the next video. Take care. All right, people. So welcome to the next section of our discussion on collection data types within Python. Now, right here, I wanted to plug in arrays because lists and arrays are something that can get really confusing because syntactically they look the same most of the time. And many of my students, including myself in my early days, found it really confusing, especially when working in programming languages like C#, because they look so similar, but they do work differently sometimes, but not all the time. They could be very, very similar. Now, within Python, arrays don't exist in the setup of our built-in types. If we want to get access to an array, we're going to have to import it from the Python modules that exist for it. Now, there are two different ways to get access to the array class because this is what we're going to need in order for us to initialize an array. Just like we have the list class for lists and the string class for strings, we have the array class for arrays. So let me show you the two different ways to import an array. Now, this is my recommended way of doing it. So I'm going to show you that first. So what we want to do is that we want to say from array, we want to import array. Now, notice that in Visual Studio Code, we have this symbol that appears every time we have something to do with a class going on in our code. And this is here to represent that this is a class. So this slanted rectangle with lines coming through means class. And once we have this, we can create a variable. So I'm going to call this my array and set this equal to array, just like we would if we were going to initialize, for example, a list. Now, this is one way of doing it. Now, the other way to do this, which is equally valid, but not my favorite way, and I'll show you why, is to simply write over here, import array. Now, even though we import array from up here and it seems shorter, there is a little cost to this, visually speaking, is that every time we want to create an array, we're going to have to write array.array. So we're saying that from the array module, we want to access the array. Now, to me, this code is very clunky, and after a while, it can start to get pretty annoying. So personally, for me, I like to use the first way of doing it because it makes our code a lot more cleaner and a lot more easier to use. So we're going to say from array, import array. Good. Now, how do we initialize an array? Now, an array in Python has two arguments. The first one is called the type code. And the type code is the determiner of what type of values we can store within our array, which we're going to use square brackets to initialize, which already, when you see it, you're going to say, well, that looks exactly like a list. Exactly, that's the problem. Or maybe not the problem. Well, you'll see in a moment anyway. So how do we get access to a type code and what can we do to get access to it quickly? I'm going to show you. Now, in this case, google.com is going to be your friend. We're going to search on Google for Python type code. Now, I don't expect you to remember these. Now, over time, you may remember a few of these because 90% of the time you'll be using 10% of the list of type codes. So to find these, we need to go to Google. So follow me as we do a quick search. So we're going to go over. Now, I've saved you some time and just shown you what I've done as a search. So I've searched Python type code for array. Next, once we get here, you want to click on the link that says Python docs and docs.python.org. And if you see a title that looks like this, efficient arrays for numeric values, then you're in the right place. So we click on it. And here we go. Immediately, we get the list of our type codes and what they're used for. Now, the time of this recording, the most recent version of Python is version 3.12.2. So anytime your version changes at the time you're watching this code, or there's a newer version from the time you're watching this video, what you want to do is simply just find on the drop-down box the type you have here. So for now anyway, let's take a look at our list. Now, please don't be intimidated by this list. I know we do have a lot of types here, but I'm just going to show you the 90% situation that you're going to be in, which is that number one, we're going to be using in this keyword here, you. Now, this keyword you allows us to create an array of strings. So, for example, an array of names, like we looked at before when we had the list of names in our previous examples in the list section. We have also our capital I and lowercase I. Now, both of these can store integers, but there is a little difference here. A signed integer is a numerical value that can store either a negative number or a positive number. An unsigned integer only allows for non-negative numbers, so from 0 to infinity. Now, with using long types, which usually we use for things like representing dates, because, for example, the date is measured in milliseconds and also in seconds from 1970. And so those values usually go into the billions and even more, depending on what you're looking at. And so for those kind of purposes, we need the long type. Now, finally, we have the float and the double. Now, if we want to have an array, for example, of prices, let's say we have a price list, then we want to use something like a float, which allows us to represent numbers as decimals. So the 90% of the time that you're working with this, you're going to be working with the U character, the I character, and the F character. So let me show you some demonstrations of how we can declare these type of arrays. So going back to VS Code, follow along with me. So let's start off with the first one. Let's say we want to set up a string array. The next argument that we have for the array type is the initializer, which in order for us to initialize our array, we just simply use square brackets here. So in the square brackets here, let's say we have Michael, we have Anne, we have Jerry. So this is now an array of strings. Let's put this over here. We can also set up a new list. So let's go for, now you see, I just said the word list instead of array. And that still happens sometimes because an array and a list, they look the same. So sometimes your psychology goes to, oh, this is a list. Especially because in Python by default, our collection type for things that arrays do in programming languages is a list. So let's continue. I'm going to say my numbers list. So we're going to go for an array. And right here, we're going to plug in our lowercase I. And then we can pass in numbers. So 1, 2, 3, 4, 5. Now, in order for us to see the difference between an array and a list, I'm going to show you by comparing the values that we have in here and saving it as a list type. So let's go for my list this time and set this to, now we can either use the list constructor and pass in our value like this, or we can simply just take off the brackets here and carry out in this form and we get the same result. Okay. Now the way for you to see this is number one, let's go for my array and look at the dot method. Now, when we look at the dot method, I think you can recognize some of the methods that we've been using before, like append, extend. Okay, we have others like index and insert. We also have pop here and remove, things that you're quite familiar with. But then we have others on the list like from byte, from file, from list, from Unicode, which if we take a look at the list methods, you can see that those don't exist. Now, one of the differences between a list and an array when working in Python is the scope of methods or the level of methods we have. With arrays, it opens up more capabilities to do more complex data handling and collection handling. So for example, here you can see that most of our methods that we have for a list are to do with managing data within the list, either removing it or adding data or sorting it, and nothing beyond that. Now with arrays, it opens up capabilities beyond sorting, adding and removing data, and gives us other methods which I'm going to show you, like for example, writing data to a file, okay, or working with data in the Unicode form, and etc. So this is a simple introduction, nothing too heavy. In the next videos, let's take a look at how we can work with an array to carry out complex data handling. See you there. All right, people. So let's take a dive into exploring arrays in Python. And in this video, I want us to start off with, I believe, a very important topic, which is converting an array into a list, or type conversion with arrays. Now, you're probably wondering, why would you want to convert an array into a list? Especially because it took so much work to get here. We had to import something, and then we had to find the type code just to get over to creating an array. So I'll explain to you why. Now, when it comes to building a real-world application, there are quite a few considerations that you have to make before executing your code. Now, things like performance, CPU utilization, memory storage, and etc. These factors all matter in building the best possible application for the world to use. Now, one of those considerations is performance. Now, when it comes to using arrays and using lists, as I said earlier on, one of the things that really confused me about arrays and lists in the early days is that they look exactly the same with the square bracket notation, especially in other programming languages, but they do work differently at times. So it used to catch me up, and I used to feel so annoyed. Now, with smaller data sets, arrays and lists don't have any clear difference in their performance, but as the data sets get larger, and trust me, they do when it comes to a real-world application, so for things like storing user information, lists come out on top with having the best performance out of the two. And so this will be a very good spot where we want to convert an array into a list. Now, converting a list into an array can be very challenging at times to think about when and why to do it. But one important reason when it comes to converting an array into a list and then a list back into an array is if we want to take use of more complex methods of manipulating the data that we have. So I'm going to show you both ways, from array to list and list to array, below. Now let's kick off with converting an array to a list. There's a few methods of how you can do this. I'm going to start off with the first one here, which is using list comprehension. So at the top here, I'm just going to declare an array of numbers, which are going to be ages. So I'm going to call this our ages array. And over here, I'm going to call our array method. Now remember, when we're dealing with integers, we can either use a capital I or a lowercase I. Now in this case, because all the ages are positive, we can go for a capital I. But the reason why I use a lowercase one is because I try to just keep myself in the mode of always accommodating for negative numbers, number one, even though in this context, negative numbers doesn't make sense. And secondly, between the two, capital I and lowercase I, so an unsigned integer and a signed integer, they both take the same amount of memory size, which is 2 bytes. So to be fair, in this case, it doesn't really matter too much. So here, let's put in some ages, so age 22, 24, 27, 29. Let's go for 39, 35, 44, and 50. So this is our array of ages. Now, to use this comprehension to convert this into a list, it's pretty simple. So let me show you. So I'm going to call this variable here ages list, and this is going to be where we store our actual list for us to use. Now, with a list comprehension, there's a few parts that go to it. We have the result of what we want, then we have our for loop, and then finally we have our source of data. These are the three parts to it. And this is how I like to think about it when I'm working on our code. So the result we want, what is that? Now, in this case, we just want the individual items. We don't want any manipulation to them. We don't want the data to change. We just want each item in this array. So what do? So right over here, the result we want is an age. Now, the next thing we need is a for loop so that we can iterate over this list and grab each item in this array of items that we have here. So I'm going to go for a for loop here, and I'm going to say for age in. Now our source would be our ages array right over here. Now let's test this out. The first thing I'm going to do is I'm going to print out a type for the ages array to see what we had as a type before our conversion. And then we want to see one after our conversion, which is going to be ages list. Now, if we've done this correctly, the type should change from an ages array to an ages list. And of course, the final result should be a list with our values in there. So let's put ages list here. All right. So let's execute the code and let's see what we get. So take a look. So in our terminal here, you see that the first class is our array.array, which means our array class right here. Then this variable here, which stores the list, has now become a class of type list. And finally, we get our result here, which is a list of items, which in this case is our ages. Brilliant. So this is the first way to do this. The second way we can do this is using the list constructor. Now, we dealt with the list constructor in our previous lesson, so I hope you are acquainted with this. Now, when it comes to working with our list constructor, what we need to do is we're going to save a variable. Now, in this case, I'm going to call this our age, which is list constructor. Now, I'll call it cons for short so that it's easier to type for all of us. Now, how do we use the constructor? Now, what we need to do is call the list constructor, which is our list class. And then we're going to wrap our ages array inside of this value. Once we do that, if this is done correctly, then the type of the ages list cons should be of type list. Let's take a look. So I'll clear the terminal here, follow along with me, and then let's execute the code. There you go. So you see right down here on the fourth line, this is our fourth print statement. We have a class type of list. Now, how about going from a list to an array? Okay, so to go from a list to an array, this is where we can make use of the very powerful methods that the array module and array class gives us. So in this case right here, we're going to stick with taking the value that we have here. Now we can either use our list comprehension or we can use our ages list con, whichever one we want. I'm going to take our list comprehension here because inside of here contains our list, which is this value over here. So what can we do? First things first, we need to have a list item to convert. So I'm going to go here and I'm going to call a new array. Now this is going to just be called our ages empty array. Now I know the names are a bit funny here, but I just want to get the point across to you. This is why I'm using these strange names. So ages empty array. And in here, what we need to do is we're going to initialize an empty array because we want to fill the array with our list value. So we'll set this up as I. Now, whenever we want to initialize an empty array, all we need to do is just pass in the type code. The array class, which is our array constructor, will immediately initialize an empty array if we just pass in and fill in the first argument. Now, once we do this, what we need to do is grab the source where our items are. Now, right now, either one of these contain our ages array in the form of a list. So as I promised, I'm going to use the first one here, which is ages list, to do what we need to do. So we're going to call our ages empty array. We're going to hit it with dot, and then we're going to call from list. So the from list method, take a look at what it says. It says we can append items to an array from a list. And that's as simple as it gets. So all we need to do is pass in this variable here, ages list. And if this is done correctly, then we should see our list appear on the screen as an array. Now, what I want to do here, just to make sure that this is working correctly, is first of all, let's print out our empty array here. So ages empty array. Let's go for that. And then just to make sure that I clear any doubts, even though it says there's an array here, let's put the type on that. So clearing the screen and let's go. So here we go. Now what I'll do, just for the sake of teaching, I'm going to comment out all these lines because our terminal is getting a little bit large with data. And let's run this one more time. All right, one more time. Here we go. So you see here, we have our array. These are the items that are here, and you can see that our array has been populated with our list items, and the class type is array.array. Perfect. So this is how we can work with arrays and lists together. I'll see you guys in the next one. All right, guys, so let's talk about APIs. So what exactly is an API? Now, in computer science and software engineering, the acronym API stands for an application program interface. What does this mean? Well, by definition, an application program interface, or API for short, is a software intermediary, so essentially a middleman, that enables two applications to communicate with each other. So an API, in very simple terms, is the middleman between two different applications communicating with each other. Now, if this still doesn't make sense, don't worry. I want you to think with me for a moment as we take a look at an example of what this is. So, meet this man over here. He's our waiter. Now, imagine you're going to a restaurant and you wanted to make an order. And this is the waiter you received, and his name is Mr. API. Now, let's say you go over to a restaurant, you go over with some friends, and you want to make an order. So you're sitting at the table, you're having a discussion, and you're telling the waiter what exactly you want to order. Now, the waiter is the API here, and what we're requesting here is essentially our order. Now, in computer science language, we call this a request. Whenever a software entity wants a certain action to be done on that computer, it sends a message to an API to make a request. Now, after the request is made, there needs to be a response. Just like if we were going to go to a restaurant and we ask for some food and now our food is being served. In computer science language, if we wanted this to be our food, which in the same sense, if we wanted to get some sort of action done, the response that we're going to get back would come from our API. And again, this would be called a response in computer science language. Now, this request response structure that you see here is exactly how two different softwares can communicate with each other. This is how two computers can communicate with each other. This is how two electronic devices can communicate with each other. This is how two electronic devices can communicate with each other, and etc. So, keeping the idea of Mr. API in your mind as the waiter that is going to wait for your request and then deliver the request over to the chef, and then the chef brings the result of what you've ordered as food, which would be the response. So we have our API here. Our API is the middleman. It's always in the middle of every request that we make. Now on the left-hand side here, you can see we have these different devices. We have a laptop, a mobile phone, an iPad. Now, the side that takes care of making the request, which is the side that you and I work on when we're trying to get access to data, for example, from the internet, would be called the client side. Now, on the client side, first, we're going to make a client request to the API. When we make this client request, the API is going to receive this client request, and then it's going to make an API request. Where is it going to make an API request to? Well, before it does an API request, it needs to take the request we've made from the client and convert that into a palpable form, a readable form for the API to send that request over to the necessary place. Now, this process of doing so is called parsing. So when we parse the data, what we're simply doing is changing data from one format to another readable format so that a certain system, a certain piece of software can understand a request that's in a different language. It's kind of like having an interpreter. If we made a command in English for something to be done, and the person who's going to do this command only understands French, well, our API needs to take our English request, do a quick Google Translate from English to French, and then send that over to the necessary place. Now, that necessary place is called the server. Okay. Now, what does the server do? Well, when the server receives this request that we've made, then it has the responsibility of providing us with a response, which is exactly what it does. So we get a server response. Now, this server response is passed back to the API, and the API gives us an API response in the form that we need. Now, this architecture here is called the client-server architecture. And this is the architecture that underpins how we as humans all around the world interact with the internet every day. Okay? Now, when we make these requests and receive these responses, it's important for you to know that the type of requests we can make are, it's important for you to know that there are different types of requests that we can make to an API, which will eventually end up at a server. And equally, there are different types of responses that we can receive based on our request. Let me show you what I mean. So when it comes to server-side processes, there are different ways a server can handle our API requests, which ultimately started off as a client-side request from us, right? Let me show you what I mean. So we have a parsed API request. Again, parsing just means changing the format of something that is readable to another readable format so that it can enable the place where this data or this request is going to be sent to understand exactly what has been requested. Now, there are two major pathways that you're going to find when it comes to server-side processes. The first one is going to be when we send an API request to a server, that server request can also then make an appeal, which will be a request to cloud infrastructure. And when I say cloud computer, and when I say cloud infrastructure, I mean cloud computing infrastructure. So these can be things like Amazon AWS, Microsoft Azure, Google Cloud Platform, DigitalOcean. These are all very popular cloud platforms that allow us to carry out cloud computing processes in the cloud and then return whatever response needs to be returned, depending on what the client asks for, back to that client. So it could be on a mobile phone, a tablet, a laptop. The other major situation or the major process that can occur from the server side is that this request that goes to the server can cause the server to make a request for database activity to take place. So databases like PostgreSQL, MySQL, MongoDB, Oracle database, these are some of the most popular databases in the world. And once we make that request,
our databases can be activated to carry out different processes. So for example, storing user information, maybe deleting user information, updating the information that is stored in those databases, and etc. So these are the server-side processes that we can have. Now we're not done. The other side of the story will be the client-side processes. So when the server is sending a response back to the API, we can have our web client, which can be our laptop. We can have our mobile client, which is mobile phones. Or we can have our IoT client, which is an Internet of Things. It can be a range of different devices. Okay, things like, having Alexa in your home and different tools of that sort. So when the server sends a response, there are different types of responses we can have in regard to, which is going to be directly proportional to the request that we've made. Let me show you what I mean. Now, there are two major aspects to the responses we can receive from a server, which is passed down to an API. The first type would be WebSockets. Now, don't worry too much because in this lesson, I'm not going to go into detail about WebSockets, but it's important that you know the terminologies at least for now. Now, if you notice from the arrows here, that the arrows are two-way arrows, meaning that we have data going from our API to the web client and going from the web client back to the API. You can also apply that we have data coming from the API to the mobile client or the IoT client, and then data also going from these clients to the API. Now, this is a special type of internet infrastructure that we have, which is very useful for things like real-time chatting, sending messages to your friends, okay, sending messages on social media. That real-time chatting ability comes from the ability that is provided to us by WebSockets. Now, this form of response that we get here is technically a response, but it's a persistent response. And what this is called in programming is a full duplex or a two-way communication channel, okay? It's a channel that's always open, so we can send data to our web client, so we can say we want to send a message, and the web client can also send a message back without having to make a new request, which is what makes WebSockets unique here. On the other side of the story, we have notifications and JSON data, which are the most common things that will be received from an API, okay? Now, JSON data is the uniform format of data that is sent from an API to a client. Whenever we see data appear on the screen, 99.9% of the time, that data was in the form of a JSON object first, even if it gets passed down to text, but 99.9% of the time, that data would be JSON data. We also can receive notifications. Sometimes we don't always want to just receive a JSON object of data. Sometimes we might want to receive, like, say, a push notification on your phone. Like those annoying notifications on your phone from Uber Eats that telling you should buy more things because you have a discount, right? Things of that nature. Now, this form of communication is what we call a request response communication. Now, I know that naturally you think of it as a one-way communication, and in a sense, it seems like it because we get data from the API, it comes to the client, and then if we want to make a new response, we have to send another message. But I would say saying one-way communication would be deceptive here. The best way for you to see this is that we can send many communications, but once the response comes back from our request, the channel of communication is shut down until we reopen it again for a new request. Whereas with WebSockets, the channel of communication isn't closed in the same way. We can continue to send messages from the web client, mobile client, IoT client to the API and then back and forth again. Okay, so each have their use cases as to why we use them. Now, with this understanding about APIs, when it comes to working in Python, the idea behind how you want to write your code is you want to put yourself in a situation where you're able to write very good code, very clean code that allows you to extract data from the internet. Because if we were to just come to the bottom line as to exactly what APIs do and why we need them, they allow us to access data on the internet. They allow us to access things like maybe market data for, let's say, things like trading, which is why Python is very big in the trading space, which we'll look at in later lessons. Okay. You can also share data. You could send data to book an appointment for the doctors online. We have all of these different opportunities that are open to us through this client-server architecture. And so the idea behind building applications and writing code in any language, but specifically as we're focusing on Python here, is making sure you have the ability to access the internet in a very safe and intelligent way to build really good full-scale applications. Okay? So in the next lesson, let's move on to how we can write code to actually build out these API structures for ourselves and actually extract data from the internet. See you there. Welcome back, guys. So in this lesson, let's take a look at how we can extract data from the internet. So as you saw from our previous lesson, whenever we want to extract data from the internet, we can extract it using our client-side hardware. So that can be a mobile phone, it could be a laptop, it could be a tablet, any electronic device that has a connection to the internet. But the question is, how do we actually get that request to begin? How do we create that request? Which is what the title of this lesson is. And I want to show you. So we need to get access to the request package that is available in Python. So how do we do that? Well, at the top of this file, we need to use the import keyword, and then we need to tell Python what we're trying to request, no pun intended, because the package we actually want is actually called requests over here. Now, as a prerequisite here, if you don't have requests, and the way you're going to know this is that if you type in requests here and you have a yellow underline, you'll get a message from Python saying that failed to resolve this module. So all you have to do is, first of all, don't worry. Number two, you go down to your terminal, you type in pip install requests. And what this will do is that it will call the Python installation package manager to install the request module onto your computer, and then you'll be all good to go. All right. Now I already have it installed, so I'm going to get rid of this here, and let's continue. Now with this request module or package, it gives us access to the functionalities that we need so that we can actually create a request. Now to create a request, we need a few things, okay? So the first thing that we need, number one, is we actually need to have a target resource. This target resource can be, for example, a web page. All right. The next thing that we need to have in mind when we're writing our code is actually going to be what we want to do with the data at the target resource. Now we write this in programmatically into our code so that when we actually want to make the request, we can specify what type of request we want to make so that we get the action that we want returned back to us, the response we get back from the API. And that response, of course, would be directly proportional to the request that we've made. So let's start off with the first part. Now for this demonstration in this lesson, I want us to make use of a very good tool. In fact, a fantastic tool that I love to use to teach from. It's been something I've used over the years that has been really useful when I want to test out different types of API calls that I would like to make. Okay. Now, where do we get this from? If we want to get some data as a target resource that we can use, we're going over to a website, which is called jsonplaceholder.typicode.com. It's an absolutely brilliant resource, and I strongly encourage you as you're learning to become a software engineer to make use of this website.
It's free, it's fast, and it's very reliable. Okay, so if you want to find this website, you can search for it on Google, or you can follow the link beneath our lesson here, and you'll be able to go straight to this area here. Now, once you get here, what I want you to do is scroll down to the bottom, and let's take a look at our actual resources. So when you make an API call, which means we're going to make a request that will be passed to an API, and the API is going to pass that to a server, and the server can handle it, as we said, in different ways. So it can go to a database, it can go to the cloud infrastructure, it can go to even another server as well, in some cases, right? Now, when we make this API call to request some data, we need to have a source. Now, JSON placeholder, thank God, is being created to have a source of data. It actually has 6 common resources that we can get access to. So we have access to data called posts, comments, albums, photos, to-dos, and users. So let me pick one at random. So let's say we want to get access to users here. Take a look at what happens. So as this page is loading, you can see here that we have these very large data structures here that contain a lot of information. Okay, so we have the ID, the name, username, and etc., which is very commonplace if you want to store information about users in some sort of web-based platform, okay, or even a platform that is offline. Now, in our case, we're working with data that is online, so you can think of this as working with a database of data for some sort of online website, like an e-commerce shop or something. Now, this is actually an array of objects, okay? From the first curly brace to the last curly brace, this entire expression is an object of data, which contains key value pairs. So the key being the field name. So for example, ID, name, username, and then the value that matches that specific key. Now, if we wanted to get this specific data programmatically into our code, let's say just to display on the terminal for now, how would we do something like this? So the first thing we need is the URL, because that will provide us our target resource. So click over here, make sure you click on the right thing. So follow along, copy this. Let's go back to VS Code. And for now, I'm just going to leave this over here. Now, the second thing we need to have is what we want to do with this target resource. Now, the thing is, which I didn't mention in the previous lesson because it wasn't time, of course. But anyway, in this lesson right here, now is the time for us to take a look at this second part here, which is that when you make a request, not every request is the same. Even though we're making a request, so principally speaking, we're requesting for something, the type of request we can have from our client position can be different, okay? Not all requests are the same. And it's important that you note that from early, okay? So we need to make a decision about what type of request we want to do. And the request that we want to do, that we're going to create programmatically, needs to be mentioned in our code. Otherwise, we'll get results that we're not looking for. So with this first part here, number 1, I'm going to save a variable called URL of data source. Okay. Now I know it's a very long variable name, but this is for teaching purposes, so not a problem at all. Now you notice here, if I paste this in as it is, we have an error because we can't paste in a hyperlink just like this or a URL just like this. We need to wrap it in our string brackets here, as I call them, which are just speech marks, but I call them string brackets. Okay. So now we have a data source here. This is our target resource. Next, we need to actually describe to Python how we want to deal with this target resource. Now, in this specific case, I'm going to write the code first, and then I'm going to explain a point to you afterwards. I'll show you what I mean. So over here, we need to make use of our request package. So
if you do request dot, you'll notice that there are going to be a lot of different pieces of information here, lots of different options here in a drop-down list. So many things are going on here. You can see that there's over 40 to 50 different options right here. So it looks a bit confusing, but trust me, it's not. Now, whenever we want to extract data only from a target resource, the type of request we're making is specifically called a GET request. So we need to select the GET method here. Okay. Now, the GET method has many different arguments that we can pass in. For now, I'm not going to pass in any arguments just yet, because I want to make a point here about the theoretical side of working with requests. Now, when you make a request, as I said earlier on, there are different types of requests that we can make. Let me show you what I mean theoretically. So, if you guys remember this diagram over here was the teaching diagram that I created for you to teach you about the client-server architecture. So, with the client, we make a request to the API. Our request is passed into a API request, which is readable to a server. And then the server sends us a response. The API takes that response and turns it into an API response for us that we can read on our screens and do whatever we want to do, depending on the request. Now, my focus here is this section right here, the client request. Because as I've said, even though we're making a request, the types of requests we can make can vary depending on what we're trying to do. So let's take a look. So we're back again with our client, and we're going to make a client request. Now, there are 4 foundational requests that can be made, and there are a maximum of 9 request types that are available for making a request from a client. Let me show you what I mean. So the request is going to be passed through using parsing. Now, when we make a request, again, as a client, as a user of a website, a user of the internet in general, there are many different things we want to do. Some days we might want to log in somewhere and play a game. Other times we might want to search for an image and grab it to use it in a PowerPoint presentation. Long story short, there are many different things that we can do when it comes to making a request to the internet for something. So, for example, we can say we want to visit a website. Now, if we want to visit a website, what kind of request would that be? Well, we'll find out. So what else could we do? So apart from visiting a website, we could send an email, which is very common for us to do. Or we could change our passwords, which is another common thing that we can do. We can remove our address from someone. Okay, maybe we've moved house, so we need to remove our address completely, or we just want to get rid of our address from a dodgy place that we don't trust, right? These are all common things that all of us do when we're using the internet. Now, how does that translate into requests? Now, all of these 4 different actions here are actually 4 different types of requests. And programmatically speaking, we have to handle them differently. Let me show you what I mean. So for visiting a website, sending an email, changing your password, or removing your address, even though they're all part of the internet experience, are very different programmatically when you write the code. Okay? So starting off with the first one, visit a website, we call that a GET request. Now, a GET request means that we want to get some data strictly. We're not trying to change anything on the website. We're not trying to change the data structure. We just want to retrieve that data for our viewing. How about sending an email? Well, sending an email is what we'll consider to be a post request. Why is it a post request? Well, a post request is designed to allow us to have data in our client side. So this can be, for example, an email will contain the subject, it will contain the body of the email, which will contain all of the message that we're trying to send, maybe an attachment. All of that data is bundled up in what we call the request body. And the request body, when we call our post, is going to be transported over to our API. The API will take it over to the server and then distribute that data to the person it's addressed to. And this is why it's called a post request. Whereas again, with a GET request, we're not going to have any data in the body. We're just sending a request to extract some data. How about changing your password? So if you want to change your password, this would be a put request because the target resource, which could be, for example, a database, already has a password and an email and other information about you. All you're looking to do is to update that data inside of your area, which would be your database, but you would see it, for example, on a website as your profile area. Let's say apart from changing your password, you wanted to change your entire identity on that page. This will also be classified as a put request. And finally, removing your address. So if you want to remove your address from a place, in this case will be our target resource, which is the correct terminology, that would be a delete request. And the delete request, we can simply send the command over to the API to tell the server to tell the necessary resources to delete our address. So these different types of requests are what we call request methods. Again, there are more than just these four, but these are the four foundational ones that you're going to come across 90% of the time. Okay, the other five are not used as much. They do have their use cases, but I do believe you can get by starting off being a programmer and at least getting to the intermediate level without ever interacting with those other five. So for this lesson, I won't be going through those. All right, let's go back to VS Code and finish off our code now. Now that you have this understanding, with this GET request, if we pass our URL in here, we'll be able to grab some data. So I'm going to type in our variable name, which is URL of data source. Now with our data over here, take a look at what we have. If you hover over GET and you scroll down, you see that it returns a response. Now the response is going to return contains a few things. All right. Now response number one contains something called a status code. And this is a mandatory piece of information that is designed in the HTTP infrastructure, which is the Hypertext Transfer Protocol. Anytime you make a request for something or you send any sort of request from a client, you always will receive a status code. Now, what's not guaranteed is if you're going to receive data or an error. But what is guaranteed is that no matter what's going on, you're going to receive a status code. And this helps us as developers and also helps the systems we're working with to understand how the request went when it was sent. So one of the most common ones you'll find is status code of 200, which means okay. This is a very, very common one that you're going to find in code all over the place. You'll find it all over server architecture and client server architecture. 200 means okay. So if we make a request, providing that, for example, the URL we have is correct, there's nothing wrong with the server that contains the information we need and also the database, then if we make a request, then we should get a 200 response, okay? Now, there are many different status codes. We're not going to go through that in this lesson, but I just want you to have that in the back of your mind as to what a response is. Now, the second part of a response is the data. Now, this is optional because we may not receive data. A response object, if the request is not successful, we may not receive data, okay? But if the request is successful, we will receive some data. And number three, as I mentioned earlier, is an error. Now, we can optionally receive an error in the situation where we have a problem with our API call, okay? Now, the status code will always let us know first if there's a problem, but we'll also know from the error what specifically has happened, okay? So our status code, if there is an error, is usually in what we call the 400 category. So for example, we can have an error 400, or we can have an error 404, okay? Meaning that, for example, we have the page not found, we have a bad request that has happened, okay? So we have all of these different
status codes, which is a system for us and also for computers to understand exactly what went on with a request. All right, so enough talking now. What's next? Well, we can save this as our response. Now we have to handle our response elegantly. So we can say response, and we use our dot notation here. Now you see that we have a function over here called raise for status. What this function does is very powerful. What it does is that it's going to keep track of the status code of this request. And if you notice here, it says that it raises a HTTP error if one occurs. So when we have a status code, it's going to tell us what the status code is for the request we've made in our response. And what about the actual data? Well, let's call this 3, getting the data. Now, when it comes to getting the data, data comes in different forms. Now, I'm just going to store a variable called data, and we're going to say response again. Now, if you look over here, we have this function here called JSON. Remember earlier on, you heard me saying that we had an object, an array of objects, okay? Now, the standard way that we store information in computers when it comes to what you've seen in, for example, a database structure, where we're storing, for example, users, as we have on JSON type code. In that example there, the data had these key value pair fields. That structure is what we call the JSON structure, okay? What does JSON stand for? Now, first, we're going to call JSON because we need it, but I'm going to leave a little note here. So JSON stands for JavaScript Object Notation. Now, you're probably wondering, why JavaScript if we're writing code in Python? Well, when JavaScript was introduced in 1994/5 by Brandon Each, he created a system that allowed us, as advancements continued with ECMAScript, to have a uniform or standard way to share information between computers in a very clean and clear way. And so this is where JSON was born, which was the object notation of describing data in key value pairs in curly braces. So the most common format that you'll find data in when you're going to receive it from a API call is in a form of JSON. Now we can control what data type we have or what the shape of data would be by changing what we have over here. So apart from JSON, if I click on this, you see we also have text. Now in this case, we don't want text because the data that we have, as we've seen in JSON placeholder.typecode, or just JSON typecode for short, as I like to call it, is in an object formation, okay? So for now, we have our API call. Now, the last thing we want to do is we want to print this on the terminal. So if we print data and we run our code, we should get our users appearing on our terminal. Let's take a look. So if I type in Python, and then what we want to do is run the name of our file, so apis.py. Now, if you're on a Mac computer or Linux, Python would be Python 3, okay? If you're in a Windows computer, it's simply just Python. If you're on a Mac again or Linux, it's Python 3. This is how you can write the command from the terminal. Now, if you don't want to do this, there's a really nice tool you can go for. I'll show you with my extensions over here. So if you type in code run, okay, you'll see that you have this .run show up here by June Han. It's a very powerful extension on Visual Studio Code, and it's been downloaded by 28 million people so far. Now, if you click on this and you download it, what does it do? Well, it allows you to run your code without having to make this call to Python and then the name of the file, which can get boring and sometimes, well, it's not hard to make a mistake, right? So if you install this, it doesn't take long. It's very quick. Once you've done that, you click back on here to get on your files.
Instead of running your code over here, you can run it over here. Now, the only downside to this, as I mentioned earlier on in the course, if you heard me talking about this run button, is that if you run your code from here and you have an import function, the built-in Python import function, you won't be able to import anything because it's a read-only structure. So then you're going to have to call Python from the terminal so that you can get the read and write structure that you're looking for. Okay. But in instances like these where you just want to execute some code, you're not really trying to do any of that stuff with import, then you can run the code from here. So if we click on run here, you see it's loading. And there we go. So if I scroll up here, you notice we have a very long list, okay, or a long array. Now, arrays and lists are not interchangeable. They are different, but from the context of the website, it's an array. From the context of Python, it's a list with these square brackets here. So you can see here, we have all of this data showing up in our terminal, which means that our API call was successful. And the response we got was correct. Now over here, with this function here, you may have thought that it would be good to print out this line here as well, because it will give you a status code. But it won't give you the status code because you can see from the type annotation, it returns a none object. So it's not going to return anything to you. So if you try to print this, nothing's going to happen. Okay. If you want to find out about your status, you have other ways to do it. But again, guys, I hope you really enjoyed this lesson. Let's move on how we can increase our skills when working with extracting data from the internet. Take care, guys. So, as you saw from our previous lesson, both from the theory and from the practical side of learning, we can programmatically write our own API call requests directly in our code, which is pretty cool, right? Now, when we run our code here, as we saw in our previous lesson, our endpoint here, users, returns us all of the data in our user section, okay? So if we go over to JSON type code and we take a look at the code we have, you see that we have a list of objects over here. Now, our curly brace is our object structure, and our square bracket is our list structure. So this is what we'll call a list of objects. Now, lists and objects are collection data types, which is a special data type section within Python that allows us to, as the word entails, collect and store data, okay? Now, scrolling down here, you can see that in terms of the shape, because we have pretty print on, you can see that we have the same values here, ID, name, username, email address, as we go down the list, but then the matching values, okay, 10, the name, username are completely different for each person. So we have our keys here, which are the same keys, and then we have our values, which are different values. Now, when we make a GET request, as I said in the previous lesson, we don't send any data in the request body, but there are two places where you can send data when making an API call. If you want to send data for a certain configuration, or you want to configure your request, we can send data through our request body, and we can also send data through our parameters, okay? Now, a lot of times when you see this type of code, you see the keyword params, which means that we're going to pass in a parameter. Now, what is a parameter? Let me demonstrate to you what I mean. Now, at the moment, we're on the users section of our JSON type code page. Let's say we wanted to just get access to user number 1. How would we do that? Well, we can add another / here and put 1. And if I press enter, take a look at what happens. So we have a little loading period, and then our code shows up. Now, really what happened under the hood is that when we put /1, our JSON type code API, our JSON type code API made a API request to the server, which is the database, to extract just this value and display it on the screen, which is why we get 1. Now, of course, if we type in 1, then 2 and 3, for example, 3 here, and we put it in,
You see, we get completely different data, but we get just that data. Now, when you think about real-world applications, this is a very useful thing that we need for several reasons. One reason is because when we want to extract data from a database, we don't want to extract all the data that is available on that database. We don't want to extract all of that data that's available on the database in one go all the time because it's not necessary. Sometimes we just want to extract specific pieces of data. So maybe we want a few users. Maybe we want a user whose first name starts with C, maybe, or we want to have someone who has a website that has .com only. There are so many different specifications we can make when we want to get a GET request done for ourselves in our code. When we want to get a GET request occurring for our applications. So if we wanted to mimic this programmatically, how can we do this? So let's go back to VS Code. Now in this lesson, we're going to go through our gets, our post, our put, and our delete. So you stay tuned as we continue writing our code. All right, now back in VS Code, we need to make a few changes. And I'm going to show you different ways that you can implement this so that you can be the most dynamic Python programmer for your future and your future career. So at the moment, we've hard coded this URL here, and it's limited for us, is limited to us only using this to extract all of the data. Now we want to have a situation where we can say /1. But the problem is here, if we write our code like this and execute it, the only data we're ever going to get from our API response is going to be the first user in the list of users, which we don't want. So how can we programmatically make this a dynamic value? This is where we're going to use what I've taught you in our previous section, which is to use a function. So we need to declare a function here. Now I'm going to call this get user data. Now with this notation I have here, with this syntax that I have here, this is the syntax that we would call camel case syntax. Now, very commonly in Python, camel case is not really the preferred way of writing code. What you will normally see in Python is snake case. Now, what does snake case look like? So snake case is like this. So we'll say get user data. This is the preferred way of writing code in Python. But if you're someone who wants to use camel case, you can by all means go ahead and do it. But I would say that as you work on more complex Python projects and work with people who are Python developers 360, so that's their main programming language they use, you're most likely going to see this form of syntax. So the snake case syntax is going to be all lowercase for each word with underscores to separate each of these words here. Okay, so the first letter of each word would be lowercase, and then we have our underscores between each of these. All right. So in here, what we want to do is move all of this code that we have in here. So we're going to have our URL source over here. I'm going to switch this back for a moment. All right, I'm going to tab this over. Now remember, Python is a programming language that keeps a track of white space. And because it keeps a track of white space, so we'll move this over here, we need to make sure that we're always 4 spaces to the right from the beginning margin on the left, okay? This is just the way that Python is created, has been created. Now, as we looked at in our section when we're looking at Python formatting, this is a standard that you must have in your code. Now, in some instances, if you get the right extension, if you save your work, so you hold Command and S or Control and S if you're in a Windows computer, then you can get some reformatting done for you sometimes, okay? But just keep that in mind when you're writing Python code. All right, so now that we're here, what do we need to do? Well, using what I taught you from our previous lessons, we need to pass it in a parameter. So we need to create this function. We need to allow this function to accept data externally when this function is called. So in here, let's call this our user ID. Now I'm just going to use camel case here, but if you want to, you can call this user ID in this fashion as well. Both are acceptable, whichever way you want to do it, okay? So with our user ID here, this parameter, we want it to accept an ID number. Now, this is beyond the scope of this course, but we can have type annotation here. So we can say, for example, that this is going to have to be of type, and then we can say it's going to be of type integer, which is something that we have in Python. Now, you don't need this, but it is useful for readability purposes, okay? But I won't use this for now. Now, when we pass our data into our structure here, we need to pass it in such a way that when this function is called, we can pass in several values. So it doesn't only have to be one, like we saw just a moment ago. It could be 5, it could be 10, okay? So how do we do that? So in the section when we looked at working with strings, I told you about the special keyword that we can use, which is literally just a letter, which is the F string. Now, if we put an F in front of a string, it allows us to pass in variables with that string. So this is what we call string formatting, okay? So right here, if we put a forward slash, we can put curly braces here, and we can pass in ID. Now, what am I doing here? Well, when this function is called, the function that we have right now is going to require one positional argument, as you've seen in previous lessons. And in that positional argument, we can decide that we want to pass in any number between 1 to 10. Now, of course, we want to make sure that we pass in the right value, but this function as is written right now doesn't limit us not to put the correct value, okay? But for now, we're going to test out putting the correct and also the incorrect value inside of our code. Now, once we've done this, we can handle our response the same way. So our response is going to be a request. We want to do a get request, and then we want to pass in this expression of our string, okay? Now, in here, to make sure that we have our code and it's coming up on the screen, or you want to have some messaging in our terminal to tell us that this data request has been successful, we could have an if statement down here, okay, which would be using our conditionals. For now, I'm not going to do that. We're just going to start off with this first aspect, which is just to make sure that this functionality is working. So what next? Well, with the current code we have, we're going to need to call our function here. So we need to say get user data, and in here it's going to be looking for a value. So in here, let's say if we put the value 1, what we should get when we run this code is that we should get our JSON object that we're going to print on the screen, which has a user ID of 1. Now, the thing is, with the way that our forward slashes work, the forward slashes work in tandem with the shapes of our object, okay? So the user ID, since it's the first property in every object, forward slash user ID, which is what I have here, would mean that we're passing or looking for the user ID of the specific value specified. So if we run our code right now, let's see what we get. So you see, notice that as a response, we get ID of 1. So if I try this again, and let's say we pass in ID of 3 now, and we pass this in here, you see, we get ID of 3. How about if we put a value that doesn't exist? Now, in our code right now, JSON type code has 10 users in our list of objects. So let's say I put in here 11, okay? And we try to test this out. Take a look. So you see we get a traceback, which means we have an error. And it tells us here that we have an issue. Now, the exact exception that gets raised is what we call a HTTP error. And you see the error over here is 404 client error. Now, when it comes to the status codes we have, there are several status codes we can have that range from what we call the 100 class all the way up to the 500 class. So anytime you see an error that that begins with a 4, it means that it's an error on the client side. So there's something wrong on our side, maybe an internet connection, our code isn't correct. We have quite a few issues here. Now, specifically, error 404, if you've ever seen it before, using the internet, all that means is that there's something wrong with our URL. Maybe this URL has a typo or the data we're requesting doesn't exist, which is what we have in our case, okay? Now, if you want to programmatically write in our code without having to call this function every time, we can decide that we can do this in more than one way. Now, if you want to write your code in this format that we have here, it's absolutely fine. But I do want to show you the other ways that you can go about writing code in this fashion. All right, so the way we've written our code is absolutely fine. We can write our code in such a manner where we can pass in our ID as a parameter. Now, another thing that you can do, or another way that you can execute this code is as follows. Now, with this get method that we have, which is a function attached to this module, we have access to some other really cool features. Let me show you what I mean. Now, when we want to make a parametric request, which is what's going on because we're passing a parameter into a URL. So JSON placeholder.typecode.com is our base URL. And then /users means that we now have an endpoint, and then user ID is another endpoint. So we have two endpoints and then our base URL. When we have this kind of structure, we can provide what is called a parameter object. Okay. Now remember, an object has a structure like this, which is these curly braces here. Now, what we can do is we can provide parameters. So let's call this our parameters. Now, parameters are like our configurations. These are our specifications as to what we specifically want to get out of this GET request. Okay. Now, very commonly, parameters would be called params for short. And in many programming languages, including Python, you'll see the word params come up a lot in different cases when we're dealing with something that is to do with parameters. Now, in here, we can provide a key value pair structure. Specifically in Python, if you see curly braces, which we use to represent objects, it's also called a dictionary. Okay, so we call this a dictionary. Okay, and we also say object. I'll write this here. Now, what could we do? Well, with the code that we have here for our users, okay, and let's go back to JSON typing code so you can see this. Each of these values here, ID, name, user, email, are very special. As I said, they're called the key. Now we can provide this key with our GET request so that when we send this GET request, we can tell the API that, hey, when you're going to look for the data that has this key and this value. Okay. Now, because we store our data in this structure of an object as well, which is a way for you to always remember this, we also want to pass our parameter in the same way. So our parameter that we're going to send over to this API, we want to make sure that we send it as this object here. So I want to come back. Let's go back to VS Code again. Let's go back to VS Code again, and then we're going to write in some stuff here. Now, at the moment, we're dealing with user ID because that's the name I suggested. But here, if we want to successfully do this, we need to make sure we use the same name that is available in our JSON typing code over here. Now, over here, let's pass a string here. I'm going to pass ID here. And then what I want to do is I'm going to say it's our user ID. All right. So with this slight change, what am I doing? Well, we're still going to receive the data that comes in from our user, but we're specifically telling our endpoint that we want the data that we're going to pass into this function to be assigned to this key, which exists in our data called ID. Okay. Next, what do we need to do? And this is the part that gets really cool. In our GET request, it can accept more than one argument. The first argument, of course, is our URL, which for now I'm going to remove and set it back to just users here. But in here, we can decide that we want to add a second argument. Now, this argument would be a keyword argument called params. Okay. Now, this params over here, we can pass in our parameters. Now, remember keyword arguments? Keyword arguments allow us to label data and also leave default data values if we need to. Now, this params keyword here in our GET request, under the hood, what's going to happen is that when we make this API call for the GET request, Python is going to look at this params parameter, which is going to be an argument when we pass in the data, and it's going to add this expression to the end of this endpoint, so that when we make our search, it's going to search for data based on the ID and the user ID, okay? So when we do this, what we should get is if we pass 11 here with ID, it should give us the same result. So we can clear our output over here. Once we clear our output, then what we want to do is execute our code. Now you see, notice what happens when I do this. It gives you an empty object because we have 11 here. How about if I change this to, let's say, 10, which is the last one here. So if we run 10 now, you see, it gives us ID number 10. So now we're passing a dictionary object into our endpoint so that we can run our code. All right. Now in JSON type code, this is not the only thing we have. We also have name, we have username, we have email, we have address. Now, very commonly in real world applications, we might want to search up someone by their username. So let's say we have username Samantha. I'm going to grab this. This is for ID number 3. If we go back in our code here and we decide that instead of just passing in an ID here, instead of saying that we only want to look for an ID, how about if we make our function a little bit more dynamic? Now, to make our function more dynamic, what could we do? Well, in here, apart from just passing in the data, why not pass in the key? So let's call this key. And over here, we'll provide key. So now we have our own key value pair structure. What does that mean? Well, now let's say we wanted to find an ID of 10. In here, we'll pass in ID like this, and it has to be a string spelled correctly. Now, if this works, what do you think is going to happen? Well, when we send our code through, what should happen is that the GET request is going to look for this key value pair structure that we provided based on the values that we passed in here. So if I clear the terminal and we pass this here, you see, we still get 10. Now, with this structure here, that means that we can also do other things. So let's say we wanted to get a username. And with this username, we want to get the username of our person here, which is Samantha. So you can, again, go over here and copy this so you can code along with me. I'll just paste this here. And we're going to say we have Samantha here. Now, because Samantha is a name, which is a string, we need to pass in Samantha here. Samantha. Good. So when we make this API call for a username called Samantha, then we can run our code. And you see, it gives us ID 3. So this is another powerful way and a very common way that code will be written so that you can have dynamic GET requests. Now, we're not done. Another thing I want to show you here is that when we make these GET requests that we're doing right here, you may think, oh, well, this is pretty repetitive. We have to write our function, then we're going to call our function. What if we just want something to just happen? Well, unfortunately, with code, nothing just happens, but we can specify that certain functions should run over other functions. Imagine if we had another function inside of here, and we'll call this get other data. Now, for now, I'm just going to leave this blank and just put pass in here. But as it stands, this apis.py is a file that we will consider to be a Python script. Just like when you go to a play, you know that the actors are following a script. Now, sometimes we may not want all of that script to be said. Maybe some things are just notes on the side, or some things are just not to be executed right now, maybe at another time. So what can we do to resolve this issue? Well, in Python, when we run our script, if we were to run our code from the terminal without the code I'm about to show you, then what's going to happen is that whatever function is in here will get called. Secondly, if we were to decide that we want to export this function, to export this data out to another place to use it, then all of the functions here will be available and any of them can be used. But maybe we don't want our code to be like that. Maybe we want only one function to run and others to run based on only certain conditions or under certain conditions. So what do we need to do to change our code? Well, what we can do is I'm going to introduce you to an important syntax here. Now, if you've been looking at our code from the beginning of our sessions to the end, you'll notice that a lot of times when you look at your code, you find these strange looking names that have these underscore underscore syntax. So for example, underscore underscore RPL underscore underscore. Now, depending on what context you're dealing with, these have different meanings. Now, the term for these are what we call a dunder, okay, which just means a double underscore. And they have meaning across Python for different things. So for example, if we're working with object-oriented programming in Python, these double underscores will represent a magic method, as it's called. Now, if you're working with functional programming, which we're doing, these can have meanings for how we work with this file. Now, a very common syntax is if we use an if statement, which you know what that is, which is a conditional, and we say underscore underscore name underscore underscore equals to underscore underscore main underscore underscore. Now, this expression over here probably looks very weird, and I understand. Now, what does this name section here mean? Now, name is a very special dunder, it's a very special variable within Python that stores the name of our file. Now, depending on how we use our data, if we're exporting this data to another place or we're using it in our code, the name would be different. So for example, right now, in our code over here, we have the underscore underscore name. And because we're dealing with our direct script here, which is we're going to run our code directly from this file alone, the name of this file is called underscore underscore main as a module. So let me show you how we use this. So the underscore underscore name convention, which is our dunder, will allow us to control the control flow of our application here. Now, I consider this an application because we have just one file here. But let's just say we wanted to expand on our way of writing code and we wanted to introduce some importing. Let me show you. So here, let's just call this API helper.py. Okay. So with API helper.py, if we wanted to use the functionality that we have inside of our APIs module, how would we do that? Well, we use the import keyword, and then we're going to type APIs, which is the name of the file. Now, what's important to note here is that this syntax that you'll see, which is very common with Python developers, which is something very common that you would do as a Python developer, is when we want to control what function we call or what functionality we want to run, if this module is called by itself, we define it after this if statement block right here. But if we want to use our code here, so our get user data function, and also this get other data function that we've just have for now. If we go over to APIs, take a look. If I type in APIs dot, you see we have access to both of these functions for our use. Now, if we call our get user data function, you see it asks for the same parameters. You see that it has the same parameters and it has the same arguments that we can use, that we used in our APIs call here. So in here, to test this out, if we decided that we want to have another search, so we have Samantha now as a username, let's find another username on our Type It Code website. So back to JSON Type It Code, I'm just going to pick a value at random. I'll just go for 4. All right, cool. So right now we've got Patricia Lebsack, and the username is Karain. So we're going to grab this line. Hope I said that right. Karain, Carrie Ann. All right. So we'll copy it over. Let's go back to our code. So now in API helper here, if I pass in this expression, so we want our key and value pair structure. Now we have it in reverse order, so the value is first. So we'll call this Carrie Ann. And we'll also put this here as username. Now you're probably wondering, with our parameter names, user ID right now is probably not the best name because right now we're using username, and you're absolutely correct. So one of the refactorings you can do, which is really important when testing out your code, is making sure you have good variable names, parameter names, so that when you're passing in arguments, it's very clear what values should be passed in if somebody is using your code for some sort of execution, right? So over here, instead of user ID, we can change this and call this value. So scroll back up, go to value over here. We'll also change this to value too. So now we have what we would call a more generic set of parameters. Now we have these generic sets of parameters. It won't take away from our functionality. It just gives us better naming conventions within our code. All right. Now the proof is in the pudding here. What do I mean? Well, if we execute this function successfully, then it means that we can make API calls outside of our API's file, which when we import it, you can consider this API file to be a module. So over here, we use the terminal this time so that we can keep this over here for comparison. All right. So remember, if you're in a Mac, you need to type in Python 3, okay, lowercase Python 3, and then the name of the file. So API helper, okay, .py. Now, when you do this, Python is going to run our code and run it like a script. So it's going to execute everything within that page. Now, if you're in a Windows computer, like I am, we don't need Python 3, you just need Python. Okay, so if we press enter, you see, it runs our code. And over here, you see that we actually get two results back. So when we pass in Karina as a username, it gives us our username Samantha here, and it also executes username Kareem. Quite interesting, right? Why is it that when we call API helper, it executes Samantha, because we see we have username Samantha, and then it executes what we asked for. And this is the thing about using our underscore name. You see, what happens is when we run our code in this fashion, what's going to happen is that Python is going to run what is called a resolution order. Okay, this is a module resolution order. And a module resolution order essentially is a definition based on an algorithm that we can talk about in other videos that allows us to order the way in which executions can happen. So if you use object-oriented programming, the MRO is very common to be used for ordering what we execute first. Now, based on the way that we've written our code, because we have our file here name, when we execute API helper, the first thing that happens is that we need to import APIs. By importing APIs, it's going to execute this code first. When it executes this code first, it's going to run our expression here of underscore name as main, because at that time, the module would be set to main. After the import is successful, then this code will run afterwards, which is exactly why we get this execution. So when we have what we call script initialization, when this script is initialized or this script is called, this function will be called as well. Okay. Now, if I change the order here, just to give you some insight into what's going on. So if I go over here and change the insight over here, and I'm going to go and run our code from the APIs page. So let's clear this and let's call Python apis.py. Take a look at what happens now. So our code runs the same way, even though we have this execution here with our Python. But if I was to go to the output section here and run this code, same thing. So you see, there's no changes whatsoever when we call our functionality here in this manner, okay? But of course, if you comment this out and we run our code over here, so now I'm going to run, this is commented out, but I'm going to run this expression of get user data with the new username that we have over here. So we can even use output. So I'll just run this from here. Now it only executes this code right over here because this is not being called at all. In fact, we pass when we get to the end of this module. So After the import, the next thing to do will be to execute the next code, and we get just this code over here. Okay. Now putting this back down here, when you want to run code in Python, it's a good convention to use this underscore name convention when you want to make sure that in this script, we execute a certain portion of our code and not everything. Because some of the things we might have in our module will still have the same single responsibility. So they'll be having related functionality to fit one responsibility. But maybe some of those functions only need to be called in certain conditions. But the thing that we definitely want to happen would be this function every single time we run the module. So this is what our underscore name convention allows us to do. Okay. So now you've seen there's a few different ways we can execute our code, and you can use these to your benefit when writing code. All right. So in the next lesson, let's crack on and take a look at the next type of request, which is going to be our post request and how we can handle those. I'll see you in the next lesson, guys. All right, guys, welcome back. So in this lesson, let's take a look at how we can handle post requests. So with our get request that we looked at in our previous lesson, you understand that we have many different ways in which we can execute the expression of this code. Now, the key thing I want you to take from our previous lesson that we're going to use in this lesson is the fact that we can pass in parameters using an object, which is called a dictionary in Python. Now, with a post request, as we looked at in our theory lesson, so before our get lesson or handling our get request lesson, you remember that a post request is designed for us to be able to send data in the request body to our API. Now, why would we want to do something like that? Now, when we send data along with a request, like as we sent a request using a get request with our parameters here, it allowed us to have some control as to exactly how we want our response to be handled. It also provided us a way to give specificness to our code. So instead of extracting all of the users, using our parameters here, we're able to extract the user that we want. And we went one step further by even allowing ourselves to extract users based on different identifiers. So by their username, by their ID, and etc. Now with a post request, when we send that data over, usually we're trying to send that data to a database resource so that we can gain access to an area or to save some data that needs to be saved and processes like that for etc. So this can be things like logging in with your username and password to your Amazon account. Every time you need to log in to your Amazon account, you need to send your username, which will be your email or phone number, and your password over to the server. Now you do that through the API, and if your password and username check out to be correct, then you're going to receive a response. But the response you're going to receive is not going to be necessarily a message on the screen. It's going to be in the form of you having access to your profile area. So we want to create requests like that in our code for many different reasons when building modern applications. Most modern applications, if not all modern applications, are connected to the internet in some form or fashion. And there's usually going to be some sort of logging and sign up process. So in that same manner, if we wanted to post data and store it, for example, in a database, we can do it with JSON typing code. So let's go back over to our page. If I was to go back to our main page, so let's go back to the main page, you'll see over here that we have some information on the route system or how we can make available data in our code or carry out other processes. So you can see here, if you look at the endpoints and we scroll down, if we want to make a post request, JSON placeholder has made post available through the /post endpoint. Now, if we post data to this endpoint, what are we doing in this case? Now, in this case, if we want to post data to an endpoint, what we want to do is add new data, which is another thing that the post request can do. So whenever you want to make a post on social media, which is a very common thing that we all do, posting a new story or posting a tweet, posting a picture, video, and etc. That terminology of making a post really under the hood is us sending data from our client device. So it could be a mobile phone, a tablet, a laptop, computer, and sending that data over to the API, which goes to the server, and the server handles whatever we need accordingly based on the resources that it's connected to. So if we make a post request programmatically from our code, using this API, which is our JSON placeholder API, we can actually post a new post with this URL /post. So let's grab that. So right over here in the resources section, we have posts. So if you click on that, we can take a look at what we have as code. So the code that we have here, the format it is in, the format it's in is absolutely fine. But if you ever get a format that looks a bit weird, you can click over here to get Pretty Print to show up. And Pretty Print just formats our objects to look really nice. If I take it off, you see that we get this random, almost random looking object of data. This is kind of how it shows up on our terminal. But if you want it to be pretty, you just click on Pretty Print and there you have it. Now, by default, it's already set to Pretty Print when you try to extract data or view data from your browser. So you don't really need to click on this the first time you load the endpoint or search the endpoint out, okay? So here's our post. We need this URL and we're going to make use of it. But just before we go back to VS Code, I want you to take a look at what we have over here, okay? So on our JSON type code website here, we have the shape of our data, which is called the schema. And especially when it comes to working with backend development and also areas of front-end development like validation logic structures, we need to know the schema, which is the shape of data. Now, our schema has 4 properties: user ID, title, and body. And what we want to do is we want to make a new post that is in the same shape of this data. Now, to do this, we have to create our functionality in Python, and that's exactly what we're going to do. So follow along with me and I'll show you what we're doing here. All right, so back in VS Code, what do we need to do? Well, we need to create a function. So let's create a function that we can use to get the functionality for posting available to us. So I'm going to go down here and let's say that we're going to create a function here. And this function, in terms of naming convention, would be best, because we're going to create new data, to be called create. Now, it's something new and it's going to be a post. So we can call it create new post. Okay, good. Now, as always, it's good to run a mental checklist as to what we need. And the first thing we need, number one, is going to be the URL. Okay, so we need the URL of our source, right? Now, I'll just copy this over here and then just change this to post. So that's what we have right here. So that's what we need right here. What's the second thing we need? Now, the second thing we need here is we need to have a schema object structure. Now, in our case, what is the schema object structure? So when we looked at our code, we know we had a user ID. We also had an ID. We had a title, and we also had a body, okay? And we can just verify this by quickly going back over to JSON type code and taking a look. Or if you want to, as you're following along, you could just copy one of these objects so you can keep it in your code with comments so you can keep track of it. So we have user ID, we have an ID, we have title, and we have our body. Brilliant. Now, once we have this schema, what we need to do is create a way where we can dynamically add new data, because we don't want to hard code this function where it can only send one type of data. And of course, that presents other issue. Now, we need to make sure our code is dynamic, because if our code is not dynamic and it only accepts the same values every single time we run this function, we're going to create duplicates in the database, for example, which is not good. And that'll cause us issues down the line when it comes to our data science and data analysis. We want to make sure each new post is unique, all right? So what do we do? The third thing that we need to do is, of course, write some code. So let's write some code. All right, so let's get started. That third step is what we're doing right now. So in here, let's get our URL. So we can call this URL of posts. Okay, grab our URL from here, copy this, paste that over there, wrap this in our string brackets as I call them. That's the first step. The next step here is that, of course, we need to formulate how we're going to do our post request. Now, before we even do our post request, there's a few new things I want to teach you. You see, as I mentioned in our previous lesson, we have two different ways that we can send data to an API. Primarily, we can send data through the means of a request body, which is what we're doing in this case, but we can also send data through our parameters. So we can provide our key value pair structures as parameters and send that through with a GET request. And that allows us to essentially send some data that controls how specific we are with our request. Now with the post, there are a few more things that a GET doesn't have that we need to consider. One thing is that when we want to make a post request, we're going to be sending data. And because we're sending data, we need to be specific about what type of data we're going to send. So number 4 is that we actually need to provide what are called header configurations. Now, header configurations sounds very scary, but it's very simple. Now, a header is always present whether you make a request or you receive a response. And the header contains metadata, so information that is not pertinent for you to know really on a casual day or on a regular day. But if you need to make very specific configurations, you can configure your request header. And that way you can communicate with the API on how that request should be handled. So we have things in our header configurations. For example, we can describe what type of data the request has, which is what we're going to do in this lesson. Now, why would we want to do that? Well, it makes our requests more likely to be handled correctly and taken care of as they should. Now, what we want to do in this case is we need to provide a header configuration because we're going to be sending data we're going to be sending data in our request body over to an API, which needs to tell a server, which will then tell some sort of infrastructure what type of data this is, and of course, how to handle that data. Okay. The data inside of an object could be a list of values that are in the form of a string. There could be numbers. There could be objects within objects. There are so many different data types that could potentially be inside of that object. So we need to provide this information. So you follow along with me. You don't need to code right now. You can just watch me as I write code, and then you can leave notes and then copy along. And I'll make sure you have time to do so. All right. So if we want to make a request, we'll call this response, and we're going to say request dot. Now we want a post. Now with our post here, I just want you to see that in IntelliSense, it gives you all of the different keyword arguments that we can have. So we have URL, we have data, we have JSON, we have none, we have params, we have all sorts of different keyword arguments that we can provide into our post. Essentially, we can become more and more specific as to exactly how we want our request to be handled. So the first thing we need is our URL. So I'm going to pass that in here, URL post. The second thing that we want to provide, now by default, the second positional argument is data. But if you use keyword arguments here, you can control what is what in terms of what keyword you want to provide an argument for. Now you can see here that data is optional. So we don't need data over here in order for this to work. But it is advisable that, of course, if you're going to post data, you would like to post data with actual data in the request body. Now, in our code over here, we want to pass in data in the form of an object because our schema is in the form of an object. We have a list of objects. And that will be the best format for us to send data to JSON type code so that it can store our data for our post. So just before I complete this code up here, let's call this a new post. And we're going to create an object here. Now, an object, as you've heard me say across a few videos, is one of the many different collection types that we have within Python. Now, a collection type are a special type of variable that allow us to store data and represent data in different ways. So it gives us very useful tools for us when it comes to handling data and analyzing data. So in this new post section, what do we need to do? Well, first, we're going to provide parameters here. So we're going to say we have user ID, we'll have title, and we'll have body. Now, I'm purposefully missing out ID. And the reason why I'm missing out ID is an important point that I want you to pay attention to. You see, with databases, the ID keyword or the ID field in a database has something called auto incrementation. Now, whether you're using a relational database or a non-relational database, whichever database resource you're using, what's going to happen is that when you want to send data to a database, this ID field doesn't need to be added into your object most of the time. Because when you send the data, so user ID, title, and body, an ID will automatically be assigned to this data. Now, why would this be useful? Well, as you know, humans, we are good at maths, but we all can make mistakes. Now, computers don't make mistakes the way we make mistakes, not saying that they're perfect, but they won't make that kind of mistake. Because let's say we added an ID here, and if we go back to post for a minute and take a look, the last ID is ID 100. Let's say, for example, that we accidentally put ID as 100 again, then what would happen? Well, if we put ID as 100 again, then we're going to have a clash in our database. And as a result, we can raise different types of errors and our code won't work. Okay? So it's better to leave the database to decide on what the ID should be. There are mechanisms inside that will know that, okay, the next piece of data that comes in is going to be 101. Okay? So back in our code again, what do we do? Now we need to provide a key value pair structure. So we need to provide the key with the correct name, so user ID. And we're going to set this to the user ID that the user passes in, whoever's using our code. In this case, it will be us. Then we need title. We're going to set this to title. And then here we're going to have body, which we'll set to body. All right? So that's our new post. Now, with this new post that we have, what do we want to do? Well, we want to send this data into our post. So it's going to go into the request body and it's going to be sent to the API. The API is going to then carry this data along to the server, and the server is going to realize, oh, you have a post request? Okay, I'm going to send this to the database and save your data. Now, this form of data we have, this structure of having a string and then a variable or any type of data is the structure of JSON. So since this is the structure of JSON, we need to provide what is called a header. So we have a keyword here, which is a keyword argument called headers. And in here, we can provide an object that has properties that define different aspects of metadata to help this request be processed correctly. Now, in our case, let's go over here, and I'm just going to call this a header config. And with header config, what do we want to do? Well, we're going to pass an object, and then on our left-hand side, we're going to use our key value pair structure to define what this data type is going to be. Now, if you want to do that with an API request, the name of that key that we need to use that all APIs recognize is called content dash type. Okay. And you have to make sure you spell it like this so that it's clear to the API what you're talking about. So when we make a request, a post request, when the API reads our request and it sees this in the header, it's going to pay attention to the value that we're going to provide. And when it sees that value, it's going to know, oh, okay, so the data in the request body is of this type. Now, on the right-hand side, what do we do over here? Now, on the right-hand side, we need to provide something that is called the meme type. Now, it's beyond the scope of this video, but to break it down in very simple terms, the meme type is the description of what type of data we have in our request body, what is acceptable also to be data that we pass inside of the request body. So in our case here, if we're dealing with JSON data, we use this expression here. We say application, and then we say /JSON, okay? Now there are a long list of meme types, and on the CS Academy website, so that'll be codeswitchacademy.io, the PDF that contains all of the different header information along with meme types will be made available to you. Now with meme types, let's say we wanted to accept images and videos, for example. We could say that we have images, and I'll leave it as images with a / at the end. This means that we accept any type of data that is an image, but we can be more specific. We can say we want images and we want JPEGs only. So that means the only type of data that can be received here or dealt with would be JPEGs. We could also say videos or video. And with videos, we can say that we only want MP4s. These are what we call meme type configurations. All right. So enough with the theory. Let's get back to writing some code. So in our header here, we're going to type in header config. What else do we need? Now, because we're dealing with JSON data, we have another keyword argument called JSON. And what we want to do here is we want to pass in our data, which we have as new post, inside of this JSON keyword argument. Now you notice here that it says that it's also optional, but it says a JSON serializable Python object to send in the body of the request, right? Now the body of the request or the request body is what we're dealing with, right? We want to send something that is serializable data, which is this, and we're going to put that right here. So new posts. Good. So we have our URL, we have our header configuration, and then we have our data, okay? Now I'm slowing this down on purpose because I really want to make sure that you guys take in the information and I'm not just rushing through and spouting out knowledge to you, okay? So whilst you're writing code, I also want you to take notes so that you can become the best Python developer that you can be. All right, so once we've done this, what do we need to do? Well, with this response, how do we know if we have actually successfully sent the data to the server and the database has actually saved our data in the database? Now, we are not going to know this directly because we're not going to receive an object back on the screen. It's not going to tell us we have this new object on the screen. And even if it sent our data back to us, it wouldn't mean much, right? If on our terminal, it printed out the same object we just sent in. So we need another means of communication, which, as I told you, is always available consistently, no matter whether you receive data or you receive an error. And that is going to be the status code. So the response status code. So the status code we get as a response, as we looked at in our previous lesson, if we have a 200 response, for example, that means okay. So anything inside of the to class, by the way, now anything that's inside of the to class, which we'll describe as 2xx, means that it's successful. And anything that's inside of the for class, so 4xx, means that we have a client-side issue. So that means there's something wrong with our code or internet connection. There's something wrong on our side of the story of the request response communication, right? And we have others. So we can have the 5 class, so 5 class, which means we have a server-side issue. So that means there's an issue with the server. Maybe the server's down, maybe that resource has been removed. Many issues can arise. So these status codes are really useful for us to even programmatically proceed to carrying out further actions that we want to carry out in our code. Now, because I've taught you this already, I want to give you a challenge. I want you to pause the video where it is and give it a try. I want you to write some logic using what I taught you with conditionals. And what we want to do here is have something that gives us a feedback response, as I called it, on the terminal. So I want you to use conditionals to check whether this response was okay. This response actually happened and it was successful. If it's successful, we want to get a message on the screen saying that it's successful. If not, we want to get a message saying that it wasn't successful. Okay, so I want you to give it a shot, guys. Write the code, give yourself 10 to 15 minutes, and then when you come back, I'll show you my solution. All right, guys, welcome back. So I really hope you gave it your best shot and you didn't just wait for me to start talking again, but you actually gave it a try. So what do we do? Well, we need an if statement. So we need to say if the response, now remember the dot notation, what do we want? Well, we want status code. Now, what status code do we want? Well, if something's successful, as I've taught you, we want to say that if the status code equals to 200, which means we have a response as okay, everything went well, we can simply print out a message saying that the post request to add a new post was successful. Okay, so now we have a way to keep a track of our code. Now, in this situation, we don't need an else if. Now, I'm sure some of you maybe have written else if response code status code equals to, let's say, 404 or 400. Okay. Now, as great as this looks and sounds, we don't need to do all of this hard work. One of the important things I want you to remember as a software engineer in the making is that we work as hard as we can to make life as easy as possible for all of our users around us. And so, even for ourselves as developers, if there's no need to write extra code, we don't want to write extra code. So we can refactor this down and simply just say else. Because if it's not a 200 response, we don't want to hear about it right now, unless there are other 200 responses we may want to look at. But for now, if we say else, which means if it's not 200, we want to say, sorry, this transaction or this request was not able to be handled as requested. Okay. Now, the only dilemma here is that when we actually send data to a target location, which would be our database, and we do this so that we can get our data added to that system, the response we actually are looking for is not exactly a 200 request, because us saying that the request is okay programmatically, or the response coming back saying that, so the response saying that we have a 200 response, as much as it sounds good and it is good that our request was successful, the only problem is that we need a bit more specific information. Whenever we're in the to class, so whenever we're inside of the to class of responses, we know that it's successful already. So we don't actually need to be told again. What we need to know is if this data was actually saved to the target destination, which in this case, to the target destination, which in this case was to be a database. And in this case, is our database. Now, what we actually want to say here is not 200, even though from a programmatic standpoint, from the challenge standpoint, you did a great job. What we actually want to say is if this is 201. Now, what does 201 mean? Now, 201 means it's successful, but successful in what context? It means successfully created a object of data. Okay. Now I'm calling it object of data, but you can just call it successfully created data. But essentially what we have going on here is whenever a 201 response happens, and this can be, say, for example, you're signing up to a website to become a new user. When you get logged in, if you ever check the network tab to see what response you got back, you would get a 201 response, not a 200. So 200 foundationally means everything is okay. But as you go from 200 to 201, you have some more specifics as to exactly what was successful. So we say if this is 201, then we want to print out this message. If not, then of course we're going to go over and print out an error message. All right. So that was everything we need for now. If we need to make any changes to our code, we can always come back and make our changes to make this code even more beefed up if needs be. All right. So what do we do now? For now, we're going to comment out this line here because we're not using this function, but we want to call our new function, which is create new post. So we're going to say create new post. We can pass in our data here. So let's say we want to pass in a user ID. I'll just keep this as 1. Let's say the title of our post is how to use APIs. And the body of our text will be APIs are the best resource in programming ever. Put a smiley face. All right. So this is our code. So if this is successful, we're not going to just have a 200, which means it's okay. We're going to get a 201, and then we're going to print this message on the terminal. So let's take a look. So we have our code from PowerShell here. I'm going to clear it out. You can also clear yours on your Mac. So if you're in Bash, on our output here, we're done with this, so we can clear this out. And for now, let's execute our code from here. Let's take a look at what we've got, make sure that everything we've done is correct. So there you go. Didn't take that long. It took about 1.3 seconds, but you see it says the post request to add a new post was successful. Brilliant. Now, if you had access to the database, you can actually go and check up the database, refresh it, and check to see if our data is actually there. Now, I see a little typo, so I'm going to change it because I hate typos. But again, you see that we've successfully added data to our target location, which is the database. And this is how we can create post requests. Okay, so in the next lesson, let's take a look at how we can handle our put requests. I'll see you guys there. Take care. All right, welcome back, guys. So in this lesson, let's take a look at how we can handle put requests. So as we looked at from our theory lesson, you understand that a put request is a type of request that we use to update data that already exists in some sort of target destination, like a database. So in a database, let's say we wanted to update our details. We want to change our username, we want to change our password, we wanted to change our name. Maybe our surname has changed, or we have a new middle name, or you got married and your surname has changed. These are all things that are very human situations that happen every day. So in that kind of situation, the type of request we want to make is a put request. Now let's go back to JSON typing code for a minute so we can take a look at what we've got going on. So if we go back one step and we go to our main page, wait for that to load. What we want to do is take a look at our resources again and our routes. Okay. Now, if you're from the UK like me, I actually say routes, but routes is the pronunciation that is American and what we use most of the time. So you hear me say routes. If you call it routes, it's the same thing. All right. So it says that all HTTP methods are supported. So you can use HTTP or you can use HTTPS. So HTTPS is the secure protocol. So it's our hypertext transfer protocol that has security attached to it. And then we have our general HTTP. Now, when we're making our API request, we need to follow our documentation here. It tells us what we can make our API calls to. So we can do a get with posts. We can do a post request to posts. We could do a put request, and we could do a patch and a delete. Now, when we do a put request, our idea is that we want to change the data that is stored in a target destination in a location like a database. And what we want to do is we actually want to overwrite what already exists with the new data that we're going to pass in. Now, a patch request is very similar to a put request because both of them have the job of changing data that already exists to something new. However, with a patch request, is more often used when we're trying to change a very small section of a data object. So maybe just one property, like you want to update your name. we would use a patch request to do that, not a put request. Okay. We don't want to overwrite the data. We only want to overwrite maybe or change just one field. So this is where we'll use a patch. But in our case, we want to use a put because we want to have a full overwrite of the data that we've just written. So we want to have a full overwrite of the data that is stored in the database. So let's take a look at using our post endpoint. So that means /post, so that we can do a put request. Now with the put request, take a look at the structure here. The / here means that we're dealing with our base URL, which is jasonplaceholder.typecode.com. And then the resource we're looking at is posts. And then after this, we're looking at the ID number for the post, which is /1. Now, in this case, with a put request, we don't want to update the entire data set. If I go to posts, you'll see that there's 100 posts here. So if you click on this right now and we load this up, take a look. There are 100 posts. So these 100 posts that we have, we of course don't want to update every single post because that wouldn't be a useful API call because we don't want to change all the data. We want to change data specific to one post, not all posts at the same time. Now in social media apps, if you make a typo on a post, on a tweet, or you put the wrong picture up and you want to change the picture, we want to change just that picture, but not every single picture at one time. Okay. If this is something that's stored in a database, same thing. We want to make sure that we change the entirety of the data, but just that specific field and not everything else. Because the request body will hold an object that is going to be sent through. We're not going to pass in 100 objects or an array of objects. That's not how it works. So for our put request here, if we look at the schema structure of our data, remember I told you that the shape of an object, the shape of data is called the schema. We have these 4 properties: user ID, title, and body. So if we want to uniquely identify a specific post, we need to identify that post by its ID, because the more specific we are in this case, the better it's going to be for changing the data. Now, one more thing to pay attention to before we move on to the next step is that when we are doing a put request and updating something like a post, we don't want to allow our users to be able to change every aspect of our post or every data point that exists or every property value that exists inside of our object. So for example, in our post object here, we wouldn't want the user to be able to change their ID or their user ID. We want these things to be read-only. The reason why we want it to be read-only is because let's say a user creates a very derogatory post purposefully, knowing that they can change the ID of the post and then reassign it to someone else, so someone else catches the blame and, becomes a big thing. We don't want that. So from a contextual point of view, let's say in our social media app, we want to make sure that the post that was created is only changed by the creator of the post. That way, it helps the security of the project and also make sure that our database is storing data in an orderly fashion and in the correct way that we would want it to store it. The only property values and property fields that we want to be changing would be the title and the body. We want user ID and ID to essentially be what we would call immutable, meaning that there are no changes we can make to those pieces of our object or to our data object. Okay? So let's test this out. Now, let's say we wanted to change post 1. By doing this /post/1, it gives us access directly to just that post. So we need to create a function that allows us to control what post we want to change and, of course, what data we want to add. So let's put those two things together. I'm going to copy this URL here, and let's go back to VS Code and take a look. All right, so back in VS Code, we're going to create another function again. Now, whenever we're making a post, we know that we're sending data, so we're creating something new. Whenever we're posting data, we know that the data is going to be fresh. It's going to be in that database for the first time. But if we're doing a put request, the data
is going to be something that we're renewing or we're overwriting, or the best term that you'll find when it comes to working with, or the term that you would hear the most in programming circles is we're updating data. Okay, so we're, let's write this here, updating existing data. So let's put this here. So when we're updating existing data, the best thing to do would be to name a function after what is actually going on. So let's call this update posts. Now in here, what do we need? Now this time I'm not going to write the checklist because I think you've become used to what we're doing here. Now we want to first of all have a URL for where the posts are located. Now we can copy our code from here because we already have the same URL. We will make some adjustments later on because we want to make sure that we're making an update to the correct post. And we also want to make sure that we provide the correct data. Now we already have our schema structure here for what a new post is. And so if we were going to update our data to add a new post, we'll need to have the same schema structure, the same object structure. So we can copy our new post here. So let's make sure we have the right number of white spaces. So here, we have the right number of white spaces now. So remember, it's 4 from the margin of the left till we get to 4 spaces. Good. So we've got our post, we have our structure here. We also have our parameters here. So with our parameters over here, in this case, we don't exactly want to change everything. It's best to leave ID and user ID as immutable values and not touch them. So we'll delete this field over here, and we'll also delete this field over here. All we want to do in this function is allow the user to be able to update their post, which would be the title and the body. Good. Now, for distinction between what we have with our create new post and our post over here, it would be good if we call this title new or new title. So let's call this title new and body underscore new. Okay, so we'll say title new and body underscore new. Now you can also reverse this the other way. You can also reverse this the other way around and call this new title and new body. Title new, new title, same difference. Okay, now over here, we're going to change the variable name a little bit. Let's call this update. I'm just going to call it update. And then we can start working on the functionality. So of course, we're going to be making a request and we're going to receive a response. We'll save that response in a response variable, and we're going to call request. And this time we want to do a dot put. Now with the dot put, we have many of the same keyword arguments that you'll find in a post request. What we want to do here is, first of all, provide the URL. So we'll say URL of post. Now with this URL of post here, remember I said to you before that we also need to provide header configurations, and we also need to provide our response. Now with header config here, I use the camel case notation, but I'll change it to snake case for this video so that you can follow along in your consistency of writing. We're going to grab this so that we can define the meme type, the MIME type, which is our multimedia type. So we need the data that we're going to pass again to be in the form of a JSON object. And we need to let the API know that this is the shape of data we're dealing with. This is the type of data we're dealing with, okay? Now with a post request, we're posting data to create that data that doesn't exist, for example, in a database for the first time. In our case, with a put request, we're going to send a new piece of data to the request body. So it's like we're doing a post, but the way that this data is handled will be different as a final result. In the case of our updating here, we're going to change existing data, but we still need to send that data.
With a post request, we need to send that data, but that data will be added to a database for the first time. So put and post are very similar, and I find that students do find it a bit difficult to understand the difference when you first start. But by the time you finish watching this lesson, you'll be a pro at understanding the difference. So we have our header config, we have our response here, okay? And then we can start getting cracking with the code. So in here, we'll say that we want to have our headers, which is going to be our header config. And also we want to provide JSON so that we can say that we want update to be our JSON object. Now, you know the drill here. We want to write our code in such a way so that we can get a response. Now, the thing here that is different from a post is that when we're sending data that doesn't exist in a database so that we're creating a new entry, we need 201. But for a put request, all we need is a 200 because once it's successful and it's updated, we don't really, again, need to receive that object back to view it for any reason. We just need to know that it went through okay. Now, because it's a put request and we're just updating data, again, the response doesn't need to be a 201 because we're not creating anything new. We just need to focus on the fact that we've actually had this successfully. Okay. Now, when you write your code in this fashion, you can write a 200 request. So you can say if response, okay, dot status code is equal to 200, then we'll say we're going to print out this put request to change existing data was successful. Okay, that's brilliant stuff. And we'll say that else print out, sorry, this request was not able to be handled as requested. Great. Now, the thing is, as I told you that the 200 level of our status codes we get as a response means that the response, that the action was successful. Now, 200 just means we generally had something successful. The process that you requested has happened. 201, again, is successful from the context that the request has been fulfilled, and it means that we've created a new data point in our database, or what we'll say we've created a new resource. That's another terminology we have. So our payload, which is the data what we've sent, has gone along and allowed us to have a 201 because a new resource has been created in our target destination, our database. All right, so in our case, with a put request, because we just want an action to happen, we can just say that we have a 200 status code response, and then we can execute our code from there, okay? The 201 is something unique for a post request, but for a pull request, we don't really have any special code that can specifically define that context of updating data. Of course, we can have other mechanisms involved that can be triggered if this response status code is 200, like we can have some nice front end code that gives us nice imagery to say, hey, this was successful, and maybe here's a transaction ID that your transaction was successful. Okay, things like that. Now, back onto the point of actually doing this put request, we need to call our put request down here. So I'm going to comment this code out now. And then let's do a put request. So we'll call update posts. Now, there is a little bit of an issue here. Can you tell what it is? Right. Now, as I told you earlier on, and if you picked up on this, then it means you're paying attention, and I'm really happy. When you make a put request, if we were to execute this right now, we're going to run into the issue. What would the issue be? Well, as I said earlier on in our lesson, we want to be specific about where we're posting our data to. We can't update our post if we don't know what post we're updating. The database can't do that. The API would be a little bit confused as to what you're doing, but it's going to still send a request. So our actual target destination, which will be the database, would be confused as to what you mean by sending a put request to this endpoint post. So what do we need? We need our user ID. So over here, after body new, we need another parameter. Okay, now we can call this our user ID or user underscore ID to keep in the same shape as to what we have with other values. So up here, I use camel case, but because I didn't use any other casing, this is acceptable to use, okay? But in the case where we have snake case for our parameters, we need to keep it the same. So you need to use user underscore ID to have uniformity in your code. So with user ID, where do we pass this in? So F string right over here. After the F string, we're going to pass in user ID. Now we're following our documentation properly, because if we pass in the user ID of 1, for example, that means we're going to update the post where the user ID is 1. Great. Now, equally, as I've taught you in our previous lesson, in our get request, we could create a variable called parameters and provide a key value pair structure and say, okay, we want the ID to be a certain value. So instead of writing our code like this, we can get rid of this and keep the endpoint as it is, which can be useful in some cases, because let's say we're working with just post for the entirety of this apis.py script. In that case, we can have this as a global URL that we store at the top of our file, and we can carry out different transactions. We can write different codes to execute different types of requests based on what function we're dealing with. Okay. Now, I'm not going to go and do that, but I just want you to open your mind as to the possibilities of what we have going on in our code. So what else could we do? So we can say, we'll call this parameters. We'll call this parameters. And then in here, what would the parameters be? Well, in this case, let's say we want it by ID and we want to update post ID number 1. So the first post, we want to change it with our new data. So in here, in our user post, what do we say? So the title would be APIs are great. And then we can go over and say something like APIs are even better than I previously mentioned. Okay. Then we go and put over our smiley face this time. Okay. Now the final argument that we need to provide the data for here would be in the argument of the user ID. So let's just drop 1 over here. Okay, cool. So now that we've written our code, it's the same thing again. We're going to go to our terminal. Okay, you can either use the terminal and write Python 3 or Python if you're on the Mac is Python 3, Python if you're in Windows, or we can go to our output window and run our code. So let's check that this is working first, and then after we can take it from there. Now with our parameters, when we're executing our code, you know that we need to pass in our parameters somewhere. Now, if we're passing in parameters, where would the parameters go in this case? Do you remember? So in our response over here for our get, we passed in this keyword params. So it's the same thing down here. We're going to go down here, and as a fourth argument, we're going to say params equals to parameters. Brilliant stuff. So here we go. Let's run our code. So you see, it says that, sorry, this request was unable to be handled as requested. Now the question will be, why is that so? Now, if I change this to user ID and we run the same thing, so now we're dealing with the ID of the user. Take a look. You see, it still says that we can't carry out this update. Now, I want to show you something here before we continue. If we forget to put parameters in, number 1, our code won't work. Now, if you go and hover over this, right now, we passed in user ID over here, but we haven't said what we're doing. We've only said that we have 1, but we have 1 here, but we don't have our value here. So if I say user ID now and put 1 here, we should be seeing something on the screen. Now, if we still don't, so I'm going to execute it, and we still don't, it says, sorry, this request could not be handled, then we need to go and figure out what our problem is. Now, there's a few ways you can debug, and part of this lesson, I decided that I'm going to show you how to debug straight away so that you become the best programmer you can be. Now, if we want to check what's going on, we can type in response dot status code. So we want to check what status code we get to see what our issue is. And this is why status codes are so powerful, because they can help us with very quick debugging. So follow along with me. Let's look. So look at what it says. Right now, it says that our current way of writing our code is a 404 error. Now, what did I tell you 404 means? Let's put this here on the terminal so you can see how debugging works. So 404 means we have a bad request. In this case, what is the bad request? Well, the bad request is that when it comes to working with this endpoint over here, it's saying that somewhere in our endpoint that we've created, we've written something either incorrectly or we've passed in the wrong parameters. So how do we debug? Let me show you. So if I was to say for now, I'm going to get rid of user ID and we're going to pass in this value here, put /post/1, close the string. Our first test that we want to pass in here, let's take away params for a moment, is to just pass in this new title and our new body in here and see what happens now when we get our code executed. So we'll run again our code. And let me take away this because I forgot to get rid of the argument. Okay, so let's clear that and run it again. Look, you see now it says this put request to change existing data. Now I can see that there's some typos here. So existing data was successful. Brilliant. So now it's working. So when we pass in 1 here at our endpoint, it's working okay. But if we pass in our parameter over here, so parameters here, we're passing the key value pair, user ID. Okay, it runs into an issue now. So over here, we know that we want an ID of 1. So if I pass in 1 again, because we know it's working here, and we'll leave this as user ID here first to check it. We'll pass that. See 404. The second field is called ID, so we'll test that out. We'll put ID here, test that out. Still get 404. Now, what about if we change the type? So if I change ID from this to a string, and we'll try both of them. Let's go over here. So user ID, go over here, still 404. So whether we use, and let me just drop ID quickly over here too, so you can see this. And do one more first before I continue. So you see that no matter what you do right here, we get 404. Well, if you go back over to JSON typing code, and then we're going to go back over here. So on our page, the schema says that we have user ID first, ID second, title, and body. Whether you pass a string or a number in here doesn't change the fact that whichever way we put in data, we're not getting a good response, right? When you go to your docs here, take a look. Now, if you go to guides, which is important here, now this code is written in JavaScript, but the same rules apply for ourselves when we're writing code in Python. So if you update a resource over here, if we pass in an ID and a user ID in this object here, so ID and user ID over here, and we try to update our data, it's saying here that this is the correct way for us to write our code. If you notice in our fetch over here, it says that it passes in 1 straight away. So 1 is already added here. So if I decide, let's pick 1 at random, by the way. So we'll go to JSON typing code. We'll go back to our posts and we'll go for 1. Let's say I copy this entire object here as it is. Let's copy that. Let's go back to VS Code. So now I've got this entire object here. I'm just going to drop it right here. Okay. And let's just say now that I decide, again, with parameters, I'm going to go in here and pass in user ID. So user ID and F string over here. So now I'm going to just change this to a shortened form, and we'll just get rid of this over here too, so that it's different. So now take a look at the shape of our structure, the shape of our schema. It's 4 values: ID, user ID, ID, and the rest, okay? All right, we're going to bring back params over here. So params equals to parameters. All right. And then make sure we get the right spelling of user ID over here. And now we have our code going along here. So with all these executions that we've done, the shape of the data we used before had 2 values instead of 4. Okay. Now with parameters as ID set to this user ID, let's say we want to go and change 100. We want to update 100 in our code. So we're going to update 100. So again, if we run this code and it doesn't work, we will know what type of error we've got. So take a look. You see now, all of a sudden, surprise, surprise, our code is working. So I hope you guys really enjoyed this lesson. So in our next lesson, let's take a look at the last type of request we're going to deal with, which is handling our delete request. I'll see you then. All right, guys, so let's take a look at our last API request type, which is a delete request. Now, delete request is pretty straightforward relative to the other types of requests. And as the name entails, all we're trying to do is trying to delete something from a target location. Now, usually we use the delete keyword for things like removing data from a database. This can mean removing a user. It could mean removing an entry for something that we placed, like an order on Deliveroo or Uber, and etc. These are what the delete request covers. So programmatically speaking, what we want to do is delete our post. Now, the same way we need to update a post, and we need to be specific about the post that we're trying to update, as we looked at in our previous lesson, the same thing is true when we're trying to delete a post. Whenever you want to use the delete or the put API call, it's always pertinent that apart from the endpoint, which is the location of the data in terms of the array of objects, which will be our array of posts or our list of posts, we need to be more specific to identify what exact piece of data we're trying to work with. If you just use a delete call, we're not really going to make it specific enough for a infrastructure connected to a server, like a database, to understand what exactly you mean by deleting something or to make a request to delete. Now, programmatically speaking, what we want to do is say def. Because we're deleting something, I think the best name to use would be, let's put this here, delete post. And then we can start to write our code. Now, in JSON type code, we've seen that when we need to do a put request, we need to pass in our user's ID. The same thing will be true if we need to do a delete request. So we can actually just copy over these 2 lines of code and plonk them over here. Now, the difference between our put request and our delete request is that we're not trying to add any new data, because even from a grammatical point of view, we can't add new data by deleting something. We're trying to get rid of data completely. Now, the only parameter we would need would be the user ID so that we can specify what post is being deleted. Now, to identify each post, we know that we want to identify them based on the user that posted them, or based on the ID, which is even better, of the post itself. So let's say ID number 20 or ID number 79, right? So in here, if we pass in user ID, this could work, but it would be nicer if we just call this ID. And then here we'll call this ID as well. Now in our last lesson, I used user ID for teaching purposes, but we can go for ID. So now we have our URL for our post, we have our parameters. What else do we need? Well, in this case, we don't need any configuration in the header because in the body of our request, there isn't actually any data at all. We're simply making a request to remove something. So it's almost like we're sending a command. We don't actually need to send any data. We just need to make sure we pass our parameters. So the logic can actually remain the same. And to save on time here, I'm going to copy this code right here. I'm going to paste it in. Make sure we have the right number of white spaces. And then we'll just start from our dot notation. So we want to call delete right now. Now with delete, it does have different key value pairs that we can pass in. For us, we don't need any headers and we don't need to provide any data. We just want to pass in the URL and pass in our parameters. So if we do this, what do we say? Well, pretty easy, right? We say URL of posts. Then for the keyword arguments, we want to say params and then say parameters. Good. Now, once we've got our code laid out like this, our job is pretty much done. If we get the response that we're looking for, then we get a delete request. So we change this to delete. Okay. Was successful. We can shorten this here. So I'll say, yeah, this delete request was successful. And if not, we get the status code. And that's really it. So we could make a post for post 50, which is what we have here. So we can go down here now and I'll comment this out. And then we want to call delete posts. And in here, we'll pass in an ID. So let's just say ID of 100. Okay. Now, just to make a note here, the data doesn't actually get deleted from the database, but it's faked using some programmatic methods to look as though it was deleted from the database. Okay. So if we really were updating and deleting the data on the database, then every time we go to JSON typing code, literally every minute, we'll have different data sets showing up on the website, which of course would be really bad, especially if we're trying to run some testing. So all we want to see is that we have a request 200 and we get this message on the screen. So open up the terminal, go to the output, let's run our code and see what we have. And you see, this delete request was successful. Perfect. So now you understand how we can work with these 4 foundational API requests that all developers need to know. And as you can see from the way they work programmatically, most of the time you're going to be interacting with these 4 main API request types, okay? So make sure you practice as much as possible, and then we can move on to the next section of our course. I hope you guys enjoyed this lesson, and everybody take care and have a great day. All right, guys, and welcome to the final section of our Python developers course, version 1.0. Now, I want you to give yourself a pat on the back because if you've made it this far, you've done a fantastic job. We've been through so many different Python concepts, and for you to handle all of it and be here, I'm proud of you. Now, this section is the most important section in our course. The reason being, well, the reason being is because all of the things you've learned so far from section 1 to 6 are going to be put into one entire project, which is going to be a game. Yes, you heard me, a game. We're actually going to build a game from scratch. And this game that we're going to build is going to be Tic-Tac-Toe, also known in the UK as Noughts and Crosses. Now, let me demonstrate the game to you. So I'm going to run our code over here. Now, I'm going to just choose one round of this game.
You can choose the number of rounds you want in this competition. So I'll press OK. So player name is going to be Michael for player 1. And player 2's name is going to be, let's put my surname, Roberts. So what we're going to build here is a game that we can actually play noughts and crosses with each other. And now I hope you guys enjoyed seeing that. This is what you're going to build with your own 2 hands. So by the end of this section, you're going to be fully ready to go out there and start building cool applications. So in the next lesson, I'm going to teach you exactly what to do to get started so that we can crack on with building this amazing application. I'll see you guys there. All right, guys, welcome back. So let's see how we can get started building our tic-tac-toe game. Now, as you can see from our VS Code window, the window is completely empty. All we have is the welcome page. And I also have my folder here called Tic-Tac-Toe game. So right now, as you're building this project with me, I encourage you to create your own folder. I've called mine Tic-Tac-Toe game because I think it's the most fitting name. And then we can continue. Now, in order for us to get started, we need to make sure we have the right modules, because without those modules, there is no game. Now, before we continue here, I want you to know that all of the code that I'm going to write in this project and all of the code from all the other sections will be available in our GitHub repository. The GitHub repository name is the CS Academy IO, and this specific code is called the Python Devs Course 1.0. So all of the code for every section of our course together is available there. All right. Now, continuing on, in order for us to get our modules, we need a file. So the first thing to do would be to start off with creating our file. So up here, I'm just going to call this game.py. Okay, so follow along with me. You can give it the same name or a name that you feel comfortable with, and then we can crack on with our application. So this game application, of course, needs a few different properties. Now up here in our section where we're going to put our imports, we're going to need specifically 3 imports to get this to work. Now the first one we're going to need is something called Tic-Tac-Toe. Now what is Tic-Tac-Toe? Tic-Tac-Toe is a very powerful GUI tool for us to be able to visualize our code. Now, the game logic that we're going to write needs some visualization. Otherwise, it's just going to be a game that has nowhere or no means for us to play, which is not going to be fun, right? So Tic-Tac-Toe is a very powerful Python package that we can install that allows us to visualize our code by giving us a graphical user interface toolset for that specific purpose. What else? Well, the next thing is we need something called Pygame. If you remember from the introduction video, when a player won, which is of course me, because I'm a winner. But anyway, when that game was complete, there was a soundtrack that was playing. Now, in order for us to get a soundtrack, we need this module called Pygame. So right here, I'm going to write, we have a play our winning sound track when the player wins. Okay. Now, the reason why I'm making sure there are code comments is because you may want to take this code and fork the repository and continue building on this game. And if you want to impress employers, this will be a perfect way to show your skills. So it's important that the knowledge behind what you're writing, the understanding behind what you're writing is also there. Now, the final thing is we need another package called random. Now, aside from the soundtrack playing, when the game was actually finished, now there was some confetti. And that confetti was falling from the top of the screen down to the bottom. Okay. Now that confetti falling down on the screen is going to need some randomization because, of course, the way that it looks is representing what we do when we throw confetti on someone for celebrations. So the random package is going to allow us to do that. So here I'm going to write down for generating our random confetti when a player wins. Okay, good. Now, in order for us to get these, we're going to need to open up our terminal, right? Now, as a prerequisite, I've already installed Tkinter and also Pygame. Now, with random, by the way, random is actually a built-in module. So if you try to install it, you might get an error saying that this random package does not exist because it's built into Python. So on the terminal, what do we need to do? We need to say pip install, and let's go for the first one. Now, Tkinter, maybe you've gone ahead and tried to write Tkinter, won't work. What you do need to install is something called TK, okay, which is Tkinter. So when you install TK, you will get access to Tkinter as a result of that. So it's going to be pip install TK, not Tkinter. So let's install that. Okay, now as you can see, I already have it installed. So you can see it says that this requirement is already satisfied. Okay, the same would be true for Pygame because I already have it installed. So we're going to install Pygame. There you go. Now, for those of you who are watching this, you most likely don't have Tkinter or Pygame installed. So once the installations are complete, then you can continue with this video. So if you need to pause the video to wait for the installs to happen, please do so now. And then you can come back. So now the final one, as I said, if you try to do a pip install of random, you see that it said that there's no version that can satisfy this name random. And the reason being is because this name is already taken because it's a built-in Python package. So at the top here, if I said import and I type in RAN, you see that random shows up straight away. Okay, because it's already something built into Python. And what about the rest of our packages? Well, we also need to import. Now, this is the part that might be a little bit confusing because even though we've installed TK, if you start typing in TK here, you notice that we have a drop-down list of TK, Tkinter, underscore Tkinter, and underscore Tkinter underscore D. Now, the one we want is just this one here, Tkinter. And if it helps with the confusion, you can use a type alias and say as TK. So anytime we want to use Tkinter, we can type in TK right here. And you see that it shows up. Now, the best way to always check if you've installed something correctly is to use the dot notation with the module. That will show you if you actually have any of the tooling available for you to use. And you can see we have a long list of things that are here that we can use. Now, don't worry too much about it. It might seem intimidating, but Tkinter is not as difficult as it comes across to be. Now, the final thing, of course, will be Pygame. So we're going to import Pygame. And if you really want to, you can do the same thing and call this as PG to represent Pygame, just to shorten having to write Pygame. Now, we don't need Django, so ignore that snippet, and then we can continue. So these are our installations here. Now, how do we know if our Tkinter is working? Again, this is our GUI tool. So before you go and we move on to the next part of our lesson to start building the logic of this game, we need to figure out whether this is actually working. Now, how do we know if it's working? Well, the first thing to do is create what is called a window. Okay, so create a window. Now, what is the window? Now, when you use applications, so Visual Studio Code, Microsoft Word, we have our software, when it loads, opens up a window where we can see all of the different aspects of our software. Now, that entire space, that four-sided space that has minimize, maximize, and then the exit button is what we'll call our window. Now, Tkinter allows us to create our own window so that we can build our own code application logic and then view it on the screen. So how do we test this? Well, there's a few things we need to do. So first, let's create a game window. So I'm going to call this game window. Now, what we want to do is get TK, and we're going to call TK capital letters, which is a class. Now, this allows us to actually get the screen name. Now, don't worry too much about the different arguments here. You're going to understand these as we go along with our project. But for now, all we want to do is just call TK over here, okay? Now, as you notice with every software that you've used in Windows, we always have a title that shows up on the screen. So for example, the title may say Visual Studio Code, or it might say Microsoft Word at the top. Now we can also create our own titles over here with our own code. So in here, I'm going to save a variable. Let's just call this our game window label. Now, when we want to create a label here, TK by itself has quite a few different properties. One of them is called label, and that allows us to label our window. Now, it has a few keyword arguments, and as you can see, there are a lot of things going on in our window here. So I'll do it one more time so you can see. You see, we have quite a few arguments here. I don't want you to be worried about the number of arguments that are here. All of these are different functionalities that we can add to change the way our code looks, okay? Now, when you want to work with a label, we need a few things. So for example, we need to have our foreground and our background, which is very common. So our foreground would be FG. You can see that foreground FG is over here. So we'll choose FG for short. Now we can say our foreground color, which is going to be the color of our text itself, could be black. Very simple. And then we could also say that we want to have a background. Now, if FG is for foreground, then background would be BG, right? So we say here is our background. Now, what else can we add? Now, we actually need to have a title, right? So the argument beforehand that will go here. So now we have our background. We have our, now before we put our background here, I've written background. What we need to say is we need to write white. We want a white background and a black foreground, not a background. You know what I mean? Okay. And then what we want to do here is we want to write in our text. So when we want to write our text, over here, you'll see that we have the text keyword. And in here, this is the place that we will write our label. So we can say this is our tic-tac-toe game window. Okay. Now, it's important to note that when we create these labels here, we're adding these labels to our game window. It's not going to immediately show up. So the next step that we need to do is we need to push our changes to our window. Now, how do we do that? Well, what we need to say is that in our game label here, you see that there are different functions that we have. Now, all of these different functions that we have here provide all sorts of different functionality. Now, in our functionality for us, if we're going to add a game or we want to add code to a game, we need to make sure that we update what is called the state. Now, I'm going to come back to what state is later on, but I want you to see that we can update the state. Now, this long list all the way down gives us a few options. One of them is something called main loop, which is the thing that we're going to need at the end. Without main loop, we're not going to be able to see anything on the screen, okay? We need to make sure that main loop exists, all right? So whenever we want to add properties or add anything to a game window, all right, what we want to do is we want to push that data in. So what we're going to do is we're going to say we're going to pack our data. So when we pack our data, that is going to allow us to pack our data into this window. And then the final thing would be we call the game window and we want to say we want a main loop. Now, the reason why we need a main loop here is because we want our GUI, which is our window, to stay consistently open. So with these 4 lines of code, we can actually get our GUI to display on the screen, which is what I want to show you. So if we click over here, you see we have tic-tac-toe game window. And if you open this up a little bit, let's see if we can get our window open. You see here, we have our text right here and we have TK showing up. Now, if you're on a Windows computer, you're going to get TK looking like this. It may look slightly different on a Mac and on a Linux computer. I believe on those two, there isn't any feather, but on Windows, there is a feather. But essentially here, we've just created our first window from our GUI tool with our code. All right. So in the next lesson, let's get cracking on what we need to do in order for us to actually build our tic-tac-toe game.
So I'll see you there. All right, my people, welcome back. So, do you remember this question I asked you in the previous lesson, which was, what are the numerical winning combinations? Now, before we continue, I just want you to have peace of mind that you're definitely going to have a different answer from another watcher of this video, okay? So don't feel any way if your answer is not exactly the same as somebody else's answer. And even if you got it completely wrong, remember, the whole point of why you're here is for you to learn. So don't worry at all. So let's go through how we can actually calculate what the numerical winning combinations are. So we have our board. You understand that from a numerical point of view, our board has 9 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. But from a programmatic view, which is our collection type of list that we're going to use, it will be 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So with our winning combinations, we know that we need 3 sets. So we have our horizontal wins, we have our vertical wins, and then we also have our diagonal wins, right? Now, I went through the first example so that you could have a leg up on exactly what to do. And that was our 0, 1, 2 position. So our 0, 1, 2 position means that we have 3 in a row on our upmost row in our board. What else can we have? So on this note, we can also have our middle row here, which would be 3, 4, 5. And then we have our last row, which would be 6, 7, 8. Okay. So this is how we can map out the combinations we need for winning. And you're going to see why this is important in the lessons following. How about the vertical side of things? Well, for the vertical side of things, we're going to go for our most left or most to the left vertical combination, which would be 0, 3, 6. Then we have our middle vertical column, which would be 1, 4, 7. And then finally, we have our most far right or the furthest to the right vertical column, which would be 2, 5, 8, right? Okay, cool. Now, how about the diagonal side? Now, with this diagonal side, I want you to pay close attention to what I'm about to say, because there is a nuance here that is important, which is why I said to you at the beginning that don't worry if you have different results from another viewer, because it's very possible that can happen. And I explained to you why. So with our diagonal winnings, we know that we can win, which would be 2, 4, 6. So that will be from right to left. We also win if we get 3 in a row from left to right, which will be 0, 4, 8. How about our third position though? Now, in our previous lesson, I said that each direction has 3 possible winning combinations, right? Now, when it comes to the diagonal one, there's a little bit of a gray area here, and I'm going to explain to you why. Take a look. So we could also have 8, 4, 0, which means the player managed to get 3 in a row, but from right to left, starting from the downwards position to the upwards position, right? Now, equally, we could also have 6, 4, 2, which would mean the player got 3 in a row from left to right, okay? Now, the issue here is that if we were to go down this road of using 6, 4, 2 and 8, 4, 0, programmatically speaking, we're just repeating ourselves, okay? This structure over here is what we'll call the reverse combination. When we actually write our code, the code is going to evaluate both the forward position and the inverse position, okay, of what we've written. So we don't actually need to write the reverse combination. So even though technically speaking, we have a third position here, which would be our reverse combination position, so 6, 4, 2 or 8, 4, 0, we don't need to add that. So we're going to omit that, okay? Now you could even argue that there's 10 positions or 10 combinations because we could have 6, 4, 2, and then on another line, we can have 8, 4, 0. So now we have 10. But remember, when it comes to writing code, your greatest work is to be as simple as possible. So software developers, software engineers, we spend as much time as possible making things as simple as possible. And if we can programmatically evaluate both the forward direction and the backwards direction of the diagonal winning state, then we don't need to have this 642. So we can get rid of that. Now, how about writing some code? So let's go over to VS Code and start writing out the first parts of building this board, right? So let's go over to VS Code and take a look. Now, with the code we've written here, we don't actually need this anymore. But I'm going to comment it out instead of deleting it, because if you want to run a test yourself to make sure everything's working, as I call it, the sanity check, then you can uncomment this code and test this out to make sure everything you've got so far is working, and making sure TK and Pygame is working in the future if you need to. So the first thing we need to do would be what? Well, we need to create the board. Now, how are we going to create the board? Now, remember in our previous lesson, we had this expression here, which was a list object that has the none type in there times by 9. Now, from our section that we looked at in functions, what is the purpose of a function? Well, the purpose of a function is to allow us to have almost like a mini program. So it's a block of code that has some instructions that Python has to follow. We can use it repeatedly in any part of our program to execute some sort of functionality. Now, depending on how we write our functions, we can reuse it with different data, or it can be the same data being reused every single time. Now, in our case, we want to create a board that looks the same way every single time. So when we first start the game, we want to have a clear board. So we need to create a function for this because we want to reuse this functionality in our game. So the best name to call this would be create our game board. Now, in this case, we need to write the code logic first for our game before we can move on to the graphical aspects of our game. Okay, the logic that runs the game would be our code logic here. And then the final aspect would be the graphical user face logic. The last part would be the graphical interface logic that ties everything together. So in here, what do we need to do? Well, we simply need to return a non-list object 9 times, okay? So we're returning a non-list object 9 times. By doing this, we're creating the board, okay? So our board that has 9 empty spaces, every time we call create game board, then that function is going to run. Now, why would we want to run this? Let me give you some information here that is important. Let me give you some insight here as to why it's important. So let's think about this. Now, the first time the game starts, we need to have a clear board. So we need to use this once when the game first starts. Now, the other time we need to use this, which is why we need to turn this into a function and not just a simple variable, is because when the game ends, which will represent a round of the game, let's say is the best of 5, when round 2 starts, we need to have a clear board again, right? So we need to say when the game round ends and we are starting a new round. Now, with code like this, anytime we have a situation where we need to do something more than once, and it's a mechanical process that we need to repeat, we need to make sure that we have a function that can carry out our activity. So instead of having to call the variable, we can call this function to do its thing, okay? So this is the first aspect of what we need to do. What's next? Well, the next thing that we need to do is we need to figure out how we're actually going to create the board functionality. Now, when we want to create the board functionality, what are we trying to do? Well, if we're trying to create the board functionality, this is going to be dealing with having those X's and O's show up on the screen. So how do we do that? Well, what we want to do here is we need to create something called a button. Now, this button comes from the TK package. You see, in order for us to get the function where if we click on our game, we actually get an X or an O, we need to tell Python exactly that. So programmatically speaking, we need to create a way for us to have some sort of activity or some sort of relay between when a user presses on a square and then the response of providing either an X or an O. Now, the great thing to know is that our TK package, which is tkinter, has all of these functionalities available for us. So all we need to do is utilize those to our benefit. So we're going to create another function here. So follow along with me. Now in here, let's say that we're going to create our game buttons. Or let's just call it game button, because we're going to repeat this code 9 times. We don't want to create 9 different buttons because that would be redundant code. Now later on in this lesson, we are actually going to pass in some parameters because we're going to need some data in our function to know how we're going to render our X or our O on the screen. But for now, we'll stick with what we have, okay? Now, what we're going to do next? Well, the first thing we need to do is that just like we have our 9 spaces here, which are an empty list, we also need to have a matching 9 values that are going to be our 9 buttons. Now, for us to write this, the first thing to do would be to set up a variable. So let's call this our game buttons. And for our game buttons, we just want to create our empty list structure. Remember, our list is a collection type that stores a list of values that are indexed, right? So with our games buttons here, if we stored simple strings, so let's, for example, do this, and I said Michael in here, and I had John. I'm going to take this out of here just to demonstrate really quickly how the list type works. We'll drop this here. Now, indexing means that we can reference a value by its index number. So for example, Michael over here, and I'll leave it up here, would be, let's go about here, would be 0 as an index, and John would be 1. So over here, if I said print of game buttons index 0, okay, what do you expect to come on the screen? Well, if we run this code, we should get Michael on the screen. So let's go over here. And you see, now apart from what we get from Pygame, which shows up every time you import it, don't worry about that. Down here, you see that we have Michael. If I change this to 1 and I run our code over here, you see it says John. So a list is a very special type. It's the collection type again that allows us to have a list of values that we can reference by their index, which is why with our game board, we're going to have an index from 0 to 8, and we can use that to make reference to each of the different squares that we have inside of our 3x3 structure, right? So I'm going to get rid of this so that you can have space to continue writing. Now, if you want to keep that code there, you can keep it written because it won't be in the GitHub repository. All right, let's get rid of that. So we need an empty list for now. Now, what we want to do is we want to create these game buttons inside of the game, but we want them to be created in a loop structure. And this is coming back to what we looked at in our conditionals teaching about the for loop. Why am I saying we need a for loop? Well, we need to create 9 different buttons. And we want these buttons to be pushed into our games buttons list here so that we can pass it over to our TK window and update the data. So as we're clicking with our buttons here and an action is taking place, we're also going to be updating and controlling the buttons on the screen, okay? Now, if that didn't make much sense to you, don't worry, I'm going to comment on each line of our code. So since we have 9 different spaces, 9 different blocks, we need 9 different buttons. So a very simple setup would be to say for. Now, we can call it B for a button. And we want to say for B in range. Now, remember the range function allows us to add a number in here that can classify the range of values. Now, the range we want is of range 9. Now, by us putting 9, what does that equal to? Well, if we do this at the top here, range 9 would equal to 0, 1, 2, 3, 4, 5, 6, 7, and 8. So we still have 9 values, but it starts from the 0 index. You find in programming that a lot of things are 0 index, including when working with our range function. So if we ask for 9 values, we're going to get 9 values, but 0 is included as a number. Okay. So over here, we need to write our code. So in our block here, what do we need to do? Well, every time we have a value, so starting from position 0, which will be the first position on our board, we need to be able to push a button into that square so that when we click on it, the functionality for making an X or making an O on the screen will show up. So let's call this our game button and take a look at what we need. Now, in our module TK, our package, we have access to a very important property, which is called button. Now, it's actually a class, okay, but it's a property of the module. Now, take a look at all of the different arguments we have. Now, we have very similar arguments to what we had when we were creating the label, because this is something that allows us to create our graphical viewership, our graphical user interface, okay? Now, with all the arguments we have here, the good thing for you to know is that you don't need to use all of these in order for you to create a game. Now, I know there's a lot going on here, and if you scroll down, it's a bit much, but I want you to trust me that we don't need to fill in all of these different arguments in order for us to get a game. The more things you fill in the arguments, the more specific your game will be, or the more tailored you'll make it towards what you're looking for. But you don't always need to do this, right? So in our case, what do we need to do? Now, we're going to use something called the root here. Now, the root won't show up yet because I haven't written out the variable for that, but you're going to see what the root is very soon. The next thing we need to do is provide text. Now, every time you create a button, you can choose to have some text in there, or you can choose for it to be empty. Now, when the game board starts, we want it to be empty, and we want to allow the value X and O to be pushed in there. We don't want actually to have it as X and O already, because that wouldn't make sense for a game. So we need to leave this as an empty string, okay? Now, the next argument that we can pass in here for our visual customizations would be the font. Now, with the font here, if we want to pass in some descriptions here, you see that it says we have TK default font. So if you don't pass in anything, it's going to have a default font. But we don't want to do that. Let's have a little bit of fun with our font. Now, to start off here, let's just start off with what is called the normal font, okay? Now, for sizing, we're going to leave it at something really small. Now, the actual size we want to go for is going to be around about 35, 40, but I'll leave it at 10 for now, just so you can see what's going on. Now, we can also decide on having a width and a height. So for our width here, let's start off with 5, and our height will go for 2. Now, why am I going for this structure? Now, usually when I'm building games, I usually have ratios in my mind. Now, when it comes to the width versus the height, okay, the width is talking about how wide something is, the height is talking about how long something is. Now, for our button here, I usually like to have a wide width and a smaller height. So that ratio is about 2.5, 1 to 2.5. Some people do 1 to 3, some people do 1 to 2. Now, don't worry too much about this, because as you go along, you see how you can control your ratios and what they do. Now, the most important part that I want you to pay attention to is this next argument here called command. Now, if you're not familiar with any other programming language, no fault to you at all. You're in the process of learning, and well done for taking the advantage too. But if you are familiar with any other programming language, especially things like JavaScript, which is an event-driven language, this command keyword will start to make sense if you've had any experience with event listeners. Why? Well, I'm going to write a little note here about command. So I'm going to call this the command ARG. Now, what does the command argument do? Well, in here, we can provide a function that is going to be called every time a game button is interacted with. Okay? So every time a game button is interacted with, this would be the command that is run. So in our function series, we didn't touch on this other aspect of function that I'm about to show you. So this is new learning that you can add to your roster on how to build applications. Now, this command here is expecting a function. Now, in order for us to pass a function here, we need to declare one. Now, the only problem is that if you look at our code here, the function that we're going to write will take a lot of space, and we don't want to do that. So Python has provided a very simple way for us to solve this problem. How do we do this? We use something called a lambda function. Now, a lambda function is also called an inline function, and you're going to see why it's an inline function in a moment. Now, when we want to create functionality that is very simple, and in this case, what we want to do here is that every time we click on the button, all we want to do is just set our data that we have, which in this case is going to be our position. Let's say, for example, position 0 with the data that we've set here. Okay. So what do we do? Well, in our position that we have here, we can call lambda. And one of the most common syntax that you're going to see in Python is this. We're going to see lambda is going to be B. Now, to the left would be the parameter. On the right would be the implementation logic. We just want to say B is equal to B. Okay. That is it for now. Now, once we've done this, we have one more thing that we need to do. And over here, for now, our code won't work. We're going to do something here where we're going to update the state of our game. Remember, I told you earlier on that we have this special word called state. Now, state, for now, I'm just going to put a print statement of B. Okay. But we're going to change this in a moment, just in case you have an error in your code. But anyway, as I was saying, so state is the position of a variable. If we're dealing with a variable, it can also mean the current position or the current situation of our application. So, for example, what is the state of our game? Well, we could be in, for example, starting state, which means that on our games board, there is 0 positions being made. So there's no noughts, there's no crosses, or there's no X's, no O's. Now, with our command argument here, we want to pass in a function that every time we click on a button, the state of that button is going to be updated. Okay. Now, to do this, we're going to need to have a function that we can update the state with. Now, by calling lambda over here and saying B equals to B, okay, what we're saying is that we want to pass in a parameter, and that parameter, we're going to call a function for that parameter so that it can update all of the different values we need in order for a button to be a button in our game. Okay. Now, once we've done that, what's the next step? Well, we also need to work on creating the structure for our grid. Okay, so we need to create our grid structure. So whenever we create our button, we know that we're dealing with squares, which we'll call our grid. Now, for us to be able to make our grid, which in our case, if we're playing the traditional tic-tac-toe, is going to be a 3 by 3 grid. So we have 9 positions, 3 by 3. What we need to do is that we need to take our game button, okay? And for every game button, we need to create our structure of what we want to do. Now, the great thing is that TK or tkinter comes with some really good built-in functionalities that we can make use of. And one of them is if I call game button over here and I put the dot notation, if we type in grid over here, you see that grid has this rectangular shape here, which means it's a property. Now, if I call grid over here as it is and open up the brackets, take a look at what it says. So as you can see here, we have this grid functionality that allows us to create the positioning for a grid. Now, in our graphical user interface, we need to represent our 3 by 3 squares as a grid shape. So grid is the way we represent this. So we can use our column, and we can use this to identify a number of columns starting with 0. And then we can also do our column span, which is going to allow us to span how many columns we want. In our case, when we're dealing with a grid, we need our columns and we also need our rows. Now, there are many different keyword arguments here. And if you take a look, we have column span, we have row, and we have row span. Now, for now, we don't need to worry about the spans as much because we're just dealing with a 3x3 game. So design-wise, we need to make sure our columns and rows are 3x3. And when we do this, what's going to happen is that it's going to generate for us a very lovely 3x3 grid with 9 spaces. So how do we do this? Well, first, we need to provide a calculation of how many grids or rows we want. Now, right now, with our range here of 9, we can use our number of b to give us the information about what we're dealing with when it comes to our grids and rows. So if I go to row over here, right, what can we say? Now we can say row is going to be b. Now, this is important here for you to pay attention to. So whenever we're dealing with a 3x3 situation, and in here, for us to make sure that we keep in line with the 3x3 calculation, if you go back over to the code for just a moment, so I'm going to delete this so you can see what I'm talking about before I continue, because I really want you guys to get this. With our column, you see that columns start with 0. When you go over to rows, it also starts with 0. Okay? Now we need to figure out how many rows and columns we need. And when we do the maths here, you're going to see exactly how this works. So it says it starts with 0 for column and row. So we're going to say that we want our column to be b. Now, if I say b divided by, for example, 3, because we want it to be 3x3, we're going to run into a little issue, okay? The reason why is because if we do our calculation with our range from b range to 0 to 8, yes, we have 9 values, but in terms of numbers, we only have 8 numbers because 0 is just 0. So it actually will represent 8. Now, 8 divided by 3 gives a remainder, and we don't want that. So what we need to do to solve this problem, and of course, 8 divided by 3 is not exactly 3 either, all right? But again, if we want to solve this problem, we need to use the double divide symbol. You see, the double divide symbol, when we use it in Python, will give us a whole number integer. So over here, 8 double divide 3, opposed to 8 divided by 3, which equals to roughly around about 2.6, would give us exactly 2. Now we need 3 columns, and because column is 0 index, it will give us 3 columns, 0, 1, and 2. Now we use this double divide again. It's a little bit opposed to maths because in mathematics, if you have something that is above 5, so 2.5 and above, we round it to 3. But in this case, we're rounding it to 2, okay? So this is the way that we can use our double divide symbol in this case. Now row, how do we do this? In our case, we need to figure out with our rows how many rows we have. Now I know it's going to be a little bit weird what I'm saying, but I just want you to stick with me here so you understand how this works. Now with our row, the calculation that we need to use would be to use modulus, okay? Now modulus and 3 would be how we solve the issue of how many rows. Now, if we were to do this down here, I'm going to show you something really quickly. So if we create the for loop and said for I in range of 9, and we simply said that we wanted to print out, okay, I, and then modulus 3, okay? Now, none of our code over here is going to run because we haven't called these functions, so you don't need to comment anything out. But if I run this on the screen, take a look at what we get. So you see we get 0, 1, 2, 0, 1, 2, 0, 1, 2, and it continues going. But you notice that the highest number is 2. And this is the part that gets weird. Okay? Now, b modulus 3 means 8 modulus 3. And I'm going to write this here. 8 modulus 3. Now, modulus helps us to calculate how many times something is divisible by something else. Secondly, it shows us how many remainders. Now, we only see the remainders part, not how many times something is divisible by per se. If something is completely divisible by a number, by another number, then it would be 0 that we'll get as an answer. So if it was 6 modulus 3, it would be 0. In our case, we do get a remainder. And the remainder that we get is 2. Now, I know this is still weird, but if we say remainder 2, because rows start from 0, we're going to have 0, 1, 2, which means we still get 3 rows. Okay? How about with our column? Well, with our column, if I say B, or I in this case, double /3, and we run this, you see we get 0, 0, 0, 1, 1, 1, 2, 2, 2. Now, we have 3 values, but in terms of how many rows we have, we actually are going to get 3. Now, even though the answer that we're going to evaluate to would be 2, 0, 1, and 2, we'll get 3. Okay? So columns, let's write this up here. Columns would be 0, 1, 2, which equals to 3 rows. 3 columns, excuse me. And then our rows would be 0, 1, and 2, which will equal to 3 rows. Now with this calculation here, we have our 0, 1, 2, so 3 columns and 3 rows. And now we've created our grid. Okay. Now, once we've done this, all we need to do now, since we've created a grid, is to add the values that we get into our list. So our list will start off as an empty list of buttons. There won't be any buttons there. But as we click on the button and our command is fired, we want to be able to trigger our buttons to do something, right? So I'll get rid of this over here and let's write some code. So right over here, what we're going to say is that our game button that we have, what do we need to do? Well, if we want to add something to a list, we use a method called append. And the append method adds something to the end of the list. Now, it's important it goes at the end because we do want it to be in the correct order. We don't want something to be added in randomly. We want it to be one after the other. So in our case, what are we going to add? Well, every time we create a button, we want to push that button into our list of buttons. So we're going to push in game button. Perfect. Now, once we've done with this exercise of pushing in buttons based on this for loop, we want to get access to this array of games buttons because inside of this array of buttons or list of buttons, now technically speaking, this is a list, not an array, but you might hear me use the terminology of an array, which apart from being a data type can also mean a list of values in a programmatic sense, okay? But we have our list of values here. Now, creating our game button, we need to send these buttons out of this function and into another part of our application, which will be our GUI, so that they can be displayed on the screen. So right over here, what we're going to say is we're going to return our game buttons. Perfect. So once we return our game buttons, now when we click on our buttons, we can get some functionality. Now, wanting to know over here, we're going to come back in the next lesson and think about how we're going to create our function. In fact, the function we're going to create here is going to be called exactly what this sentence is about, which is going to be update our state. That's what the function we're going to call is going to be called. Now, also, we're going to take care of our root in our next lesson because we need to have what is called the root, which we'll see in a moment. So in the next lesson, let's continue with building our code. See you in the next lesson. All right, people. So welcome back. So let's talk about updating the game state. So in our game, I told you in our previous lesson that we have this important functionality we need to add, which is updating state. Now, the term state is a computer science term, and it has 5 different meanings. Now, in the context of our game, what does state mean? Okay, so let's talk about it. Now, in the context of our game, our focus is on what I would call the program state. Okay, now by definition, the program state means the state of the condition of the overall game application at a specific point in time. Okay, I'll say that one more time. So the state in the context of our game means the condition of the game application at a specific point in time. Okay, so there's 2 keywords here. It's the condition and at a certain time. These are 2 things we need when it comes to working with state. Now, this definition may seem a bit vague to you, but let me continue on with exactly what this means in our context. So in context, there's going to be 3 different things we're going to look at when it comes to handling, managing, updating the game state. Number 1, be dealing with variables. Number 2 would be dealing with the component status. And then number 3 would be memory contents. So we're going to be observing variables, the component status, which means the different functions and different attributes that come with those components, and also memory contents. What's being stored in memory at a specific point in time when using our game application. Okay, so let's go back over to VS Code and actualize this theory. All right. So the first thing, again, as I said, we're going to deal with is updating state. Now we need a function for that, and I'm going to explain to you what this function is going to do. So over here, I'm going to call this updating the game state. Now, the reason why we need to update the state of the game is because, as I taught you in the previous lesson, using this for loop, we have 9 buttons that have been created for us. Now, each of these buttons that come from Tkinter are going to have a command function, which is an event listener. It's an event listener that's going to be listening for when we click on one of our 9 boxes in our board grid. Okay, when we do that, we want to trigger this function to happen. Now, that functionality needs to be a functionality that number 1 would, and I'm going to write this over here, would choose whether we have player 1 or player 2 making a play. Okay, so we need to choose whether player 1 or player 2 is making a play, because when we click on those buttons, if we don't update the state, maybe, for example, we might just get all X's on the screens, or all O's, or all crosses, or noughts. We don't want that. We want to have an alternation between one and the other. And we need to be able to update the game state so that the game application knows exactly who's playing at what specific moment in time, which is what game state is all about. Again, is about the condition of something at a certain point in time. Okay, what else do we need to do? Well, we want to make sure that when we're dealing with our game, we can make sure we can check, and I'm going to write this here, who the winner is. Now, why do we want to check who the winner is? Well, checking who the winner is going to trigger a few things. Now, in our game, if I was to call this 2B, what would happen if we have a winner? Well, if there's a winner, then either we're going to reset the board for a new round. Okay. What's the other thing we might do? Okay. We might have a celebration and play our winning sound. Okay. Etc. and etc. Okay. So there are a few things that we can have going on when a person is a winner.
I'm saying etc. and etc. because I've only gone for the first three. In later lessons, we're going to go through other ones. Okay, so when it comes to updating the game state, let's write a function here. So here, let's call this update game state. Now, the thing with our function when it comes to updating the game state is that we need to work with a few different variables. Remember, I told you that there were three different parts to working with state in the context of our game that we need to deal with. Okay, the first one is we're going to want to take care of managing the state of the actual board itself. Okay, so the board has its own state. It has 9 different squares, and one of those squares at any time can be an X or an O. Okay, depending on who clicked on it. Now, with those board comes the buttons. Okay, and the buttons themselves are the functionality that provide us an X or an O and all of the different parts to how we play the game. What else? Well, when dealing with a situation like this where we have our board and buttons, we also need to update information about the player themselves who's playing. So we need the player's info. Okay, so we'll call that player info. Now, one other thing that's important, and I don't want us to forget here, is that we also need to keep track of the index. When it comes to the index, it might seem a bit strange because you're thinking, why do we need to keep track of the index? Don't we have the board? Well, as I taught you in our previous lesson, we know that our board will be 0 index because we're dealing with a list of values. And with our board itself, we know that it's 9 squares, okay? But in order for us to know what's going on a specific square, we need to have information about the index. So the index is going to be updated so that we can keep track of what index on our board has been filled. So for example, if we have index number 1, which is going to be the second position in the grid, we don't want to be able to click on that same index again on the board and do some sort of action. Once that action has taken place, we want it to be set in stone. Otherwise, we won't have a stable game. Okay, so these are the 4 things we need in order for us to update the game state. So the first thing is, before I put these parameters in here, and I'll just do this down here. What do we need to do? Well, the first thing that we need to do would be to deal with our player. So I'm going to put number 1 here, logic for our players. Okay. So what would be the logic for our players, right? Well, the best thing we can do is, because we're playing the game of X's and O's, traditionally X's come before O's. So the first player in our game should be the player who makes a cross. So it's noughts and crosses, not crosses and noughts. But when it comes to playing the actual game, it's always the X that goes first. Now, if you want to go the other way and put the nought, which is the 0, you can do that either. You can do that as well. All right. So let's just call this our, let's say that this is our player. Now with our player here, we need to have a ternary operator as an expression. Now, what is this expression in this variable going to determine? Well, in this variable, what we want to determine is whether we have player X or player O. So we can use a ternary operator, like I've shown you in our previous sections here. And we'll say if the player is a nought, okay? Now, again, you can also choose to do a cross, but I'll do a nought and then a cross just for the sake of noughts and crosses. All right. So if player is a nought, how do we know if a player is a nought? Well, what we want to say is if, and this is where we're going to need our state variables. Because in order for us to determine whether it's a nought or a cross, we're going to need our board. So I'm going to drop our board in here. So we'll say if our board. Now here, we need to use a special method here called count. Now what count is going to do is just keep a track of whether the person is a nought or a cross. Just trust me on this one, but we want to use the word count. So if board is count,
of our O. Now, when it comes to this expression, by the way, I just want you to know that with a ternary operator in Python, the result we want is on the left-hand side. So what we're saying is if board count is a naught, okay? And in this expression, we're going to say if that's equal to board count, and we'll say X, else we're going to have X. Now, you're probably thinking, what did you just write? Well, let me explain. So with a ternary operator, what we're saying here is that if board count of our naught is equal to the board count of our cross, then the value would equal to the player being an O, which is what's going to appear when we click on a box. We want the O to appear. If not, it's going to be an X. So you always have to practice reading ternary operators because I know in Python they can be a bit strange sometimes. Okay. I know in other programming languages it's kind of from left to right, but Python's kind of backwards and then forwards. Okay. So if this if statement is true, then it's going to evaluate that the player at this current time is going to be a naught. If not, they're going to be a cross. Okay. All right. Now, what else do we need? The next thing we're going to need is that for the naught or the cross, we also want to keep track of the player's name. We also need to know what player, as you saw in our demonstration video, what player is the naught or the cross. So up here, we're going to put in our player info. Now, whilst building this, you're probably wondering, why didn't I say player here instead of player underscore info? Because it seems a bit longer. The only reason why I did that is because player info and player, when I was writing this code, was going to clash if I have player here and player here. Too many things going on, okay? So risk that you might make a mistake. All right, so on the next line, what do we need to do? So here, what we want to do is we need to get info about our player, okay, who is either a naught or a cross. So here, what do we want to do? Now we need the name of the player because as you saw in the game, if let's say the player is Michael and he chose to be a naught, and then the other player would be assigned to be the cross or vice versa. Okay. So we can say that our player name. Now, what we want to do here, again, when we're dealing with this information, is that we're going to say the player info. And in our case, for this to work, we need to have the information about the player. So we'll say player info, and then after we'll say the player. And then from the player, we need to get access to the property of the name. Okay. Now, this square bracket notation is a notation that we use to be able to get access to information about something that is inside of what we call an object. So our player info will give us access to the player, which in this case will be a naught or a cross. And then we also get access to the name. This way that we can, so in this way we can assign a name with a naught or a cross for the two players that are going to play our game. Okay. And that's as simple as it gets. Now, the next thing we need to deal with would be the actual board itself, because we're dealing with updating the game state. And what that entails is that as the game is moving around and as people are choosing the naught or a cross, we want to make sure that when they're choosing the naught or the cross, the game receives those choices and updates itself and presents the next available option so that the game can flow in a linear cycle. Now, for that to happen, we need to make sure that we're dealing with what's going on with the board itself. Now, to deal with the board, we need two parts. Of course, we've got the board, which is our first part, but the second thing we're going to need is going to be the index, because to keep track of the state of the game, which will be our board,
we need to know what index is doing what indexes are empty so that we can actually have a selection go there for the next person playing the game in terms of taking turns, or what, of course, box we can't fill in because it's already been used. So we need the board and the index for this. Now, right here, what we can say is we can just simply say if the board, and then we'll say index. Now, index is going to be data that's coming into this function when we call it. So when the index has been chosen, we will be able to decide whether that index can be filled out or it shouldn't be filled out. Okay? That would be the best thing that we should do. Okay? So in this case, if I go back up for a moment so you can take a look at what we've got, you'll see that our creating our game board function returns us a none list object 9 times. Okay? Now we need to check if that place is going to be none inside of our board, because if it is, then it's available to be filled out with a naught or a cross. So here what we want to say is that if the board at a specific index is none. Now if we do that, what does that mean? Well, if the board index is none, what could we do? Well, this could leave room, and we can say that, for example, that here the player can fill this board index with their naught or their cross. How do we express that? Well, all we've got to say is that board and that specific index that is empty is going to equal to our player option, right? Now, maybe same player option might be better than same player. And as you can see, if I hover over this, it says we have a literal 0 and X for each of these values here, okay? So essentially what's going to happen is that anytime we have an empty box and the player selects that field, or the player's made a selection and that box is definitely empty, then the player's option here is going to be passed inside of here. So if you want to call this player option instead of player, it might help. So we'll call this player option. And then we'll change this to player option. Okay. And we'll pass here player option 2. You can follow along. Sometimes when you're writing code, I like to do this myself, that as you go along, sometimes you'll write variable names and change them because you find a better description, or you found a better description for them, okay? So that's what we've got going on in this case. Now, from a game standpoint, we've taken care. So from a gaming standpoint, we've taken care of this field right here, but we're not done, because there's also another programmatic side that we need to take care of. And what we need to take care of here is that what happens if this index on our board is filled, okay? The question would be, what happens to the TK button lodged in that box, okay? So essentially, if we click on one of our grids and it becomes an X or an O, what happens to the button in here? Because if we don't take care of the button, then what's going to happen is that that button is still going to be active and could change the state of the game when we don't want it to. And that's going to be a bad idea. And this is, of course, how games have glitches and then people cheating, etc. But we need to mitigate that. So we also need to tell Python to do one more thing. And for that, we need to get access to the data of our buttons. So at the end here, I'm going to pass in buttons here. And what do we want to say? Well, we need to configure the buttons in a way so that we can disable the button. So here we need to disable the button for the grid that has been filled. Okay. So if we're going to disable the button for the grid that has been filled, what do we need to do? Well, we simply need to call buttons. And then now buttons, of course, is in a for loop. All right. Take a look. our buttons in our for loop that we had, which is in an array, which is in our list called game buttons. So games button starts at index 0 and ends at index 8. So if we pass the index of these buttons, if we pass the index of the button that has been clicked on, essentially and been filled, then we can also disable that button from being used again, during the duration of the game. So for example, right now, let's say that we click on index 2. If we pass that information of index 2 to this button, then we can disable the button at index 2 so it no longer has any participation in the game until the end of the game when we're going to reset the board. Okay, so in here, we're going to pass this same index. And when we pass the same index, what we want to do is, now at the moment, we won't get any dot notation because there isn't going to be data. And when we pass in this data later on, the code logic we've written will activate itself and start to carry out what we're asking it for. Now, with buttons here, when it comes to TK buttons, we have a method called config, okay? And with config, we can provide information about the configuration of a button. So in this case, what we want to do is configure the specific button we have and say that we want the text to be equal. Now, in this case, what do we want the text to be equal to? Well, in that button field, we want the text to be equal to the player's option. So if the player chose naught because they're the naught, then we want that field to be naught. So we're going to replace it with empty text and say that we want it to be the player's option. Okay, so we'll say player option. Now, the other part that is important here that we want to happen is we want to use a special property, which is one of our keyword arguments here called state. Now, state, as I've spoke to you about before, means the condition of a variable. It could be memory contents. It can be a component's status in the duration of an application. Now, specifically here for the button, we want the state of the button to be what is called disabled. By passing in this command here, this piece of information will disable the button from being clicked again. So we won't update the state of the button again until the end of the game, which is perfect for us because that means we have one choice and that choice remains where it is for the duration of the game. Okay, good. Now, we also need to take care of a few other things. Okay, the other things that we need to take care of is checking who the winner is. Now, how are we going to check who the winner is? Now, if you're thinking, I don't know how I'm going to do this, don't worry about it because you've actually found out who the winner is theoretically already. And I'm going to show you. And I'm going to show you. So, to check who the winner is, we need to know what the winning combinations are based on the index. Wait, we've already done that, right? If you remember from our previous lesson, I told you to make a note of all of the different winning combinations that they can possibly be. And I also went through what the winning combinations are. So we can make use of that in a function to work out what the winner, to work out who the winner is in our game. All right, so down here, let's call this check who the winner is. So we need a function here. Now, the best way to do this is to say check game winner. Now, for us to check who the winner is, we do need to pass in the board as data to this function because this function needs to take a look at the board and calculate based on what indexes have been filled in what format, in what combination, as to exactly who the winner is, okay? Now, the great thing here is that when you theorize your data, which is why I've done this with you, because when you're building real applications and working in the industry space, planning is very important and is just as equally as important as writing code. So theorizing stuff and writing down notes and making scribbles is all part of the journey. Now, in our case here, we've already done this. So we need to just keep track of these winning combinations. So we can say winning game combinations. Now, with these winning game combinations that we have, we can store all of them in a list. And this list, we can keep a track of exactly what's going on later on using programmatic means in our code. So let's start off with our combinations for our columns, right? So with our columns, the combinations would be 0, 3, and 6. Okay. What else do we have? We have 1, 4, and 7. And we also have 2, 5, and 8. All right. So this would be our, let me write this here so that you have a bit of space. So these are winning combination for our columns. Okay. Now our columns, again, we're dealing with our verticals. Okay. So our vertical wins. Let me make some space here. And let me put a comma here so that we can go to the next line. Now let me just cut this out so that I don't get in the way of a code. Make some space here. Okay, here we go. All right, so the next one, of course, with our verticals will be our horizontals, which is our rows. So our rows will be 0, 1, 2. That's the top row. The next one would be 3, 4, 5. Now, if you've got this written down on a piece of paper, you can even pause the video ahead of me and fill these in and then come back when I've completed it. And then we can continue together. Or if you want to just type along with me, that's absolutely fine as well. And then we have 6, 7, and 8. All right, so I'll leave a space there and then to continue. So this is our winning combinations for our rows, which is our horizontal wins. Okay. All right, and then here we have our last bit, which is going to be our diagonal wins, right? So this will be 0, 4, and 8. Okay. We have 2, 4, and 6. I remember in our discussion that we don't need a third value, which was our reverse index, which is either a combination of 840 or 642, because once we've written the forward direction in our code, the backwards direction will be taken care of already. Okay, so with that being said, let's drop this here and let's put a little note. I'll copy and paste this to save on time and say a winning combination for our diagonals. Diagonals. Okay, so when it comes to our combinations here, if you're still wondering, the idea here is that we need to make sure we keep track of unique combinations. Okay, not reverse combinations. As you can see here, none of these, if you reverse them, would produce any other single one. So these are all unique combinations. Great. So now we have a list of a list. And if you hover over this, you'll see that we have a list of a list. That means that if we wanted to access information about our columns, okay, we could use a for loop and indexing to get access to the combinations for vertical wins or horizontal wins or diagonal wins. Okay, now all we want to do here with our check winner is to check the combinations that we have. So we need a for loop for this. So we can say, for example, here, so let's say check if there is a winning combination. Okay, so we can say, all right, winning. Let's just delete this here. So we'll say for. Now, a simple name wouldn't be to say just like winner or something like that because it might be a bit vague.
Okay, so we can call it winning combo like this. Okay, you can call it combo for short. You can call it WC if you really want to. Okay, but when you're writing your code, it's important that you make sure that you have variable names that work, even for for loops. So I'm just going to call it winning combo because in my mind, that makes sense. If you rock with that, then you can follow along with me in the same way. We can quickly change it to something you're comfortable with. Again, I want you to make this code your own. All right. So in our for loop, what do we want to do? Well, we just want to loop over our list of combinations and check if the combinations that are on the board for any of the players match these winning combinations, okay? So if we do this, then what we'll do here is say in win game combinations. All right. Here we go. So what do we do here? Well, the best way to decide is if we do our if statement here, and we're simply going to say that for our board that we have coming in here, so the board has an index from 0 to 8, okay? And it has different combinations that we can have. Now, what we want to do is that we want to say if the board has a winning combo, specifically at index 0 here, because we want to deal with every aspect of our combination direction, so vertical, horizontal, and diagonal. So say if the board has the winning combo that is 0, okay, which also equals to the board having a winning combo of 1, which equals to the board having a winning combo of 2, then we want to do something. Now we're not done here. So we have our winning combo at index 0, at index 1, or at index 2. Now the part that's important that we want to make sure of is, so we need to make sure that with our winning combos 0, 1, and 2, that we capture the combinations that we have in our win game combination. So the purpose of looping over our winning combinations is so that we can make sure that we actually have a combination of actual values that are not none. And this is why at the end of this statement, if we left it as it is, what we would have happen, and I'm going to leave a note here for you so that you can understand what I'm saying. If we do not check for board values that are none, now let me make it clear, not none, then a player would win the game based on empty squares. Okay. So with code logic, when we're writing code, as I said to you in previous teachings, that there are two different types of programming approaches that we can have to a programming language. We have declarative programming languages and we have procedural programming languages. Now, Python is a procedural programming language, which means that every aspect of our code logic needs to be defined. We need to tell Python exactly what it needs to do. Now, in a declarative programming language, we provide an end goal as to what we want to happen, but the framework or the programming language decides on the route to get there or the route to get there. Okay. Now, in our case, why am I saying this? Well, with this current logic, if I was to continue here and start writing more code and saying, if this combination is there, then we want to, do the necessary aspects of what happens if someone's a winner. Now, in this case, if someone's a winner, the simplest thing we can do would be to return a true or false statement. So we can do a return here of true. And by default for the entire game, until we get to the point of checking who's a winner, this function should always return false. So we'll put return false over here. But back to what I was saying beforehand, this logic isn't done. And the reason why it isn't done is because of this procedural programming concept. At the moment, this combination by itself doesn't check to see if the boxes or our grid boxes so 3 in a row in any direction, is not an empty row. So we could have an empty diagonal row, an empty horizontal or vertical row that could also be evaluated as a win. So we need to be careful of that. So we have to add that into our code so that it's very clear as to exactly what the conditions are for winning. Okay. So in here, we also need to say and. Now think about this. If you're writing code and you're saying that you want to add another piece of functionality, I've given you the and keyword. We want to say and board, okay? And we'll say the winning combination for index 0, position 0, is not none. Now, this expression saying that if this is not none, we'll check to make sure that we don't have boards that are empty. We need to make sure that we have fields that are not empty. So they need to be filled with either a naught or a cross. Okay. So if you reevaluate this one more time, we're checking for winning combo 0, winning combo 1, winning combo 2, and we're also checking that the first winning combo, okay, is not none. So if that value is filled in, then we can continue with our true. If not, it's a false. Okay, is that all cool? So now continuing on, when writing code like this, I want you to always think about procedural language. Now, in this case, if we're saying something is procedural, that makes sense? All right, so when we're writing code like this, I always want you to think about a recipe book. So when we're writing code like this, I want you to think of it as a recipe book. You see, in a recipe book, we have very specific instructions step by step on exactly how to get the end product. And when we write code, we're doing exactly the same thing. We're cooking, we're writing our own recipe as to exactly how we want the end product to go. So we have to be specific about all parts. We can't assume that just because we have our winning combo loop, that Python is automatically going to assume that we're not wanting to see any wins for someone who has empty fields. Okay. So always remember that when you're writing your code. Now, what else do we need to get done? Now, in our case, when we're writing our code like this, we also need to make sure that we deal with the state. Okay. Now, in our state over here, what are we trying to do? Now, the logic checking to see if something is none would allow us to provide the option to players to choose, to put a X or a O, depending on what they have on the screen. And then we disable that field after they finish making their decision at that index. Now, we're not done here yet because now we also need to incorporate what happens if someone does win the game, because that will be a change in state, because the game is going to go from a state of, let's call it game in session to game completed. So in that case, we need to write more code. So if we're going to write more code in this manner, what do we need to do? Well, in this case, now we need to use our function check game winner in another if statement. So let's go here and say updating the state of the game if there is a winner. So if there's a winner, what do we do? Well, easiest thing to do is we're going to say if check game winner. Now remember, because we have state coming through for our board, we can pass that down into our code here. So we're going to have data that we're passing in here, which is going to be the same data that all of the other parts of our function variables and attributes will look at to decide as to whether we should end the game and start a new one in our case, or continue playing the game. All right. So let's continue. So what we want to do is check if there is a winner. Now, if there's a winner, there's a few things that we need to do. Now, in order of how the game goes, the first thing we need to do, because our game is a game that can have, for example, best of 5 rounds, best of 10 rounds, and etc., we need to add 1 point to the winner of the round. Okay, that's number one. Now, in order of what we do next, the next thing that happens when the winner gets a point added is that we want to play our winner's soundtrack. Okay, so for that, we're going to need Pygame. Number three, what do we need to do? Well, we want the confetti to appear on our game screen window. Okay. Now, once we've done that, we need to also have another option here because in our check game winner, we're checking for winners. We're not checking for a draw. So we need to also incorporate logic to check to make sure that, okay, we know that we don't want empty fields and we also want to make sure we have winners, but we additionally want to check to see if there is a draw. Okay, slash a tie, depending on how you call it, right? So let's crack on with this part here, number one. So number one, we need to add 1 point to the user. Now, the good thing is that because we're in the same function scope, we have access to the player information that will be passed in. So we can simply say player info, and similar to like what we did before, we can say player info, and then just put that here. We want the player option. So this is going to be whether the person is the naught or the cross. And within that option, we want to choose the aspect of their score data point, which we can just call score for now. Now, all we want to do is we want to say plus equal 1. Now, why plus equal 1? Now, the plus equal syntax means that whatever the previous value is, score value is, add 1. That's all it means. So if the player score was 3 plus equals 1 would mean 4. The next time around, we'll save 4 as the actual data for what the score is, and then we'll add 1 and that will be 5 and etc. Now we need this kind of syntax here so that we can continuously update the state of the score. Okay. What about the next part? So number 2 is we need to play our winner soundtrack, which is pretty simple. Now, at the top of our file here, we imported Pygame as PG, or I did. You might have just imported Pygame. Now, Pygame is very simple to use. Now, if we go to PG, we want to get access to a property. Now, the property that we need in order for us to get our game to play our sound is we need to get access to something called the mixer. Now, the mixer has a class called sound. And within sound, sound has a few different attributes that we can make use of. Now, the attribute that we want is simply just to play. So if we call play, all we need to do here is pass the file, which would be the sound. Now in here, I'm going to leave this as an empty string for now because we're not going to play any sound for now. But this is just here so that we have a placeholder, okay? Now, when it comes to our confetti on the screen, we could write the code logic here for our confetti. But the issue is that we're going to have too much code within one function. And number two, we're going to break a principle called the SRP principle, which is called the single responsibility principle. Now, the SRP principle is a very important programming principle. If you want to be an industry-ready developer, it's something you need to know. Now, our function updating the state has one responsibility, which is to update the state. Now, what we can do is we can call the function confetti or check game winner or anything else we're going to add inside of our code, because what we're going to do is we're going to have a function called display confetti. But we don't want to write the actual implementation logic in here. We only want to call the functionality that fits within the responsibility of updating the game state, okay? Now, apart from that, when the confetti is displayed, we do have some other things that we need to do, all right? So I would say as a B point, we need to display who won the round. Then we'll say our C point would be to go over and then update the scores on our game window. Point D is that we want to reset the game. Okay, reset the game, which means we need to reset the board and the buttons. So reset the board and the buttons. All right. And then the last thing we need to do, which is important, is that we need to keep logic here to check whether the entire game has been won. And what does that mean? It means if all rounds are complete, so e.g. 5 rounds, and we have a winner, okay? We want to trigger that code as well. So this if statement will continue to be valid. And then when we get down to this point where we're checking if all rounds are won, if all rounds are won, then we want to trigger another function. We can call it something like check for the overall winner. We can have different names for it, okay? Now, these are what we're going to do in the next lesson, but just finishing off here so that we can work in pieces and you can take a nice tea break, have some food, and then come back and continue. We need a matching else if statement here. We need a counter argument. Now, if we want to check if something is going to be a win, we know that we have check game winner. But if we want to check to see if something is a draw, how do we do that? Well, we can use an else if statement right here. So we can say else if. Now with our else if functionality, if we say none, not in board. Now the thing is, we still need to make sure, again, thinking about procedural programming language, that we don't have none not in the board. So that means we're checking here that after all of our fields have been filled in, so all 9 squares have been filled in, if not one of them are none, which represents an empty square, but we still don't have a winner, we need to talk about it, right? So in here, what we can do is number one, we can use the TK message box, which we'll do here. In this TK message box, we can have a message to say it's a draw, okay? Simple thing to do. The second thing that we want to do is we need to reset the game, okay? So in our next lesson, we're going to take care of these functionalities. Now I'm leaving all of these code comments here and it will be available on GitHub as you're looking at this video online so that you can not only just understand what's going on from a user perspective, but you can understand what's going on from a developer's perspective. So I'll see you guys in the next lesson. Let's continue. All right, people, welcome back. So let's continue writing the code logic for updating the state of our game. Now, with our game, we know that we need to take care of, for example, what happens when there's a draw. And for that, we're going to need to get access to the message box functionality that exists inside of our Tic-Tac-Toe package. Now with our code, we have this error showing up at line 90 from our Pylon's linter, simply because we haven't closed our else if block just yet. And remember, Python deals with white spaces. So it's assuming that this function is actually supposed to be in here, but we haven't written it correctly, which is not the case, of course. What we actually want to do is write some code here so that we can get a message box to appear to let our players know that it's a tie break or it's a draw, okay? I'm gonna put pass here for now, and you see that our red symbol here, or our red writing, gets demoted down to yellow, meaning that we just have some warnings. So our TK message box, how do we get access to that? Now, with our current implementation, we've used our import alias statements, meaning we're using the as keyword to shorten the name of our import module that we're using, which is Tic-Tac-Toe, and also we're doing the same thing for Pygame. For us to get access to the message box that exists in Tic-Tac-Toe, I'll show you how it looks without what I'm about to show you next. So if I said TK and I said I want to get access to message, you see that there's no access to message box, just message. Okay. Now I can't write tkinter here either, because if I do, Python's not going to know what we're talking about because we've used a module alias. So the only way around this, if we want to get access to our message box which exists inside of this module, is to write a new type of statement, which is the from import structure. How does that work? So we're going to say from tkinter. All right, what do we want to do? Well, we want to import message box. And you see now we have access to our message box here. So if we go back down to our code, I can say message box. And you see I have access to it now. So I can get rid of this pass for now. We don't even need it. And let's write some code. Now message box is a module in it. Now message box is a module within itself, which contains some really important functionality that we need for our game. The one that we need at the moment is going to be something called show info, which is a function inside of this module that allows us to show information on the screen. Now, in this case, what information do we need to show? Now, there are two parts to the information that we need to show. The first thing we need to do is we need to give the information of the window. Now, the game that we're playing is called Tic-Tac-Toe. So we want it to be our Tic-Tac-Toe window. Okay. Now, show info also has a second argument here, which is going to be the message itself. Okay. Now, the message we want to give here is very simple, and I have it right over here. We can say that this game is a draw. Simple as that. Now, show info over here, if you want to gain more access to information about show info, you can find it on Google. If you type in tkinter message box, it will give you a list of all the functions that are available. And if not, I'll give you a link that will be available on YouTube so you can go and access the docs for that. But you should be able to find information about show info online also. Okay. But you can take my word for it that this is what we're using this function to do. All right. So after we finish with our message box, we need to reset the game. Now to reset the game, we could write the code logic right here to reset the game just this one time. But based on the structure of how our game behaves, it's better for us to have a function that we can call to reset the game at any time. Because there could be different reasons we want to reset the game. If there's a draw, we want to reset the game. But also if someone wins, which is 3D over here, we also want to reset the game. And anytime you find yourself having to write the same logic in two places, it's a lot better for you to create a function that we can call at any time to carry out that specific functionality. So establishing that, we're going to need to create a function called reset game. Okay. So in a moment, we're going to create that function, but we just want to take care of any of the other parts first before we continue to write any function. So when it comes to displaying who won the round here, which is our part B, along with displaying the confetti over here, we need to also think about whether we're going to be using this more than one time. Now, the good thing is that when it comes to displaying who won, we're only going to show that one time for each game. So we don't necessarily need a function for that. So we can also have a message box over here to display who won the round. So let's just say that display confetti is going to be here. And then for part B, we want to display again who won the round. We can use message box again. So we can call message box. Now with message box, what do we need? Well, with message box, we need show info. Now, I noticed that I've used show info with camel casing because I'm so used to using camel case because of JavaScript and TypeScript. And now you see that we have a bit more IntelliSense here. So if you write it with a capital I like I did, please change that to a lowercase I. And you see that now we have these three arguments. The third one is a keyword argument, but the first two is a title, which is the title of the message, and then the actual message itself. And we're going to put that on our window so that we can show that if there's a draw. And here for show info, we want to do the same thing. Now, the difference here is that we're going to, of course, use the same title. So it'll be Tic-Tac-Toe because that's the game. But then the second argument here is actually going to be the format of a F string. So we're going to use an F string here. Now, why do we need an F string? Well, we want to display the name of the player that won. Now, you're probably wondering earlier on, how come we haven't used this variable up here? Now, this is the time we're going to use it because this gives us access to the name of the player based on whether they were naught or a cross. So if the player who has noughts has won, then we want to display their name on the screen. Now, because we don't know who's going to be who until the game is actually finished, or to be more particular here, when the round is finished, we need to just simply pass in player name. Now, if we use an F string, we can use curly braces to pass in the variable name of our choice. So what we want to do is say player name, and this will display the name of the player. Now, what else do we need to do? Now, the player's option, which is whether they're a naught or a cross, needs to be displayed as well. So we can have another part here, and we can say, okay, well, we want to display our player, so we can say something like player name. Maybe I'll put a dash here, or we can change it around. When we run this live, we'll be able to edit things around. So it might not be the best for now, but it will be the best by the time we're done. Okay. So we'll say here that we want our player option, which will represent the symbol. Okay. Has won this round. Okay. Now this minus sign looks like I'm saying takeaway, so maybe let's just say colon instead. That might look a bit better. All right. So now we have message box show info and message box show info here. Now message box should light up green. And if yours doesn't light up green, as long as you have IntelliSense showing that you have this function here, don't worry about it. But if you don't have anything showing up here, just double check that you've written your imports the way I've written mine over here. Okay. All right, cool. So we've got the message box out of the way. So I'll leave a little bit of space and I'll just call this our A point, which is to get display confetti. The next part is we have C. Now C requires us to update the scores on our game window. Now to do this, we're going to have to create a function for that, which is to update the game label. And then D would be to reset the game. So you see here again, as I said earlier on, we need to reset the game twice. So anytime you see that we need functionality more than once, we have to make it into a function. We can't actually just decide that, yeah, we're not going to do that and write it twice over. Remember, I told you about the principle called RI, which means do not repeat yourself. So already over here, let's just drop this over here. We'll move things around later on. We'll call this, all right, reset game. So with reset game, we'll leave it as it is, and then we can think about what we're going to do to reset the game. All right, so I'll put pass here for now. What else do we need to do? Well, let's just drop this in here. So we're going to call reset game for now, just as it is, and we'll put reset game here, just as it is for now. Now, the last part here, where it says keep logic here to check whether the entire game has been won. If all the rounds are complete, e.g. 5 rounds, then we have a winner. Okay, and of course, number 4 is if we have a tie. Now, we've done number 4, so I'll leave number 4 just here like this. And with our E part, we're going to need a function that's going to check the entire game. So to check the entire game to see if someone's won would only appear really in the update game state. If we use it in one more place, then we'll see when we get there. But for now, we definitely are going to need it right here. So we can use what I call the top-down approach, which is to write the answer which would be the actual function, and then write the solution afterwards. So we need some sort of function that we're going to use to check for the overall winner. So here would say check overall winner would be our function name. So check overall winner. But for now, I won't define it. I'll just continue from where we are. All right, so let's deal with resetting the game. Now, what does resetting the game entail? Well, the first thing for a reset game to be a reset game is that our board needs to be completely wiped. Would you agree? Okay, so our board needs to be empty. Now, with our code up here, which was create game board, remember it returns this none object here, list object 9 times over. Okay, and we need the exact same thing to happen again. Now we have two options. The first option is that in here, so let's put this here, we need to clear the board. Now for us to clear the board, we need to get access to the board. So we need to pass in data about the board instance that shows up when we run our game in here. So we can say something like our board. Now with our board, because it's an array from 0 to 8 of squares, which will be in this case a list from 0 to 8, what do we need to do? Well, we can simply use the syntax that I was explaining in previous lessons very briefly, but I'll go through again, which is to use this syntax here. Now, this syntax of putting a colon inside of a list. Now, usually we can have a range. So let's say we wanted to see the first 5 values. If we put 0 to 5, this will give us index 0, 1, 2, 3, and 4, but not 5 itself. Okay, so it's going to be from 0 in terms of index all the way to index 4, ignoring 5, but that will give us 5 values. Now, if we do this over here, we're saying that we want to set our board, all of the indexes to a certain value. Now, the thing we can do is we can say that, okay, for all of our squares on our board, we want to set this to the same structure, 9 times 9. Now we already have none times 9 here, so we could decide to call create game board and it will return us this same expression. So we can say over here, instead of none, we can just say create game board. Now the reason why I like this create game board is because when you read it from a story point of view, if you want to put it that way, it makes sense. When we reset the game, we want to create a new game board. And it's just because we don't have the name new here, but this kind of denotes to the fact that we're trying to create a new board. Okay? So we can call create new game board and that job is done. Now, what's the next thing we need to do? The next thing we need to do is we need to take care. So I'll put number 2 here first. We need to take care of the buttons for each square in the board. Now, specifically here, what we want to do is we want to reset the buttons to be ready for usage again. Now, I'm giving long descriptions here because when you take this code on GitHub, I want you to be able to read through this code and truly understand it. Okay? So how are we going to deal with our buttons? Well, we're going to need to pass in data about our buttons from outside of this function into our function. So we're going to need to have our buttons here. Now we have our buttons, what can we do? Well, because we're going to have 9 buttons, okay, 1 button for each square on our board, we can use our for loop again. So we can say for our button in buttons, and simply what we want to do is for each button, let's put this here. So for each button, we want to reset the state of the button to normal and also remove any X's
or O's. Okay. Remember, when we click on those buttons, it's going to allow us to draw X or O on the screen. But of course, when we reset the game, we don't want the X's and O's to be there. We want it to be an empty screen, right? So to do this, we're going to simply just write button. Now, with buttons that we're going to have, you won't see the intelligence for this, but one of the properties that we have with our TK buttons is a method, if you want to call it that, or a function called config. Now, config, again, if you're looking for intelligence and you don't see it, don't worry, just follow along with me. But anyway, with config, we want to provide a few arguments, two to be exact. The first one is that we want to set the text to be an empty string. Now, when we're updating our game state and dealing with our buttons, remember that when the button's index matches the index that has been clicked on, we set the text to the player option. So whether they're an O or an X or a naught or a cross, and then we disable that button so that is no longer clickable. We can't get any action from it. It's set in stone. Okay. But when we reset the game, we don't want the state of these buttons to be disabled, and we also don't want to have a naught or a cross inside of the grids. So down here, what we want to do is have an empty text field. And then the second thing is we want to set the state to be normal. Now, state equaling to normal just means the state is back to its normal state of being available to be clicked on. So the command argument will fire when we click on one of the squares that are empty, of course. Now, once we've done these things, we know that whenever we need to reset the game, we're going to be simply just calling reset game. And we can use this a number of times in our code whenever we need it. Okay. This is the best way to write code when it comes to dealing with resetting these values. Now over here, everywhere we've used reset game, because we have access to the data in our state function for the buttons, the index, the board, the player info, we can also use that information here. So down here, for example, in our reset game, we're also going to need information about the board and the buttons. Also, if we're going to reset the game, we also need the board and the buttons. Okay. So now we've taken care of these parts here. It's looking pretty nice. So now we can reset the game. We can check if there's a winner and we can update the state. Okay. Now soon we're going to do a sanity check. But before that, we want to continue with where we're going with our code. Okay. Now, the confetti displaying is one of the last things that's going to happen. So I won't worry about that now. But we have this C part here in between B and D, which I think should be filled in so that we can have a bit of a flow here. The reason why I'm going for this and not display confetti, because if confetti doesn't get displayed in our game right now, it doesn't really take away much from the game's functionality. But if we don't display the scores though, that will take away a lot of the functionality from our game. So in terms of order of importance, I'm going for C over A. And the reason I'm talking like this is so you can see my thinking when it comes to how we write code. Okay. Now over here for updating the scores, we need to think about this. How many times are we going to update the game scores on our game window? Think about it properly to yourself before I continue with an answer. Well, if you thought about it well, the correct answer could be any amount of times. You know, those of you who really love games might decide that you want to have 100-round battle to the end, from night to the morning. It is up to you. But the point is that a user can have any number of rounds for their game, including just one round. Now, because of this, we're going to have to call this function more than once, or this block of functionality is going to be needed more than once. So we actually need a function for this to update the scores on our game window. Okay. Now, again, if we use the top-down approach, this would involve us writing the name of the function first, and then writing the implementation logic that goes along afterwards. Okay.
Now, in this case, if we're going to do something like this, what could we call it? Well, in my mind, I want you to think about this first and come up with your own answer, and then I'll tell you mine. You can even pause the video here, think about it, and then we'll go along with an answer. All right. So if you've thought about it, I always told you when it comes to naming functions, the best way to name a function is by what its function is for. So in this case, we want to update the scores of our players. So we can say update player scores or score, whichever one. So either scores or score will do. And then we're going to put our brackets over here. Now, of course, this function doesn't exist. Now, the order, the way I'm writing these functions is not going to be the final order, but just for the sake of visibility, in respect to where our update game state is, I'm writing things up here. So over here, we're going to have update underscore player underscore scores. Good. All right. Now to update the scores, what information do we need? This is the first thing we need to think about. Now, all we need really to update the scores of our players is information about the players. Now we get access to player info in our code here. So the same thing would have to be true for our update player score. So we can accept our player info over here. And then we can start writing our code. All right, so what would we do? So in this case, when we want to update the player scores, this is the, let's write this here. This is the display of the player scores as the game is going on. Now, the player scores are going to be controlled by, of course, a few different aspects here. The first part we want to check is we need to get the information about our players, right? Now, when it comes to displaying that, we need to be able to, first of all, display it and then change it. Now, to change it, we're going to need access to the actual text of our scores. Now, where would we get the scores of our text? Okay, that's the question. So we need to access our score text, and then we can do this on second line, change or set the values to the current state of the player's scores. Okay, so this is what we want to do. Now, in a case like this, if we want to work on writing our code in this format, we need to think about how we're going to display this data on the screen. So how are we going to display the data that we're talking about on the screen? And this is where I want to introduce a new part of how we write our code. You see, at the moment, we've been working primarily in our own function blocks. But when we actually execute this code, we're going to need to use something I've shown you in our API lessons. Now, the way we've written our code so far, we've been working with code blocks primarily. So all of our functions have a code block that has our code. And then from there, we're able to, continue writing our code. But if we want to get access to our score text, okay, which is the score text we need in order to set the values, we're going to need to change our implementation a little bit. And this is where I want to introduce you to how we can use our main function. Now, usually in a good Python application, we always have a main function. Now, a main function is going to be the main thing that gets executed when this game.py script is run. Now, like I taught you in our API lesson, if we use our common syntax, which I'll write it down here for you to remember it, which is going to be if, all right, underscore name is equal to underscore main, we need to do something. Now, I'm just going to put a pass for now, but we're going to take this one step further. In Python applications, in good Python applications, we use a naming convention for our main function, which is the main thing that gets executed when we run this file as it is, which is our game file. And that would be our main function. So down here, I'm going to create a function here called main. Okay, put a pass here. Now in this main function, the main things we want to happen in our code would need to be called when we run this function. So for example, initializing our game, getting our game started. Because so far, when you've been writing these functions, you're probably wondering, how do we call all these functions to actually get them to work? Well, this is what the main function is going to do. It's going to be our place where we provide the framework of how we want our game to run from beginning to end. Okay. And because we're running this in this same script file, especially, we want to make sure that things are executed in this main function and controlled from this main function that we're going to pass over here. So I'm actually going to take away pass and just put main here like that. Okay. So in our main function, what kind of things do we need? Well, number one, we're going to need to have a place for our score text. Now, why would I write our score text here and not inside of our update our player scores? Well, the score text is something that we're going to be managing the state of throughout the game, and that value is going to change. Secondly, many of the functions that we have may actually need that score text, not just update player score. So we're going to need to use a different type of syntax to get the job done so we can access score text. Okay. Now, do you remember also, whilst we're having this conversation, that if I was to scroll up just a little bit, for our button here, we need to get access to the root. Now, what is the root? Well, the root is going to be the actual window where all of this functionality is actually going to take place within. And if we don't have a root here, we can't actually do anything from a UI perspective. We're not going to see any of the X's or the O's. We're not going to get the confetti. Nothing's going to happen. Okay, which is not fun. Now, the root, if we were going to store this within one function, the problem is that many functions are going to need access to the root at some point. Okay. Secondly, and also importantly as well, is that this root that we have, which is our window, is something that we want to initialize really before any of the other logic, because we want that window to appear on the screen and the code logic to come immediately after. So we need to find somewhere that is a global place to store it. Now, I know I am talking a lot, but this is both teaching and practical. So I want to make sure that you're with me 100% and you're also learning. Okay. So hang in there. We'll get back to writing code. Okay. So with our root here, if I was to go down to this area here, which is our function for running our code, we need to have a way where we can call the root to be executed in our main function, but at the same time, we can pass the root data that we need over to other functions that may need it. Now, what functions may or may not need it would be determined by the way we're going to write our code logic. Okay, so let me show you what I mean. Let's talk about this. Well, the first thing that we want to do is we need to get our root and we also need to get our score text. So let's put this here, number 2, our root. Now with the score text, how do we actually get score text to show up? Now, if we want to get score text, that's going to be something that exists within our window. So we actually need a TK package for that. So right here, let's call this our game score text. And we're going to call this TK. TK. Now with TK, we have access to this class here called string var or string variable. Now take a look at what this does. Now what this does is that it allows us to present a string variable and construct one within our window that we can gain access to. Now for the moment, we only just need this string variable as it is. We can leave it empty for now. But what we're going to do is that we're going to take this score text and use this in our code up here So let's go up a little bit further. And we're going to access the score text. So one more time, this game score text that we have here is going to be our entry point on our window to actually set the scores of our players. So right here, I'm going to go over here and let's say game score text. Now with our game score text, what are we going to do now? Now our game score text really is pretty straightforward. And the reason why it's straightforward is because really it's just one line of code that we're going to write. Okay, just one line of code that we're going to write. Now the code we're going to write would be to use a property called set because it has a get and set property. And as you can see here, it says set the value or set the variable to a value. So what's the value going to be? Now we have the player information. So all we're going to do now, usually with games, kind of like with football, for example, I'll show you what I mean. We might have something like 1-0, Arsenal versus Man United, something like that. Well, I'm from the UK. I like football, so I'm thinking in football terms. But any sort of sport, we usually have one player score or one team score on the left, we have a dash, and then we have the other team on the right. So we can copy the same kind of syntax. What we're going to do here is say an F string, then we'll say player info. And with our player info, we'll say that we want the person that is a naught, and then we want, I'll drop this here, their name. Okay. Now, because we know from a programmatic point of view that we're going to have our notes first, we can go ahead and continue with our expression in our string and just say something like player, let's say player note. And then we could just provide the information about their score. Now, it's the same process. I think you've got the point. So player info, okay, we know that we want the person that is a naught. And then we'll say that this player naught, this time we want access to their score. Okay, very simple stuff. Now with this expression, what it's going to do is going to give us the name of the player, which is player naught. And then it's going to give us the player score. And then we just want to match the same thing on the other side. So on the other side here, I know it's a little bit hefty here. We're going to go on the other side and say player info. Now what I'm going to do is, of course, put this inside of curly braces. Now I'm going slowly so that you can follow along with me. I know that most tutorials, sometimes people just go so fast you don't even know what's going on. So I'm slowing it down a bit, even if it takes a few more seconds on our video. And then we'll drop off the name here. All right. And we'll say that this is going to be right here, player X. And then the last part would be player info, same thing, have an X, and then we just get the score. Now, trust me, it seems pretty complicated, but it's not at all. It's fine as it is to leave it like that. And when we do a sanity check, we'll be able to adjust it and see if we have any issues, with the way we've written it. All right. So we have the player name, the fact that they're a naught, and then over here their score. And we're saying this is that person's score versus the other person's name, which is player X, with their score. Okay, good. And really, that takes care of updating the player's score. That's all we need to do. Now, the same way we're going to need the player scores through their player info, up here, we also need the player info. Okay, good. Now, what about the root? Now, the root here, in our previous code that we had, that I believe I've commented out at the top, right here, if we wanted to get a game window to show up, the first thing we needed to do was to call our TK function here, which really is actually a class, but it looks like a function. Was to call our TK class here, right? So this is going to allow us to create a game window or a window in general, but in the context of our game, a game window. The second thing we needed to do was to have a game window label. So we pass the text, pass the foreground, we pass the background. Okay. And then we packed our label to add to the window, and then we run our main loop so that our window continually stays open until we decide to close it. So this time in our main function, because we want this to happen every single time this script is executed. So in order for that to happen, we need to write our code. So down here, we need to write out our root. So with our root here, it's very simple. We'll just say our root. We'll call this tk dot tk. And now we have a root here. Now up here in our code, you see that root now is taken care of and it knows that is of type tk. And then we have update state here, which a better name that we chose was update game state. Okay, looking good. So with our root here, what else do we need to do? Now, with our root, once we have a window, we can start working on the next part, which would be to set up our dialogues. We'll take care of dialogues in later lessons. But what the dialogues are essentially going to do is that when the game starts, again, we're creating the architecture of what exactly happens as soon as this game starts running. So as soon as we run our code and press the play button here, what exactly is going to happen? Well, we want to, of course, set our game score text. Yes, we want to do that. We also want to, of course, have a root so that we can get a window. But after we get the root, before we can actually get to the point of getting the game started, we do need to ask each user, for example, number one, what is their name? So what are their names? Let's make this grammatically correct. So what are their names? Let's change that. Now, apart from what are their names, what else do we need to ask? Now, this is not necessarily in order of what is going to happen per se, but it's just suggestions of what we need to have. We also need to check how many rounds of the game do you want to play? If you remember in the demonstration lesson, the number of rounds that we wanted to play of the game was asked, I think, even before we went for our names. Yeah, even before we went for our names or asking questions about the names, we asked how many rounds of the game we wanted to play. Okay. So these are the dialogues that we need to get set up. Now, to set up these dialogues are pretty straightforward. I don't want to make this section too long, so I want to make sure that you're with me when it comes to dealing with our state so that you can understand exactly how we're going to run our code. Now, when we run our code right now, so take a look, you see that we have errors all over the place, okay? It says that it's too early to create a variable because no default root window. Now, this is for some reasons that I'm going to show you in our next lesson. But just before you go, I just want to make sure that you're with me in the recap. So what we've done in this lesson is made sure that we've taken care of showing who's won the round using message box. We're updating the scores. We're resetting the board with our reset board functionality now. We're also displaying a message if it's a draw and then resetting the board. And of course, over here, we're setting our game scores. We've also set up our main function now, which of course, for now, I've set it to a pass. And because I haven't put the code in here, of course, we're going to get an error. So don't need to worry about it. But in our next lesson, we're going to go over to working on how we can actually get the logic to come together with the UI. So I'll see you guys in the next lesson. All right, my people, welcome back. So in this lesson, I want us to take a focus on how we can build the architecture of our game control flow. So as I said in our previous lesson, when we were working on updating our state a bit more, I told you that in our main function here, this is going to be where we decide on what I call the game scaffolding. If you want to think about this in a programmatic way, this is the game's control flow. So what happens in a procedural way? So for example, the root variable, which contains our TK window, is going to open, and then maybe we might get a dialog box to show up, and then from that dialog box, we move on to the gameplay and etc. Our main function is designed to do just that. So anytime you see a main function, maybe somewhere on GitHub and you're looking at the code structure, it's for this one reason. We're trying to build out the application architecture in terms of its control flow. So that's what I want to focus on. Now, in our previous lesson, because we're dealing with updating state, I've had to introduce some of these values. Now, the way these values are going to be structured would be based on the control flow. Okay, the control flow would be based on how we want the game to work. So let's discuss that. Now, I think the first thing we need to do is move the root right up to the top and put this inside of our actual main function. Okay, we want our root to show up. And then also we're going to get our game score text. So I'm going to put the root here and I put the score text over here. Let's talk about the control flow of what we want to happen. Now you can come up with your own ideas, but generally speaking, of course, because we're dealing with an application, the first thing we want to happen is we want the window of the game screen to be initialized, okay? Now, the reason why we want that to be initialized first is because no matter how much game logic we write, we want it to be in sync with our UI components. So things like when the X appears on the screen and etc. So if we want to have the code logic where we have the UI components along with our code logic working together hand in hand, the first thing we need is going to be the canvas for all of that to appear, which is going to be our game screen. Now, the next thing that we want to have is what I call prompts. What are prompts? So prompts are simply messages that an application gives you to lead you towards a certain control flow or certain control flow outcomes. All right. So what could a prompt be? Now, a prompt can be something like a dialog box to ask let's put this here, what your name is, as an example, okay? So it's just an example here. Now, I actually wrote down some dialogue information in the last lesson. Now, I know I put 3, 1, 2, so you probably thought, what are you talking about? What I mean by that is this is 3, and this is A, and this is B, but I just put 1 and 2. But you get the point, I hope, of what I was trying to say. Now, in our game, what do we want to happen? Well, when the game loads, according to the way the game structure was of the finished version that I showed you in the first ever lesson we had, the idea was that when the game starts, we want to ask the user how many rounds of the game they want to play, and then what are their names. Now, I think it's good to go around that route just to make sure that we can have logical structure in our code. Now, we can change things around once it's done. And again, we're going to run our sanity checks soon, but we can theorize the way we want to go and then start executing. So for now, what we're going to say is that the A part of what we're going to do is we're going to ask how many rounds we want to have. Now, the thing is, if we're going to ask how many rounds we want to have, what's going to happen? Well, we're going to need to have some sort of input dialog box that receives user inputs. Now, for something to receive a user input, which means we're going to have user data, okay, we need a dialog box. Now we're dealing with the TK window, so we're not going to be using the input function, just in case you're thinking that, because that's only going to receive data to show up on our terminal, but we want it to show up in our window. So we have a different interface that we're dealing with here, okay? One is the screen, which is our root or the window. The other interface would be the terminal. So we can't use the input function here. What we need to use is a very simple module, but very useful. And if I go up here, we're going to import it in here, and it's called our simple dialog. Now, the name tells you everything you need to know. It's simply a dialog box that we can do very simple but powerful and effective functionalities with. So I want to go down and let's think about this. If we want to ask how many rounds a user wants to have, we can call our simple dialog box. Now with simple dialog box, we have a few options as to what we want to capture as user data. Now the user needs to provide us a number. So we'd want to use an integer. Now we wouldn't use a float here because a float can be a decimal number. And we're dealing with things that have a discrete value. So not a continuous, but a discrete value. Now a discrete value would mean an integer because it's a whole number. So 1, 2, 3, 4. So we'll say ask integer. Now here it has the title, it has the prompt, and then it has other keyword arguments here that we can make use of. Now it actually gives us some information here that we can make use of as well as to what the arguments do. Now to keep it very simple here, what we want to do is have a title for this dialog window. So we can say our tic-tac-toe game routes. The next thing would be the prompt, which will be the little message that shows up inside of the window as to what the user should need to do in this position when this dialog box shows up, right? And then we have our prompt here as the second argument. Now this second argument here is going to be the little message that appears underneath the title that prompts the user to follow through with the control flow that we're trying to lead them to, which is for them to give us a value that we can store and use within our game. So in our case, we can say, how many game rounds would you like to have? Now, usually when it comes to prompt, I always say that you don't want to treat users like they're not intelligent or not smart or anything, but you want to make sure that you can mitigate any sort of mistakes. So it's good here to leave what I call a mini example so they can understand what's going on. So we can say, for example, e.g., 5 for best of 5 rounds. Okay. By giving that example here, now the user has an idea that, oh, okay, so we want to know about these 5 rounds. Not bad at all, right? So this is the kind of structure that we want to have in our code. Now, the thing that we also want to take care of over here would be the third argument. Now, the next arguments after title and prompt are keyword arguments, which is denoted by this double star. Now, you know this from our functions section of this course, that whenever you see a double star, it means we have a keyword argument. Now, there are a few keyword arguments that we can get access to. So we have, for example, minimum value, we have max value, we have initial value. Okay, we have also this parent here, which we're not using at the moment. We don't need that. Now, we don't need an initial value here, okay? But if you choose to do one, it could work. Now, what does initial value do? Well, what it entails. So when we prompt our user, what if the user doesn't pass anything in? Well, we could decide that we want to have logic that if the user doesn't pass anything in, we want the initial value to be the number of rounds of the game. But then we could also argue that for control flow reasons and just user experience reasons, what if the user just wants to play one game and they thought by not putting anything, it equals to 1? You never know what people might think, okay? The better way around this
is to use the minimum value. So if the user tries to put in a number that is less than the minimum value, which would be 1, okay, we can say, hey, you're not supposed to do that. It has to be at least, 1 round of a game, because contextually and just logically it makes sense. So we can say over here, minimum value equals to 1, and that's it. Now you're probably wondering, what about all of these other keyword arguments? What happens to them? Well, if we don't pass in a value, they get evaluated to none, which just means an empty was a representation of emptiness. It's an actual type, but it represents nothing being there. Okay. And that's essentially it. So once we use our simple dialogue here and we ask for an integer, it will give us a window that has a title, the prompt message, and then a minimum value. The dialog box itself will still be looking for the value from the user, but the minimum value that will be accepted from that user would be 1. So this is great validation logic. Now, I always say, never trust a user. It's a very common saying we say in computer programming that you should never trust a user when you're building an application, because they can definitely give you bogus values. Happens all the time. Okay? So the other part of this is when the user actually returns this data to us, how do we know what they've given to us as a value? Now, this expression, simple dialog.ask integer, actually receives the number, okay? So it actually returns the number as an integer. Since it has a return type, it will be safe to save this in a variable so that we can make use of it through our application. So let's just call this number of game rounds, okay? Now with this number of game rounds, the first thing we want to take care of is the fact that what if the user gives us a bogus value? Bogus value. So if the user gives us a random value, for example, number 1, not an integer, okay? Number 2, what if they give us a value that is less than 1, which is less than our minimum value? How do we handle that? Now, in our code logic, as I said, everything is procedural when it comes to writing code. So we need to explicitly say what happens if the user passes in a random number. Otherwise, what would happen if they pass in a number that's not a string? The internal functionality for simple dialog args integer will kick in and maybe just close the window and give us a runtime error. But we want to have what I call a user experience, a user-facing experience, which means we want the user to understand that something's wrong on their part, or maybe something's wrong with our part. So we actually need to make sure we write the code for this. How do we do this? Well, it's a very simple statement. Now, the third thing that we want to take care of before I write this if statement actually would be the third, but not the least situation to happen is if the user provides no response. So what if the user just presses OK and doesn't provide us a response? What do we do? So the easiest way to encapsulate all of this is to say if not, and then say number of game rounds. Now with this approach here, why am I going for it? Well, as I said, we have not an integer, which simple dialog ask integer could take care of. And it could also take care of the fact that something is less than the minimum value. It has error handling in logic. So really, we can leverage this module that we're using, simple dialog, to take care of those first two issues. But the third issue here, we need to take care of that, which is if there is no response. So if there's no response, which means there's no value in here, what do we do? Well, the best thing we can do would be to close our window, because if we're going to be using the window and we don't have any game rounds, then there's no point of the game. Okay.
So here we want to close the game window. Now to close the game window, we're going to call our root and simply call a very interesting named function called destroy. Now, the sound of it sounds very funny. I don't know, it just makes me laugh. But destroy, as it says here, destroys all of the widgets and closes the application. Okay, that's all it does. But destroy seems a little bit harsh, but that's the reality of what's going on. Okay, now, once we've asked for the number of rounds, what's the next thing? So if you want to, you can put a little bit of stars here. I usually do this when I want to make a line between what I'm saying and a new topic. So here we're going to check now for the player's information. So far, you've been seeing me passing player info, player info. So if we go across to all of our functions here, you see we have player info over here, then we have player info over here. And I'm sure you've been wondering, where are we going to get this player information from? Well, of course, we're going to get it from our players. Now, how do we get it from our players? Using the same method of getting access to our simple dialogue module here, and then using one of our ask functions in accordance to what we're looking for. Now, in our case, what do we want to do? We need to get information about the player. Now, the thing is, if you want to get information about the player, what would be an example of that? So we can say, for example, let's say we want to get players info, okay? So we call it players info, right? Now, the first problem here is that with players info, we can only get information about one person at one time. That's our first issue, okay? The other thing is that even if we were to write the same code twice, we're repeating ourselves. So we're breaking the dry rule. So anytime we see this situation, what do we do? Yep, you answered my question. We need to create a function for this. So instead of just saying, okay, players info, let's say player info, or let's say player one info, and then we're going to do the same thing and say player two info, like this. As much as it looks okay, in terms of using the best programmatic and Pythonic ways of writing code, we want to create a function for this. So up here, we want to have a more generic function. We can just call this get player info. Very simple name. I'll put a pass here, and instead what we're going to do is going to get player info here, and then get player info over here. Now, the only thing is, how do we differentiate between these players? We're going to need to have some sort of keyword, which would be our parameter, that we can use to differentiate between player one and player two, right? So if we want to do something like this, the first thing would be to write the logic and then make sure that the execution works. So let's do that. So up here, what do we need? I want you to pause the video and just think about it for a moment. What do you think you're going to need to get the player info? Now, it doesn't have to be necessarily the exact module or function, but just what do you think you're going to need? Give me like 3 steps. This is good practice for you. Pause the video where you are, and then I'm going to come back and we'll go through it. All right, guys. So I hope you had a good think about it. So what do we need to do? So if we're going to get the player info, the first thing that you're going to need to do is we need to trigger a prompt. So if we're going to trigger a prompt, we already know that we're going to use the same package we just used, which is going to be simple dialogue. Now, this time, what we're going to ask for? Well, if we're dealing with, for example, the player's name, we need a string, okay? So here, what would we call the dialogue title? Now, the dialogue title here is important because we have 2 different players, and we want to use one function
for two different players. If we're going to use one function for two different players, how do we get information about both of them and display them as though we got unique players from maybe two unique functions? What do you think we're going to have to do? Now, in our case, my best guess that what we want to do is we're going to say simple dialog arc structure, the title, okay, here. And I want you to think about this. I want you to think about this as I'm writing it, is that we're going to use an F string and we're going to say player. But in here, we're going to need to get access to the player number. Now, we know we have two players, player one and player two. So the best thing that we can do here is have another parameter here, which we can say is our player number. All right. So then with our player, we can say something like player number. This way, when we do call this function for get player info twice, we can say that, for example, player one would be player number one, and player two would be player number two, right? And then when we trigger our prompt, it's still going to give us the opportunity to ask each individual player without any funny business going on in our code. Okay. So once we've done that with our F string, we can continue and add more. So we'll say that this is the player number. The second thing we want to do is provide the prompt. Now we need to prompt each player individually. We can't have a generic message. So again, we want to use an F string this time. And we'll say that, for example, let's say, please enter. Okay, so please enter player name. Now, if we just say please enter player name and we don't address which player we're talking to, it might be a bit confusing for them. Now, I know that, you can be intuitive with it and figure out that, okay, it's talking about me. But just in case, in between our please enter your player name, we'll say over here, player number again, and say player here. And then we can just have like a colon over here. So this way, each player, so player number one knows that it's time for you to enter your name. Player number two knows that it's time for you also to enter your name. Okay. Now, once you've done that, we know that the job is not completely done because we need to make sure of the same thing I told you before. Now, what's the same thing I told you before? Well, when we do a dialogue and we ask the user for data, we can't assume that they're going to give us the correct data. As you can see in our previous code down here, we had to destroy the root because a user didn't even give us an input, right? In this case, we want to provide something similar so that the user experience is very responsive, as we would say. So we need an if statement, and somehow we need to access the name of the player. So what do? Well, this is going to return a string. So we can save this as a variable, and we'll just call this player's name. Or let's just call it player name. It's a bit better. Now, what do we want to do? Well, in this case, it's going to be the exact same thing. So you say if not player name. So if the player doesn't give their name, because again, with these functions here, arc string, arc integer, they do have some error handling logic that will take care of stuff like someone putting in something that's not correct or the wrong character, if there is something that can be wrong in that sense. Now, when dealing with a string, we have a little bit more of a wide range of variety, but just in case there's something we can't add in, then, we can write it. So maybe we might want to stop someone from putting obscene language. So we can say, I won't put obscene language on the screen, but let's say that we had a game that's going to be for young children. We might want to make sure that nobody gives a name as a player, which is something that is inappropriate. We can also add that functionality in. Okay, now I won't do that again, but we'll just say that can be added. Okay.
All right. So if the person doesn't give us a name and they try to move on to the next page or to the next part of our game's control flow, we need to stop them right there. And we can stop them right there by giving them a message. So we'll use message box again. Now, this time, when we're going to use message box, we're not going to use it as we used it before so that we can show some information. We actually want to warn our users. Now, we have lots of different functions we can get access to. You see, we have show info, we have show error, and we have show warning. Now, the best thing to do is to show a warning and give the user a chance here. Maybe they made a mistake. Okay. So we throw a warning and just tell them that, hey, look, you need to provide us a name. So we'll say show warning. Now with show warning over here, we'll provide a title and a message so that we can show a warning message. So here, let's just call this, let's just call this a no input error. Okay. So when the user doesn't put in an input, we'll call it a no input error. And then we need to tell them some information. So the message will be whoever makes the mistake and tell them that, hey, player, let's not leave some space, otherwise we'll get space there, and say player number, okay, you must enter a name, exclamation mark, just to add a little bit more oomph to it. You know what I mean? Okay. Now, once we're done with this, we want to go back down and also make sure that we take care of the last part, which is to actually return the information about the player. Now, in the case where the player gives us this boo-boo here, where they don't enter their value that they're supposed to, which will be their name, we want to return a none object because we don't actually want to return any information out of this function because that would be bad. We don't want to return bogus value. So we block off any chance of returning bad data or bad input data by returning a none. But in the case where the dialog was asked and we have a success, the user has given us the right name. Down here, what do we do? Well, what we can do is say return. Now, what do we want to return here? Now, so far, you've probably been wondering, how come you keep using this square bracket notation here? So player info, square, naught, square, name. Now, there are always two ways that you can access an object. You've seen me use the dot notation sometimes, so something dot set, and then we've also used square bracket, which means the same thing. Now, over here in our return statement, we're finally going to actually return one of these objects that I've been talking about. Now, these objects here in Python would be a collection type called a dictionary. And we can provide the key value pair data that we need for things like the name and also the score. So here we're going to pass a name here and then set it to a default value. Now the name here is going to be the name that gets given to us by our user. So we'll just call it player name. The second one is going to be the score. Now this one with our score should be defaulted at 0, okay? It shouldn't be any other value because that would ruin the entire structure of our control flow. So we need to make sure that this value is 0, always 0, okay? I don't think you need a variable for this. Hard coding this to 0 is absolutely fine, okay? I'll write this code up here as well. And I'll write a note up here as well. So over here, what we're saying is that we're going to return our user data dictionary. Okay, so this is how we're going to have, for example, player info. Now, when I say player info, let's write this properly, player info, and then I say name. I hope you can understand a bit better that what that means is that player info and then the name of the player.
If we wanted to get access to the score, we'll say player info score and etc. All right. So now we have the information for both of these players. We can continue with our architecture here. So we've got player information. I add a few more lines here. And then you can see here that now we can get our players information when our window opens. So our window opens, we have our string here for the game score text. Then we're going to move on to asking how many rounds. Then we're going to go for the player information. So say players information over here. I'll leave a little note. And this I'll put as our number of rounds information. Okay, good. Now we have a few warnings here. One of them is our game score text. Now the game score text, where's our game score text is over here. So you're probably wondering, how come our game score text doesn't show up here? Now, if you've been following our lessons on functions, then you know that when we have a variable that is scoped to a function, it's only available for usage or accessing within that variable. Now, we need to mitigate this in this case because main is going to be the architecture of our game, but we do need to get access to this score text throughout our game so that we can update our state, because our state function here is going to be continuously keeping track of the state of our program application until the game is finished. So how do we do something like this when we can't access our value on the outside, and we also need to make sure that this game score is in our main? We want it to always happen. This is where I want to introduce you to the keyword, and I'm going to leave space at the top here, called global. Now, what global does is very powerful, okay? Global allows us in Python to make a local variable global to the entire application file. So in this case, if we make a variable global, we can still use it in our main function, but we can also access it in our state function, okay? And also in our update player scores function, which is another place we need it. So how do we make use of such a wonderful tool? I'll show you. So we scroll down here. Okay, so what we want to do is figure out what we need to make global. Now, the first thing we actually need to make global is going to be the root. Okay, we need to access this root not just in our function, because going back over here to our update state and also to our create game button, we still don't have access to the root. Now, tk.button, which is how we create our buttons that have the event listener, can only work if it knows where it's going to be placed, which is going to be in our root. We don't have access to our root over here either, but we still need root to stay in main, because if it doesn't stay in main, then we're breaking apart a major part of our game architecture, okay? So what do? Well, we need to call global and then apply the variable name root there so that we can use it globally. But we're not done. We also need to take care of what I just said, which is going to be dealing with our game score text. So we need our game score text. Okay. Now, what else do we need? There is one more thing that we need, which I've defined over here. And the third thing we need is we also need to pass the data about the number of game rounds that are going to be asked for. Now, this expression has to stay in our main function because, again, it's part of the outline of the architecture and the control flow of how the game starts all the way until how it finishes. And this is the first thing that we actually ask our user even before anything else that could be asked. So over here, we also need to export, if you want to put it this way, the number of game rounds. Now, it's pretty simple what you need to do. All we've got to do here is we're going to call global, and we're going to say that the root is global, all right? We're also going to say that our game score text is global,
And we also want to make sure that our number of game rounds is global. Now take a look at what happens as soon as I do this. You see that first we have no more errors in our code. If we scroll up, you see that now root says that it is of type TK, which is brilliant. So now our game buttons know what root that it needs to be attached to. Good. When we go down here, you see that now game score text, you can see is of type string variable. And now we can set the string variable, which is going to allow us to update the scores, whoever's winning in the game. So 1-0, 2-0, 2-1, etc. We have that functionality now. And then with our number of rounds over here, we can use this number of rounds when it comes to deciding who the final winner is going to be in our game. So when we update the game state, we need to know who the final winner is going to be, which is this part over here. And we want to make a function called check overall win so that we can do something like that. All right. So coming back, you need to take care of a few more things before we can call it quits here. Now we've taken care of our global here, which is our root. We've taken care of our game score text and the root here and the number of rounds. But when it comes to this player information here, we're still lacking a little bit. So what we're going to do is in the next lesson, we're going to focus a little bit more on working with the player information because we need to make sure that we have the correct player information so that our UI components and our code logic components together work in symphony. So I'll see you guys in the next lesson. All right, guys, welcome back. So let's take a focus on how we can utilize the information we have access to, especially our player information. So as you saw in our previous lesson, this global keyword has given us quite a few new possibilities that we didn't have before. So if we go back into our code, when it comes to our create game button function, now we have access to the root. Now we have access to the root, which is the window, in our case, the game window, where these buttons can be lodged and made use of. Without using the global keyword, we didn't have a way to access the root without breaking our game architecture in our main function. So we solved two problems in one simple step, which is great. The next part of what we did was, now that we have this global functionality available to us, in our update game state, it's going to be very easy for us to create the logic to check who the overall winner is, because now we actually have the number of rounds for the game, which is absolutely fantastic. Also, the game score text that we want to set for keeping track of who's winning or who's losing is now made available to us through this same global keyword. Now, with all of this access to data outside of our main function, we can continue building our UI components and our game logic that works underneath our UI components, along with building the architecture of our game using our main function. So, continuing on, we need to take care of the player information that we get. Now, the player information that we get, which is going to come from our function where we can pass in the value here, 1 or 2, denoting player 1 or player 2. We can use this structure that we have here to evaluate some of the simple things that could go wrong when running our code. Remember, one of the most important things about writing code logic is making sure that you account for errors and figure out how you're going to handle them in the most efficient ways possible. Okay? Now, in this case, what do we want to do? Well, the simple thing to do here is, for example, what happens if we don't have any information about the player? Well, we want to close the window. We don't want to continue the game because that will be a problem. So we can say if not player 1 info, and we can say we want to call root and then destroy. Okay, that will get rid of the window. The same thing would be true for player 2 information, right? So if not player 2, we want to say root, and then we're going to destroy. Good. Now, when we write code like this, okay, and we want to use a root to destroy here, running code in our main function can get a bit tricky if you don't know how functions work. Now, remember, when we work with a function here, we always use the return keyword when we want to end the role of a function, either at the end of the function when all of the logic has been written, or intermittently between different parts of our function if we want to end the execution of, let's say, this main function, which is what we're using early. Now, take a look at what we have here in our code. When we're writing player info equals to this function here, if we don't get the info of any of these players, yes, we want to destroy the root, and it will, of course, end our function. But just in case, it's also good for us to say that we want to use the return keyword. The return keyword used over here would ensure that we end this function, we cut it short. There's no more implementation logic that takes place. So for example, imagine if we find out that the number of rounds has not been given to us and we want to end our root or close our root. We also want to stop the underlying code logic at the same time. We also want to stop the underlying code logic at the same time so that we ensure that there's no more reading of our code, for example, past line 169. How do we do that? Well, we're going to call return here for each of these expressions. That way, we're going to kill our code, if you want to put it this way, from executing past a certain point. So when we destroy the root, we don't want to destroy the root and then Python starts to read other parts of our code. We want it to stop reading our code as well and completely end it, because logically speaking, if there are no game rounds, then there isn't any game. You with me? So we want to use the return keyword here, and it's an important, small but important feature to add when writing code. Okay? All right. So going forward now, if we look at the things that we need our game to do, when it comes to our buttons here, I believe we've taken care of it. When it comes to our state here, I think we've answered most of the questions or hypothesis that we have. The things we do need to take care of would be to display the confetti. But now, and more importantly, in terms of order of importance, again, is that we can actually keep logic here for knowing who has won the entire game. So, as I said, I propose a function to be called check overall win. And because of the global keyword, we can actually get access to the number of rounds when the user inputs that. And we can take that value and be keeping track of it so that we can also use it to successfully keep track of the state of our game. Now, with this check overall win here, the amount of lines of code we'll write will definitely be more than one line. So as a second rule when dealing with functions, I strongly recommend that it's better to write a function than trying to write all of the code logic underneath here. It's easier to keep track of and it just creates cleaner code. So over here, let's implement this function now. So this function here is going to be called check overall win. Now I want you to think about this with me. If you want to check, in this case, who the overall winner is, what things do we need? Well, the number one thing we're going to need is going to be player information. The second thing we're going to need to work that out is going to be the number of rounds, or we'll say the max number of rounds decided at the start of the game. Okay. Now, with that being said, how are we going to do that? Well, we need to get that data
passed into our function. So we need to create parameters so that we can accept arguments later on. So for check overall win, we need the player info. So we'll call it player info. And we also need the number of rounds. So we can call this number of rounds. So we can say num of rounds. I think that makes it simple and easy to read. But if you have a better description, you can go for it. So with these number of rounds, what are we dealing with? Well, in here, we need to create the code logic now to calculate whether player naught or player cross, player one, player two, whoever it is the overall winner. Now, to be the overall winner means that you've won more rounds in terms of your score than another player, okay? Or you've completely thrashed them and it's been like, for example, a 5-0 killing. So in those two instances, what do? Well, either instance we have, we're going to need to have conditional logic because it's conditional. It's not something that is going to happen every single time. It may happen, so we need to consider all of the different outcomes. So I'm going to put a little A block here, and this A block will say that this is going to be if one player has more points than another player and the number of rounds are complete. All right, so what's the other part? Okay, if one player has the same amount of points as the number of rounds and the other player has none. Okay, so like they get beat by a thrashing. So like a 5-0 or a 10-0, etc. Okay, so in these instances over here, once we theorize this, it's very easy to write the if statement to go along with this. Now you probably might think, oh, this is boring. Why do you always write everything you are about to code? The reason I do this is because it's good practice, not only for understanding, but if something was to go wrong or your code didn't play out like the way you wanted it to play out, you can always go back and work on exactly why and how it didn't work. So me talking a lot is for your own benefit. I want to make sure that you're writing the right code. Okay. So what do? Well, it's an if statement that's going to say, now we're dealing with a situation where we need to check our player info. And based on the player info, what we're looking for, well, we want to look for, we're starting off with our notes and we want to look at their score. So this would be the expression that we'll go for. Now, in this kind of condition, which is if one player has more points than another, or they've got the number of rounds are equal to or greater than. So we can say, for example, number of rounds, which is the first condition for the naught, or if the player is a cross and their score is greater than or equal to the number of rounds. Very simple. Now, how do we know who the overall winner is? So under this condition here, what would the overall winner be? Well, in this case, what we're checking for this first line, just to make sure you're clear with that, is we're checking to see if the number of rounds are essentially done. So greater than or equal to, because you're probably thinking, but if there's 5 rounds, how can a player have a score of 6? That's not exactly what I mean here. What I mean here is that we're checking to see that either one of these players has gone to the point where they've reached the same amount as the number of rounds. That means that the game is done. That's the first thing we're clarifying. So under those conditions that the game is complete or we reach the maximum number of rounds, we want to check now for the winner. Okay. So we're going to say over here that the player who wins. Now, player who wins, I think, is a bit of a strange name. Let's just call this the overall game winner. This makes a bit more sense. Okay, don't you agree? Now we can use a ternary operator this. Now we can use a ternary operator the same way to check for the overall game winner. So how would we know what the overall game winner is? So we can say, I'm going to do it the reverse way. So we'll say that if the player info, which is going to be first of all R naught, and he has a score, as I said over here. Now what we're checking? We're checking if the naught, let's say this is player one, has a greater score than player two, which would be the cross. So if player one has a greater score than player two, then what do we need to do? Well, we need to say that this player has won. So who's going to be the winner? Remember, in ternary operators, it goes forwards to go backwards to go forwards. So remember, in ternary operators, we go forwards to go backwards to go forwards. So if our naught has a score greater than our player who is a cross, then that means that the winner is the naught. If not, so else, it would be cross. So that means under the conditions where either player naught or player X has reached the same score as the number of rounds prescribed, then in that condition, whoever has the greater score is the winner. Does that make sense? Now, for us to be able to celebrate the player, we're also going to need to get the player's name. So here, we're determining which player won by their symbol. And then over here, we need to get the player's name so that we can use it for the celebration. So to get the player's name, how do we do that? So we'll say overall game winner's name. How do we get the name? Well, we'll just say player info. Now, whenever we pass in our X or our O here, we're passing that based on the fact of the object structure. Now, this variable over here returns an O or an X, but under the conditions that, in this case, the winner is determined by who has the highest score. In this case, instead of passing in an O and X, which will be hard-coded and of course biased because one person will always be the winner, we can pass in overall game winner in here. And the logic here will determine whether it's going to be the naught or the cross. And then from that, we can just extract the name of the player. Okay? So extract what's already written there, so I don't need to do it again. Now, what do we do? Well, the best thing to do would be to provide some sort of user experience now. So this is where our UI logic comes in. And the UI logic, so let's just call this UI logic so that you see where UI logic comes in. Now, UI logic always comes in when we use things like message box, okay, simple dialogue. This is where our UI logic comes in and it meets our code logic, which is the parts that lay underneath. So the engine of our game, if you want to put it that way. So the engine driving the car of our game. So we can get a message box. And this message box, we want to show some information. The information we want to show is that they're the winner. So we can say tic-tac-toe. If you want to make it a bit more fun, you can call it tic-tac-toe winner window. I'll just call it tic-tac-toe for now. And what do we want to say here? Well, we're going to need an F string because we need to provide the name. So we can say congratulations. And then we need the player's name. So we can say congratulations, overall game winner name. You have won the game. Okay.
Good. Very simple, but very effective as our UI logic. Now, once this happens here, we want to also make sure that this message stays on the screen. And then after that, our game closes. Because once the game has been won, why do we need to have the window open? Now, you could argue that maybe we might want to restart the game and start a new game. We could maybe prompt the user saying, do you want to start again? And then we could refresh our code. We can do quite a few different things. But to keep it very simple, we want to end the game window when we are finished. So in here, we don't want to call root destroy. We don't want to just abruptly destroy. We want to call root quit. Now, quit is a little bit different, okay? But we can see the difference a little bit more when we actually run our code. So I'll leave it for now and I'll readdress this later on. So now we know that we can check who the overall winner is in our game. And this opens up the door for us to work on things that are to do with our celebratory side, which is more of our UI side. Now, if we didn't display any confetti or play any sound, the game would still work. But these additional features, which is why I've pushed them to the latter parts of our lesson here, is because they don't necessarily, again, stop the game from working, but they do add a user experience, which is also important when building applications. So now we've answered our B, C, D, and E. So we've got our check overall game winner now. So we can say that we want to check overall win. Now in here, we just pass in the player info. So we use player info. Then in here, we're just going to say our number of rounds. Now, when it comes to the number of rounds here, this is the part that gets interesting. Over here, you see it has number of rounds with an equal sign. Now, if we use number of rounds with an equal sign as it is, that means we're trying to pass in a keyword argument. If we're trying to pass in a keyword argument here, it means that we have some sort of data that we're trying to pass in, right? But if we're going to use this to update the state, how do we know what values to pass in? This is the part that's important for you to understand the difference. Here, we're not going to actually pass in the same name as number of rounds. We're actually going to use our global keyword, and we want to get the number of game rounds. We can pass in this data straight away because the number of game rounds, we don't want to pass it into our update game state because we don't want to actually update the number of game rounds in our game state. It's set in stone from the beginning and is only going to change when we start a new game. So it doesn't go up here, but we can pass it here. And by doing so, we have our structure here that we can work with. So if the number of game rounds is 10 and we have the player info, then we can get it cracking with our game. So all we have left now is we need to display the confetti. We need to get our soundtrack, okay? We also need to change a little bit of our implementation at the top of our code because we need to add one more feature from Pygame in order for our code to work the way we need it to. Now, when you look across our code here, I know we've done a lot and it's probably been a long journey. So if you feel like you need to take a break right now, I totally understand. Okay, but we're almost there. Our code so far is looking good, but we still want to just make sure that everything is absolutely perfect. Okay. Now, when you're writing code like this in your own time, I want you to always think through the processes of how I've written the code and not just what I've got. Don't just copy and paste the code and then just, you know, start trying to write it yourself. It makes more sense if you spend a little bit more time and be conscious of what you're doing. Now, again, if you want to take a break here, you can pause the section of our course that we're on right now. And then in the next video, we're going to continue with building our application. I'll see you there.
All right, people, welcome back. So in this lesson, I wanted to take a focus on continuing with building our functionality for our code, but this time having a sanity check. I know throughout the previous lessons, I said we're going to have one, but now is the best time to have one. Now, it took a bit longer to do any sanity check, which means that we're going to run our code to look at our UI and see what we've got. And the reason is because I wanted to make sure you had a very solid code foundation you can work with. Now, at the stage that we're at, we're really towards the parts where we can start to have a bit more fun with our code. For now, but before that, it was really just hardcore code logic. And I really hope you've learned a lot. So wherever we are in our code, no matter what's going on in real world applications, it's always good to have what I call a sandbox test. Now, sandboxing just means having an environment which is safe, that doesn't affect the outside world. So for example, if you're working in a industry where you're dealing with numbers, like say banking, and you wanted to test out a new feature, you would have a sandbox, which is going to be a separate area where you can have a dummy version of the application you're building to test out that new feature. Whatever happens, you don't worry about it because it's in a safe environment. And in our case, when we're building our application, this is for our own learning. So it's good for us to test our code, see where we're at, and then see what's working and what's not. So let's take a look. So I want all of you, providing that you've gotten up to the stage where you've written the same code I've written, I want you to press the play button. Let's see what we get. All right. So you see we get our root here firing up, which is coming from our tk.tk here. And we also have our window that's asking us how many game rounds. So it says, how many game rounds would you like to have? So if I put in 5 here, let's see what happens when I press OK. Hey, there you go. So you see now I can enter a player name, just like what you saw in the introduction. So I'm going to put Michael over here. And it's asking for player 2 now. So I'll just put John. Let's see what happens. So you see, after we get here, our code has exited. So we didn't load our board on the screen yet because we haven't defined in our root to do that just yet. Because we haven't defined in our main function just to do that just yet. All right. So now that we have a structure that works like this, what we want to do is ensure that we can get our code up to the stage of actually being able to play some noughts and crosses. How do we do this? Well, again, it's all down to our game architecture, but I am really happy with the results we have so far. So we can continue working from there to see what we get going on in our code. Okay. So scrolling down just a little bit, we see that our code got up to the point of asking for player 1 and player 2, and nothing happened after that. So after we ask for the player information, and we also ask for the number of rounds, what will be the next thing that we want to happen in our game? Now, from a UI standpoint, okay, part 3 is that we actually want the game to start. So we want the game to start. What does that mean? It means we want the board to appear on the screen. So we need our board to appear on the screen. What else do we want to happen? Well, number 4, we want the scores for each player to be set and then appear on the screen too. Now, when I say on the screen, I mean within our game window. Okay. What else do we want to have happen? Well, we also want to make sure that we start keeping track of the state of our game. So we need to make sure we handle these parts of our game effectively so that we can actually play our game. So how are we going to do something like that when at the moment, all we have is this code right here? Well, this is why I'm here, because I'm going to show you. So let's tackle how we are going to start a new game. Now, once you have a root here that you can work with, we can make use of the different aspects of handling root functionality.
Now, it's important to know that if we're going to get our root to appear on the screen, it's going to be something that we want to have continuously unless we're going to close it. So we want to call our root and use that special function I told you about called main loop. Okay, now what this is going to do is going to allow our root window for our game to continuously appear on the screen. Now, of course, I know this is not enough, but this is a start. Okay, what else do we need to do? Now, again, when you're seeing how the code works together, we have the UI aspects of our code, and we also have our what I call the functional or the engine that drives the code on the UI side underneath working together. So to get that synergy, we want to have the UI component where we see the window, but we also want to have the functionality so that we can actually play the game. Now, coming back to our score text here, I told you that we're going to move things around a bit. Now, with this game score text that we have, we also need to make sure, along with this score text, that we deal with labeling our windows, because we want to make sure that when the game is starting, we know what we're playing, we know what's going on with the game, and then we can crack on to actually play it. So just before our root of main loop, let's drop this here. We also need to have some labeling for our score. So we can call this game score label. Now with our game score label, we need to get access to the TK module, and we want to get access to the label class so that we can provide a label for dealing with our game here. Now this time, we need to pass in what is called the master. Now the master means the root window where everything works, which would be our root. Okay. Now the next thing we need to provide is going to be some text. But the way we want to do this is that we want to actually pass in the text that we've got coming in from our score text. Okay. Remember, the game score text over here is empty. But if I go up just a little bit to show you, let's go right here. We're going to set the score text using this function called update player scores. Now, the first time we start the game and everything's running and we have blank squares on the screen, we want this to be set to 0-0, right? Because the game has just begun. Now, the functionality we have here sets that score text for us. And so we would want to make use of that in our game so that we can set that score text when we're working with the game in our window. Now, to do this, we need to use not text, but text variable, because text variable allows us to pass a variable as an argument that has text in it. Okay, we don't want text because then we're going to have to pass a raw string. We want to pass text variable so that we can pass in a variable that represents the string we're trying to deal with. Now, this is very powerful because a variable can have conditional functionality like a ternary operator so that we can conditionally pass in data as the game is going on. So what are we going to pass in here? Well, I'm going to pass in our game score text. What else do we want to do? Well, with our game score text, we do need to provide some UI design now, and it's getting a little bit fun. So we want to provide, for example, a font. Now the font size for now, we can pass in either a tuple, which is going to be a collection type that has bracket notation like this, and then we can pass in the font type and then the font size, or we can just leave this as blank. Now, if you leave it as blank, it's going to get set to the default TK font, but I would suggest not to do this because you want to have a little bit of fun with your code, right? Now, let's go for a simple font. We'll start off with one called normal. And let's get the size in. Let's just start off with 12, okay, for now. So now we have our game label. What else do we want to do? Well, apart from this,
we want to make sure that we add our grid. You see, we need to make sure we provide our functionality for our grid, not to confuse you before I continue up here. So programmatically speaking, this function create game board creates the programmatic information of our board. This is not anything to do with the UI. This is just the underlying programmatic side that aligns with our UI. Because in our UI, if we were to represent some blank squares, but we don't have the underlying code logic that describes what blank squares mean and how they can be filled in with an X or an O, our game still won't work. So over here, we've handled this side of the story, which is the functional side of what an empty board looks like or what an empty grid looks like. But we also need to match that when we get down to our code down here. So down here, we can say for our game score label, we want to have, let me just make sure I put this in the right place. We want to have access to the property called grid. And here we can use this to position the widget in our parent grid. So if we want to do some positioning, where would we put it? So we can say, for example, that based on our rows, we want to put it on row number 3. Now, if I say row number 3, what does this mean? Now we're dealing with UI here, and specifically the label that we're putting is going to be where we position the text underneath the grid, okay? Just to make it clear what I mean. We're not programming the actual squares on the grid as in we're putting the label inside of the squares because that doesn't make sense. What I mean is that we're going to programmatically place the data, which is our label, somewhere either above or beneath our grid. Now I choose beneath because it just looks better. Now, if we choose row 3, based on what I taught you a few lessons back, what does this mean? All right, row and columns are 0 indexed. So that means if we choose value number 3, which I'm putting here already to save you the hard work of working on this, so you can just learn. This means that we're going to put this on the 4th row from top to bottom. So the 3rd row would represent the last part of the actual grid of the game. 1 row beneath that will give us room outside of the grid, which would be the perfect place. Now with our column here, our column can just be column 0. It's fine. And then the part that we want to work on, as I said before, we can also work with row span and column span. Now with column span, the column span we can work with is going to be the number of spans the column exists within. So if we start from column 0, and let's say that we span 3 columns, what that means is that it's going to give us column 0, which is the first part of our grid. The middle part would be 1, the far right would be 2, 3 would be outside of the grid. So this will position us nicely outside of the grid to represent our scores. And if it doesn't make too much sense, don't worry, because you're going to see it in just a moment. Now, once we've done all of this, now we need to start thinking about updating the score label. Now we need to update the score label once we've set that, because we've asked the player for their names, how many rounds. Now we want to set the game label and all of the things to do with the positioning. And then right here, we need to also update all of this information. So when we want to update all of this information here for the score label, what do we need to do? Now our function that we had for updating the score label was over here. Now we've called it update player scores because it's easier to deal with. So update player scores over here. We're going to pass in our player info. Now you notice that when you pass in player info here, we're running into a situation where it's not letting me not pass in a keyword argument. It wants me to pass in a value here, okay? Now don't worry too much because you're going to see what we're going to do here, all right?
But just remember that we need to pass in information, actual information about our players here at this point. What else do we need to do? Now, after this, as I said, when we ran our code the previous time, we didn't see a board on the screen. So once we've taken care of all of this stuff, we need to take care of initializing the programmatic logic for the board's behavior. Now, the board behavior means that we want to have, first of all, an empty board, right? So if we want to initialize an empty board, so first we'll start off with an empty board initialization. What would that look like? So we can simply use the same keyword we've been using, which is board. And you've probably been wondering the same way that in many of our functions, like our update state function, I've been using the word board. As I said, it's all going to come together in our architecture in the main function. So I'll go back down really quick. Now with our board, we already have a function for this. All we need to do is say, we want to create the board. Now remember, create game board is going to initialize the programmatic 9 squares. So programmatically initializes the 9 squares of our grid. Okay. Now that we have that initialized, what's the next thing we need to initialize? Number 2, initialize the buttons for the board. Because now we need to add those buttons so we can have the event listening structure for when our code runs. So what do we do here? Well, we're going to call our create game button. Now, I think create game buttons might be a little bit better, sounds nicer. So I'm simply just going to scroll up here. And again, as I said, as you write your code, you're going to work on ways where you're going to change implementations of names. So over here, we'll call this create games buttons. And then when we create our games buttons here, what do we need to do? Now create games buttons, let's go back up here. I didn't pass in any data when we first started, which is something I want to handle now. When you create these games buttons here, the games buttons that we're going to create are going to need a lot more information than just what we have written here, okay? Now think about it for a moment. If we create our games buttons and we want to write code for initializing games buttons that we're going to use in a game, what things do you think we might need? Think about it. Well, over here, we had our root from before. If I say we need the root over here for each time we're going to run our game, that would be an obvious one. We also need to have data about our board, okay, that we need to pass in. Because when we're going to write our code, we need to have the board here. Now, I purposely didn't add the function bracket here because I wanted to save it for this point in our lesson, okay? Now, when you see me writing board over here and you've seen it not light up here, is because when we need to update the game state every time we click on the button, we're going to need to get the data of that board and pass it over to this function. So we need to go over here and be passing the board. What else do we need? Well, we're also going to need to have data on our buttons. Now, our games buttons array goes through some transformation. The games buttons append function is going to append all of the buttons into this array of buttons, which is our list of buttons, so that we can make use of it as we're going along in our working with updating the game state. So in our buttons over here, we actually do need to get access to our game buttons over here. Not game button, but game buttons, okay? And the last thing, of course, that we also want to make sure is that we're going to have our player info. Now, of course, some of the code I've written here, we're going to have to back that up over here. So, for example, here, we need to pass in our player info. And over here, we can pass in player info. What about when it comes to dealing with this data here? Because you can see that B for lambda, which is our parameter, has not been accessed. And we need to access that because that contains the data we need for our event listener. So we need to pass B right over here. So capital B, lowercase b. Great. Now, if we look at our update game state at the moment, we have a few things. We have our board, we have our index, we have our buttons, we have our player info. Now, let me move this out of the way so that we have more space for ourselves. Now, with our code for games buttons here, we have the root, which is going to be, of course, the window. We have the board, which we need for our board, okay? And we also need to have our player info. Now, by me calling update game state over here, we're calling this update game state in our function here so that we can update the game state. But the thing is that we also want to be able to pass this function as a argument later on so that we can update the game state many times over. So right here, for player info here, I'm actually going to put update. Let's call this update state, keep it simple. Instead of calling update game state here, rather, we're going to just say update underscore state and pass in all of these values, okay? Now, by passing in all of these values, you're thinking, huh, what's going on here? Or you're going to see. So going back down to our code over here, we have our player info, which we've left out. We have our games buttons here. And now we have access to our root, our board, our player info, and our update state. So now we have it here, as you might have guessed. What are we going to do? Well, we want to pass our root. Now, if you're not too sure what's going on, I'm going to pause it here so that you can understand what I've got going on. At this point in time, when we get to this point of the buttons being created, we're passing in the root of where those buttons are going to be passed in. We're passing in on what board we want those buttons to be passed into. Now, as I left a little blank space up here, so let's go back up. As I left a little blank space here, instead of passing in the actual function, that way it allows us to pass in our actual update game state function in our main function instead. That way we can have better structure in our code. Now, of course, with the board, the player info, the index, and etc., we need to make sure that the order of these parameters do match. You see, with our board, which is the first thing we have, then player info, and then index, and then buttons, if we don't have the same order, we're going to have an issue in our code. Now, I've left it like this so that you can see what's going on, and then we're going to, of course, rectify it later on. The B here that we're dealing with, which is this integer that you're probably wondering, what does that even mean? We're using that as a way for our index value. We need an index. So if we were to rearrange this to match our function, we can go ahead and say board, and let's make sure we got this right. So I'll go over here and put board. So board goes first, then it's player info over here. Then next is B, which is going to be our index. And then we're going to have our buttons, okay? Now, with our games buttons here, once we have this structure, we just have to follow through the same thing down in our main function. So in our main function, we can actually find out what order we're in. So I'm going to do this one more time. So first is the root. You see that? Then it's the board. We can pass board. Then it's the player info. Now our player info, okay, that we're going to have. Where do you think that player info is going to come from? Because right now it's not asking for a actual parameter, it's asking for an argument to fill that parameter. So we can't say player info. If we do, look, we get an issue. And this is why I wanted to, let me just put player info here like this, show you what's going on. So we have two places where player info is needed. We need it to update the score label, and we also need it for creating our game buttons. So just before we create this game label, we need to clarify up here our player info dictionary object, okay? Now this player info dictionary object, we need it because once we've taken in the player's information, we need to assign both the note and the cross with a name. And that needs to be set in stone because that's the foundation of our player information. So this underscore player info that you see me write, comes from here. So we'll say player info and we'll say X, okay? And then players. Now over here, we can assign player 1 to X or player 2 to X, whichever you want. Now I think because of the order, I'm going to go for an O and say we want player 1 info to be the O because of what we've written in our code above. And for our X over here, we'll say we want player 2 info. So now we have this dictionary object here. Our player info can be passed into our games buttons. And of course, the final thing that we need in order for our games buttons to work continually so that we can update the state of our game is to call what? Our update game state. Now, once we have all of these things in mind, now notice that I'm passing in a reference and I'm not calling this function here. I'm just passing in the reference, which is important too to pay attention to. We want our code to handle passing in the data, but we just want to pass the reference. Good stuff. All right. So once we have our code in this format, now we're making ways for us to get our code to work. So let's have a quick sanity check and see what we've got. So I'm going to pass in 1, and I'm going to say your name is Michael, and then we'll go for John, press OK. Now you see, our code is running, but nothing's showing on the screen. Now this is the part that we need to deal with in our next lesson. So let's see what we get on the screen. You see this? So right now, you can see on our screen, if we start clicking here, we're starting to get some functionality. Now, we have 3 in a row as a win here. And if you scroll up a little bit, you see that we get what is called an exception. Now, exceptions are called when there's some sort of error. And it says that an exception has been called over here in our code when it comes to updating the game state. Something's gone wrong. But you can see that we actually got our diagonal win here. So we're getting somewhere. Our code is starting to look a little bit better. You see that we have Michael and John showing up on the screen. And again, we're going to clean this up. And we're starting to really get somewhere with our code. So well done so far, guys. So in the next lesson, let's continue so that we can clean this up and make it even better. All right, guys. So when we ran our sanity check, we did get some code running. So if I clear the terminal just for you to see this one more time, if you run your code with me, or you can follow along and watch. So we fire up our root. So our root shows up, and we also get our function that allows us to pass in a prompt. So it's asking us for an integer. So right now, the code that's working, which is the engine of our code, is on line 82. So All the other lines, so 187 and the rest, will not continue, will not execute until we've gotten past this point of 182. So let's just say we put round 1, okay? So in our code logic, as we're going along with this, we did pass in a number. So this part of our code didn't return us back and destroy the root, okay? Because we've actually done the right thing. So the stage we're on now is what? We're on this stage where it's asking us for the player info. So I'll just put M here. And because we didn't say an empty value, and because we didn't pass in an empty value, we can continue. So now we're on line 199. So let's put J. Okay. So once that happens here, this is the programmatic side that we don't see. But the part that we do get for us is that the information about each player shows up on the screen. So in terms of actual gameplay now, let's say we have a naught, have a cross, we have a naught, we have a cross, and then let's go for a naught, then we have a cross. Now notice what happens. When we run our code, of course, we don't get any sound or celebration yet because we haven't written that functionality. But Tic-Tac-Toe raises an exception. Now, an exception is raised when a certain issue arises in our code. And over here, it says that it's raised an exception when we get to this part here. Command with this update board player state B and then game buttons. This is the first part that gets raised. So it's telling us that we have reached a point in our code where this line has something to do with our exception. The second part is talking about our Pygame, saying that we have a type error because the descriptor play for this description play game.mixer.sound objects doesn't apply to a string object. Now we know that the reason we're getting that is because if I go back up to our code, we haven't actually passed in anything here, which is going to be for our sound file, which we're going to do in a moment. Apart from that, we have one extra thing that is actually missing that we need in order for us to actually get the sound to play. So let's deal with these errors and then we can continue writing our code. So I'm going to stop our code in just a moment, but I just want to show you one more thing first. So now with our code, we still have some empty squares. And these empty squares can still be called. What we want to happen is that as soon as the winner is decided, we don't want any more activity to take place on the square because now we potentially have another winner here because we have a row of circles, which is not good. So we need to mitigate that. So I'm going to close this for now, clear our terminal, and let's deal with each issue. We can go in reverse order and start with Pygame. Now with Pygame, there's a few things missing. Of course, we need to get that file. But just before we get that file, right at the top here, we need to call Pygame. Now with Pygame, there are two parts to using it. We need, number one, sound, but apart from the sound, we also need the mixer. Now we need the mixer initializer to be specific. Now the mixer initializer, we can just declare it at the top of our file. And once we have it there, it allows us to be able to use Pygame to actually initialize playing some sound. So for Pygame, which we have as PG, we can call the mixer, and we want to just simply call the init method. Now the init method or the init function is going to initialize a mixer, meaning that it's like kind of like initializing having a speaker. We can't get any sound unless we have a speaker, if you want to think of it that way. And once we have this initialized at the top of our file, then it's easy for us to be able to play sound later on. Okay, this is how Pygame works. So make sure that you have this written at the top of your code. Okay. The next thing
which is going to be number 3, is we need to also get the sound we want to play. Now, the sound we want to play, if you're watching this lesson, and if you're watching the previous lessons, now the sound that we want to play is going to be available in the GitHub repository. So at the bottom of this video, if you follow our GitHub repository, in the root of our folder, we're going to have our soundtrack file there, which is what you need in order for you to play this game. So I want you to pause the video here, give yourself a few seconds, add the actual file somewhere to your own VS Code folder so that you can make use of it in the code we're about to write. So pause the video now, and then when you've got it, come back. All right, guys, so welcome back. So at the time of recording this video, I've also gone ahead and got the winner MP3 file from my files, and I've added it to the root of our directory here for the folder of our project, the Tic-Tac-Toe game. So once we've got our sound, we need to have a variable globally so that we can access the sound where we need to access it from. So underneath our init here, let's say that we want to load our sound file. Now to load our sound file, we need a variable. So let's call it our soundtrack. And with our soundtrack, what do we need to do? Now Pygame, once we use the mixer, once it's initialized, we also need to provide the sound here. So we need to tell PyMixer that the sound is available. Now what we need to pass here is going to be the file argument, which will be the route or the root. Now, if you followed my instructions and you've placed this winner file in the root of your folder directory, so at the same folder directory level as game.py, then all you need to really do is write the name of the file, which would be winner mp3. So now that we have winner mp3 here, we will be able to get sound when we run our code. And that's all you have to do to solve that issue. Now, the last part before we head off here is that we need to play that sound. Now you can see how the code works. So we initialize the mixer, then we pass in the sound we want to play, and then we're going to call the play function to play that sound. But if there is no file, then there's nothing to play. So in here, we can just pass in our variable, which is called soundtrack. And that takes care of that issue. Okay. Once we've done that, then we can move on to the other issue that we had. Now, the other issue is when it comes to dealing with our state over here. So we need to check what we've written so that we can match it up with our code. So once you've dealt with the sound, the last thing, of course, will be to deal with making sure that our screens present the right information. So what we can do is that in the next lesson, to break this up a little bit so you can have some more dissectable pieces, we'll continue with our second issue. See you there. All right, guys. So let's deal with our second issue. Now, because of what we did in our previous lesson where we've added the sound, let's check what we've got going on so far. So we're going to run our code and press 1. I'll just put M and A. Okay. Now, if you notice with our code, our screen doesn't appear straight away. You can't see it because the screen is not sharing that far. But I actually have to go down to my taskbar and click on the window with the Python symbol to actually get this window to show up. Now, there is a way around this so that the user experience can be better, and I'm going to show you how that works in a moment. Okay, but just keep that in your mind because when it comes to refactoring our code to make it better,
All of these small nuances matter to make the experience perfect. So let's see what we've got going on here. Now, hopefully, I'm sharing my sound with you. So if we win, let's see if we actually get some sound. There you go. All right. So as you can see here, we've got some sound now. Now, it also gives us this M, which is Mr. O, because I'm the naught in this case, has won this round. You see that? So the second error that we used to see showing up, which had to do with our state, has automatically disappeared. And the reason being is because the code logic stopped, and I can move this out of the way so you can see. Now you see over here, before I try to move it out of the way, we've got this blank box showing up here. Also, we see that player O has been added the 1 to it. And because we only have one round, we are actually the winner. And you can see it also says, congrats M, you have won the game. So the code logic that we wanted to happen is working beautifully. And if I press OK, you see the game closes. So we're getting really, really close. So that's pretty exciting. I hope you really are excited about seeing that. Again, we haven't got our confetti yet, of course, and our sizing is a little bit strange. So we need to deal with that. So our second issue took care of itself. And this is why I wanted to split the videos into two, because when we go and take a look at what the error was, which was the first error that came up, you just scroll up a little bit. The state here couldn't update because when we try to call the update state function, we hit a roadblock over here. So the if statement essentially exited early, and that caused our state functionality to essentially bug out, which is why we saw those random errors. Now, what's the lesson here? Sometimes when you write your code, one issue can cause other issues that don't actually exist until you fix that first issue. Now, that might have sounded completely crazy and you're not too sure what I mean, but the best example I can give you is a car crash. Maybe in the course of traffic, you're driving and there's a row of 10 cars. Now, the first car has an accident abruptly, and the other cars are not signaled in time. So, car two crashes into car one, and then car three crashes into car two, etc., until it gets to car 10. So 10 people had a car crash because of one thing. Now, were the other nine drivers bad drivers? No. But the first driver caused an issue that triggered other issues. And that's how programming is. So our one issue of making sure that our sound.play function works has has taken care of the other issues that we had in our code. Okay? So this is important because I know that when you see an error in your code and you see like 100 errors at one point, you're just thinking, in one go, you're just thinking, you know what, forget coding. I used to think the same thing. But most of the time, you have one issue that's affecting other parts of your code. Let's deal with that part of our code where we had the window not showing the way it should. Because again, if we run our code one more time, I don't know what I did. I did a G somewhere. Let's get rid of that. Let me just, oh, I know what I did. Now remember, guys, if you highlight over a certain piece of code and call code runner, it's going to run just that piece of code. So don't do that. Make sure you click out of everywhere so you're not clicking on anything so it can run the entire file. So block it out. One more time. Press 1. Just call this A and B. All right. Now you see at this point, you can't see this, but our window doesn't show up. We don't get the window showing back on the screen. You have to go down to the taskbar, click on the window, and then you see it appears on the screen. Now we don't want that. Now there is a way to get around this, and this is where we can employ some UI tuning, as I call it. So if you want to fine tune our code, let's go down to our main here. When we get to the point of our board and our buttons being created, before we run this main loop here, It'll be nice for us to have a way so that we can get our screen to show one more time. Now, the best place I would say to lodge this would be in a sense that we can have our board being created and our games button being created. Now, all of these things here, by the way, are what I call the functional side of our code. So the non-graphical side. The part that is graphical really starts from this label over here. Before the label, we have our prompts, and these prompts ask us questions about our names for player one and player two, right? So here we have another programmatic system, a programmatic situation where it's asking, where we're saving a dictionary object. So right in between here, right, just before we load any more UI functionality, so just before we load any UI functionality, here we can have some UI enhancement. Let's just call this UI UX enhancement. Now, the reason why I'm calling it UI UX enhancement is because this is partly a visual part, so the UI, or how the user interfaces with stuff, but also the user experience, how the user experiences our game. Now, it's nice for you to have a game where as soon as you put in the values, the screen remains in the same place and we don't have to go and, press on our taskbar icon that has the game and then reopen it again. How do we do this? Well, what we need to do is use our root to get access to a very important function, which is called de-iconify. Now, take a look. Now, de-iconify, this widget, what it does is that it allows us to keep focus on our screen. So it says on a Windows, it will raise this widget and give it focus. Now, what widget is it talking about? Well, you're going to see. Now, every time we create our labels, our buttons inside of our root here, they can be called widgets. Now, for example, if you hover over TK and you go to label, we have all of this functionality here, and it tells you that this is called a label widget. Okay. Now, you probably know about widgets because of using computers. In computers, we say that we have a widget that is let's say a icon widget, Instagram widget, a Twitter widget, etc. These are icons that have functionalities if you click on them. They don't just show design, but they also have functionality that goes along. So if you right click on it or double tap on it, it opens Twitter. If you right click on it, it gives you a drop down box. So these are what widgets are. They're the combination of design and also programmatic functionality connected to it. So once we set that up, we also want to make sure that we provide a title here. And the reason why is, let me just put a little note here. So we're going to set up a root title. As I was saying, the reason why we'd want to put a root title is if you take a look at the code one more time. So let's run this. You see at the moment, it just says TK over here, which is fine. When we press 1 and we say we have M. Now at this point, whilst I'm typing this in, okay, all of that root stuff has disappeared. So let's put R. You see what just happened there? So when I put M and then I put R, I didn't have to go and reopen this window from our taskbar. Immediately, we run this code and then we put our values in. When we get to line 220, this UI component enhancement kicks in where we can see our stuff on the screen straight away, which is great. The only issue is that, as you can see here, it still says TK, which is going to be the default thing we see on the screen. But we can change this. So I'm going to close this for now. And this is why we need our root title. So if we say root and we give it a title, we can set up a title. As you can see here, the type will be none by default, but it still returns a string. Now, root title returns a string, but we don't actually want to see TK. What we want to see is, let's say, Tic-Tac-Toe game. Okay, let's run it again. So press 1, let's put A and B. And now you see, if I stretch this a little bit, take a look. You see it says tic-tac-toe game. Now we're talking business. Now this looks a lot better. Okay, so this is what I call UI enhancement and refactoring. This is where we look at our code and see how we can make the user's experience a lot better. Okay, now we've covered a lot. In this last part of our section here, before we call it quits, we have a few more things we need to do. Okay, the things that we need to do, and I'll just leave a note up here. Let's go down here, maybe. So let's say things to do. Now, this won't be available on GitHub because I'm going to delete it, but it's a marker so that if you're taking a break for the night and you want to come back tomorrow, you can. If you just want to take a break and have some lunch and come back, you can still keep in your mind where to go. So if you're writing with me, the first thing we need to do is when we look at our UI, so let's open this one more time. Let's go 1, A, and B. If you see here, right now, I think our text down here doesn't look so nice. I think we can make this window a lot larger, okay? If you see right here, our stretching of our window doesn't necessarily stretch our beautiful squares over here that we've got. We want this to be a bit bigger. And also when we click on here, I think our X's and O's are a bit too small. If you want to have a good two-player game, it's good to have a bigger size. So the first thing we want to do as things to do is we want to fix the sizing of our board UI. Okay. Number 2, let's go back, is that of course when we win, you're going to hear the sound in a moment, just in case your sound is loud. So let's do this. Okay, so you see our code is working here. It even tells us that you've won the game because the player has the size of 1, and we only asked for 1 round. So player B is the winner, which is what we want. So programmatically and even UI functionality wise is working perfectly. The only thing is that we don't get our confetti of the screen, and we still, of course, have a screen that's too small to contain that. So what's the second thing we need to do? We want to also add the confetti to the celebration. Okay. And I believe once we've done those two things, I think we can say that we've built out a fantastic game. So in the next lesson, let's take care of that. And then we know that we've completed our game. See you guys in the next lesson. All right, people, welcome back. So you finally made it to the last lesson of our last section in this course. I'm really, really proud of you. It's been a fantastic ride so far. And really, even though we finished this course after this lesson, this is the beginning of many more courses to come in the future. So I really hope you've enjoyed yourself so far and you've learned a lot. Of course, we still have some more things to do, which we're going to crack on with. But I want you to honestly give yourself a round of applause because it takes a lot of commitment to follow through with any tutorial, any course, or anything in general with consistency from beginning to end. So even if you took some breaks and came back, the most important thing is that you did come back to complete this. All right, so enough of our conversation here. Let's get to some coding. So I left some notes from our previous lesson on the things that we can do to enhance the user experience. Now remember, UI stands for user interface. So that means our game window in the context of this application. So we're dealing with our widgets like our buttons, our labels, and etc. Now the user experience is the actual tangible experience that a user would have when using your application. So for example, in our code that we had in our previous lesson, we used this root.deiconify so that we can enhance the user experience. What did we do? Well, in this case, by using .deiconify, which is this function that we have access to, it allowed us to keep the game window open, in essence, keep focus on the window so that when we pass in our player names and of course the rounds that comes before that, the window stays as it is so we can start playing. Now, it may seem a bit small as a feature to add or something minuscule, but it does have a lot of meaning when it comes to the user experience. Okay. And we want to make sure that we enhance the user experience because at the end of the day, I'm sure many of you want to be hired by big companies in the industry like the Googles and the Microsoft, and you can have those jobs. It's not unavailable to you. Okay. Now, in the tech industry, the reason why we build tech is number one, for us to be able to have great experiences between customers. But the reason why those great experiences are supposed to be there is because above number one, I call it the bottom line or number zero, even though zero is not technically a number. We can debate on that. But anyway, the idea of all tech that you build, the business logic of the tech is designed to make money. And so if we can enhance the user experience that will allow a user to want to spend more money or spend more time on our application, then we want to make sure we do that. So small features can mean big bucks if you do it right. All right. So dealing with what we have here, we have just two more things to do. One is fixing the sizing of our board UI, which will enhance the UI, but more importantly, enhance the UX, the user experience. But the other part is that we want to add the confetti. Now, the confetti adds a greater user experience because it lets the user know that they really have won. Okay. And this is all of the small features that we can add to make our game work better. Now, with the things to do, one and two, I would actually recommend that we go for number two first. Reason being is because number two is going to number one take longer to do. But also, when it comes to fixing the sizing of our board, it'll be better to leave that to the last aspect of this entire section of our course. So this lesson specifically, because once we've set up the confetti and we have it on the screen, depending on how the confetti looks, we can change the sizing accordingly so everything comes together nicely. All right. So even though we have things to do in order one and two, I repeat, we're going to do number two first and then number one after. All right. So let me scroll up here so we can have a little recap. Now, in our function update game state, the idea here is that when the soundtrack plays, we also want the confetti to play almost simultaneously. Now, programmatically, one will launch before the other, potentially, but we want to have a very simultaneous synergy between the sound and the imagery. And this is our part A. Now, I decided for our confetti that we're going to call it display confetti. I think that's a reasonable name to have. And so since we're going to be using that, we can crack on with making this function now. So I'm going to use the top-down approach. Now, the top-down approach means we write the function name first, so display confetti. Now, of course, the Python linter Pylance is going to complain that this doesn't exist. But having this here, so putting the final product before putting the intermediate parts or filling in the gaps essentially is absolutely fine. And sometimes leaving this as a placeholder can motivate you to want to work and also help you to figure out what you're doing. All right. So sometimes you may see me, not only in this Python developers course, but all of the other courses, you may see me use the top-down approach sometimes. All right. Now, I told you also that we're going to order our code a little bit, but I think once we've written this last function here, we can do some reordering as well. Okay. So I'm going to go down. Let's just drop this right over here at the top. It's the easiest thing to do. So we'll go after updating our state. Yeah, let's drop it right here. So right here, we want to put in display confetti. Now, the first thing you need to know is that when it comes to displaying the confetti, this is the only function in our application, apart from our board function, the create board function, that doesn't need a parameter because the confetti is purely a user interface experience. We don't really need to pass in any data because we're going to be the ones generating the data, which is the confetti. All right. Now, the first thing we need in order for us to be able to display confetti on a user interface is we need something called a canvas, okay? You can call this a UI canvas also. Now, a canvas is really similar programmatically to how in art, when you have a canvas that, a painter paints on. So it could be like a big A3 sheet of paper and you can put it on top of, I believe they call it the easel, but it's the art thing that you rest all your designs on and you can start drawing and, making beautiful art. The canvas is the same exact thing, but just in the digital form, in the programmatic form. So in order for us to get confetti to appear on the screen, we need a canvas for that confetti to appear on. So we need to programmatically get some canvas activity going on. How do we do that? Well, in our Tic-Tac-Toe package, all right, so Tic-Tac-Toe, if you were to ever spend some time to go through the drop-down list, you'll find out that there are a lot of things you can do with Tic-Tac-Toe. And I'm only really scratching the surface so that you can be inspired to want to learn more from the other courses that we're going to provide for you. And also, of course, expanding your own GitHub repositories, which is really important if you want to have a career in becoming a programmer. So in this TK dropdown list that we have, what we're looking for is going to be the canvas right over here. Now, as the name entails, it allows us to create a canvas. Now, we do need to save this as a variable. So I'm going to call this our game canvas, or let's just call it confetti canvas. Confetti canvas. Now, in terms of the data that we need, as you can see from the way the code looks, it looks very similar to the other widgets and stuff we've been working with, where it's asking for this master, which is of type MISC or of type none. Now, it's a keyword argument that's set to none if you don't pass anything in, but we do want to pass in our master. Now, our master essentially is the root UI window, which would be root. Now, the next parts here are mainly keyword arguments. So we can provide keyword arguments, and really and truly, there's so many different options we can go for. But when it comes to our canvas, we really are dealing with dimensions at the moment. So we're talking about the height of something or the width of something. Now, in our case, we want to set up a height and a width. So we'll say the height. Now, a really good number to start off with is usually like 200. And that's for me, not necessarily a good number to start off with in general. It's just for me, starting off with 200 works pretty well. So we're going to have this to be a square. So we're going to have the height to be 200, and we're also going to have the width to be 200. So we're going to have the height to be 200, and we're also going to have the width to be 200. In that way, we're creating a square shape because, of course, a square has this equal number of sides. So height and width would be the same. If we want it to be more rectangular, then we'll increase the height and keep the width smaller, and etc. So that's our canvas done. Okay. Now, when it comes to dealing with our canvas here, we want to specifically give information of structure for a grid. So we need to have our canvas grid structure. Okay. So with our canvas grid structure here, what do we need to do? Well, we need to get our confetti, and then we're going to add on property grid. Now, what grid allows us to do is to position our widget inside of our parent widget in a grid. So the parent widget in this case would be the main frame of our UI that we're dealing with. And if we want to position this, if we want to position our confetti canvas correctly, then we're going to need to use a grid in order for us to do that. Now, in our case, we don't want to use rows and columns the same way we did in our previous lesson. And the reason being is because we're not trying to necessarily put our canvas to one side. We actually want it to appear in the center of the grid. So for that, we can keep our column as 0 and our row as 0 because we don't want rows and columns. But what we do want to do is that for the parent widget, which is our 3x3 square, for example, that area in our UI already has rows and columns. So here we can use the column span and the row span, which I previously told you I'll talk about in our code here, so that we can span the current canvas, which has a height of 200 and a width of 200, and we'll talk about pixels here. We can span it across whatever amount of columns and rows we want relative to the parent widget that we're dealing with. So in this case, what we want to do is say our column span. Now with our column span, the easiest thing to do would be to put it to 3. Now, because the index starts from 0, what's going to happen here is that our column starting from 0 would represent the first column, which is outside of the grid in terms of our 3x3 square. The first column is the first vertical line or the vertical squares. Middle would be number 2, which equals to number 3 in terms of how many columns we're dealing with, but it would be indexed of 2. And then the final one would be, which would be index of 1. And then the final one will be index 2. And that would take us to having 3 columns. Now with our column span, us saying that this equals to 3 here means that we're going to have 4 columns because we're going to have 0, 1, 2, and 3. That equals to 4 columns. We're going to have the same thing for our rows span, which will have as 3, which will equal to 4 rows. Remember, column span and row span, including column and row, are all 0 indexed. So 0 means the first column. Now, what we're trying to say here is that we want our confetti grid positioning to essentially cover the actual game board so that we see the confetti size-wise over the game board. So once the player has won, we see that confetti showing up on the main UI, okay? Now, once we get past that stage, the next thing we need to do is set up our confetti styling, okay? Confetti styling. Now, you see, when it comes to the confetti styling, there are options for you to choose from in the sense that you can choose, number 1, the colors, all right? And you could also choose the number of confetti pieces. So number of confetti pieces you want to be generated. Now you're probably thinking, why would I want to choose the number of confetti pieces? How am I going to know if it's enough for the amount of seconds or minutes or whatever the confetti would be falling down on our UI? Now the answer I'll give you here is that, first of all, because Python is a procedural language, unfortunately, we can't skip over the mathematical aspects of our UI. So I told you we have what we call our functional logic, and then we have our UI logic. In order for the UI to actually generate these shapes on the screen, we do need to use a bit of maths to figure out how many pieces there are. Now, the positive news is that you don't actually need to know a certain number. You can start off with a random number. If it's not working out when you run your control flow, then you can just increase the number, decrease the number. You can change things around to your liking, all right? So let's deal with the colors first. Now, in order for us to get colors to show up on our different confetti pieces, we do need to have a range of colors stored in a list. And the reason is because in the next section here, what we want to do is we need to randomize our color generations so that we mimic the effects of how it is in real life when we take, confetti from a basket somewhere and chuck it in the air. And, we get all these different lovely colors showing up. So let's do that. So right here, let's call this our confetti colors list. And in here, we can just pass in some colors. So we can say something like we want purple. Maybe we want some blue. Okay, we want some green, some yellow. What else? Want some, let's say like red and orange. Okay. Now you can choose your own colors. I'm just passing in the colors that I've used in our actual finished product of our game, but you can, after this lesson, play around with the colors and figure out what you want. Now, the reason why we're going to create a list here is because when we carry out some randomization in the moment, we need to actually pass these color names into a keyword argument. When we do that, it's going to allow that keyword argument to assess all of these different colors and then generate the different confettis based on the color that we have, okay? Now, when it comes to the number of pieces that we're going to store, again, we're going to need a list for this because we actually need to store the confetti pieces inside of a list. And then we can use that list to carry out different iterable transactions, iterable actions that can happen with a list. Because I told you before that when you have a list, it's a type that allows us to have iteration. So let's just call this our confetti pieces. And we'll leave this as an empty list for now. Let's make some more space. All right, so far so good. Now the part that we need to get to now would be generating our confetti pieces. And this is the most interesting part. Let's make sure we get that grammatically correct. Again, yeah. So this is the most interesting part because how are we going to generate these confetti pieces on the screen? How do we, again, have a certain number of pieces showing up on the screen? Now we need to create a for loop, and you've seen this for loop before because we're going to use the range keyword. The only thing that's different is the syntax that I'm going to use here. Let me show you. So let's say that we wanted to have a number of confetti pieces on the screen that would be, let's say 200. So we want 200 confetti pieces. And again, after this lesson, I encourage you to change the code around, play around with it once you understand the code to a good degree, and have some fun with this for yourself. Now, this part that we're going to look at in this next section of building our confetti is the most interesting part to me, because this is where we need to marry the mathematical underpinnings of UI, animation, and design with the actual creative parts to merge it together into a fantastic synergy, which looks like exactly what we're expecting it to look like, which is a confetti display. Now, to do this, we always need to start off with the foundation of the maths first. Now, don't be scared by the term maths because first of all, it's a normal part of programming. And number two, the maths is something that you can practice over time. So even if you're not a mathematician or you didn't do maths in school, you just simply don't like maths, don't worry whatsoever. We're going to make sure that we walk through this together. Now, generating 200 confetti pieces programmatically first and then design-wise after would involve a final step of making sure that all of these confetti pieces somehow are inside of this list, which we've stored as the confetti pieces variable. So the first thing that we'll need to do is work on the generation. Now, we can't create 200 variables, of course, and name them confetti piece 1, 2, 3, 4, and 5. That's absolute terrible code, and you should never do something like that. And as I always say, if you find yourself in a situation where there's something you need to repeat with maybe slight differences, there's most likely going to be some sort of iteration, some sort of function you can use to iterate that specific functionality you need to get the output you want. Now, from a programmatic side, we need a for loop. Now, the common for loop we will do here is say, for example, for I in range of 200 because we want 200 confetti pieces, right? Now, the problem with our code here is that we don't need this I. You see, what we actually want to happen is the actual action of generating the confetti pieces, but we don't need this I value for anything at all. And it actually takes away from our code if we have it here. So to mitigate this, Python has a fantastic way of making sure that we can gain access to the iterative part of this for loop, which is the repetitive generation of something. So for example, we want to create confetti pieces 200 times. We want the action to happen 200 times, but we don't need the count value of, 0 to, in this case, 199. We don't need it. So in Python, to override this and just get the iteration that we need, we use an underscore. Now you're probably wondering, underscores again? Yes, I know. in Python, you're going to find out that underscores are something that Python loves for whatever reason. We've got the double underscores and now we have the single underscores. And even past that, underscores have meaning in other aspects of Python. But anyway, enough about underscores. Let's write some code. So in this for loop, what do we want to happen? Well, the first thing that we want to happen here is from a programmatic standpoint, we need to create our confetti dimensions and coordinates. Okay. Now, as much as confetti is a graphical thing in terms of we can visually see what's going on, the other side to confetti is that it's going to be something that has coordinates. Now, coordinates is mathematical, which means in our code, we need to deal with that. Now, we need to make sure I change this to dimensions. Okay, there you go. And then we can get the job done with working out our design side. So with the dimensions, what do we need? So in order for us to generate our confetti, again, we do need our coordinates. Now, generating these coordinates, as I've just said, is mathematical. So that means we need to figure out how we're going to work out dimensions and then also the coordinates that go along with these dimensions. Now, theoretically, if you have a piece of confetti, what are the coordinates that we can potentially have? Now, we're working with a two-dimensional, and I'm going to write this here, so a 2D game. Now, in a two-dimensional game, we're working with two axes. We're working with the x-axis, and we're working with the y-axis. Now, in a 3D game, which I'm currently building one in the blockchain Web3 space, we deal with three axes. So we have x-axis, y-axis, and then we have the z-axis. Now, because our game is 2D, we need x and y coordinates. That way we can handle animating our confetti in the best way possible. In fact, without the x and y axis, we can't really do much when it comes to generating our confetti to look like actual confetti. Now, for every x and y axis, we'll have 4 points. Usually when you have a shape, it usually has 3 or 4 points. So for example, if you're dealing with a square would have 4 points, rectangle will have 4 points. Now, the way we can see this in terms of dimensions and coordinates for confetti generation and generating the spacing that we need and etc., we need to have a starting point. So we need a starting coordinate, and then we need an ending coordinate. All right, let me just change this so that when you're taking notes, you don't have any grammatical issues here. So our starting coordinates, usually in more advanced Python programming, we usually call this x0, which means the starting position, and x1, which would mean the ending position if we're talking about two-dimensional space. Similarly, for the y-axis, we'll say y0, meaning the starting y position, and y1, which would equal to the ending position. Now, personally for me, at the stage that we're at when it comes to our application, we want to get ourselves to understand the code rather than being complicated with all of these different X's and O's. We already have enough X's and O's with our noughts and crosses. We don't need any more from coordinates. So as an alternative, what can we do? Well, we can call this X start, X underscore start. And we can also have Y start to mean our starting coordinates. So to set up our starting coordinates, we need to have some randomization of our confetti dimensions, because if we have all the same values 200 times, then we won't really get the effect of having confetti that is being thrown in the air and it's flowing in random directions. To get that nice random human real life effect, we need to use the module I told you about earlier on in our course, which is our random module. We scroll back down. So our random module here, so random, allows us to have something called randomization, which is a functionality that essentially allows us to get random values when we need them for different instances. So in this case, if we wanted to get a random x coordinate and y coordinate for our starting point, we can call random and we can ask random to generate a random integer specifically. And the reason why we want a random integer in this specific case is because coordinates, when it comes to working with our two-dimensional space especially, still works for 3D space as well. Now, the reason why we want to use a random integer here is because we want to generate coordinates that should be whole number integers, okay? So in our case, we want to say to our random integer that we want you to produce some values between the ranges of 0 and let's say 0 to 500 as an example. Now for our y coordinate, we also want to do the same thing. Now with our range, because we're dealing with the y, we're dealing with our vertical direction here. It'll be good to start with a negative number. So we can say like minus, say 200 and then 0. I think 500 is a bit too much. I'll probably take this down to, let's say, about 450. Okay. So the same thing will ring true for our ending coordinate or the end coordinate. So we can say x end, we're going to call random and then get a random integer. Now, this is the part that's slightly different. You see, because we're randomly creating a starting x and y coordinate for each of our confetti pieces, we won't actually know where the end of our x is going to be unless we know the starting position, because it's random. And each time we go about is going to be random. Now, usually in maths, we start from the same point. Maybe we start from coordinate 0, 0, which would be like the beginning of a graph or something. But in this case, it's not so. Our number could be anything between 0 to 450. And because we don't know what that value is going to be until it's generated in our for loop, what we have to do is say x start plus our random integer. Now we can just add a small range here. So we can say like between 3 and 15. We use that same range for our y end. And now we need the y starting point and add random dot rand int 3 to 15. Now, again, these numbers are just our starting point. We're going to modify things in a moment so that we can get the desired look we want. Okay. So that aspect of our confetti is done. We've dealt with our dimensions and our coordinates. But we're not done here because we need to represent what an individual piece is going to look like. So an individual confetti piece. So we'll call this our single confetti piece here. Now with our single confetti piece, why are we saving this variable? What are we going to do here? Well, now that we have our randomization for coordinates, we actually need to get the generation of this UI component. How do we do that? This is where our canvas comes in. Just like an artist, as I said earlier on, can have a canvas that the artist can paint on and generate whatever image. Now, generate sounds so programmatic, but you know they paint and put their heart and soul into the art. We're going to do the same thing, but to generate a single piece of confetti. But because we have a for loop, we'll do this 200 times, which is how we're going to produce 200 confetti pieces that we're going to eventually push into our confetti pieces list. So at this stage, as to where we are right now, we have a canvas. It has a size. That's like our place to paint. And now we actually want to give the command to actually start painting our individual components onto that canvas. So we need our canvas here to help us. So we need to call confetti canvas. And with this confetti canvas, this is the part that gets interesting because now we're going to merge the UI aspects programmatically to the maths we've just done. So we actually need to say we want to create. Now, with the code I've written for the game already, after testing these, The ovals seem to be the best shape. It really gave the closest depiction to what confetti would look like when we're having confetti showing up on the screen. So I want you to choose create oval for this one, and then you can put your brackets. Now this function create oval, take a look at what we have here. We have a few arguments is an understatement. We have a massive amount of arguments here. But the first ones that we come across, as you can see here, is what I was talking about, this x0, x1, y0, y1. These are our coordinates that we need to pass in. Now, the great thing is, because we're already randomly generating these, we don't need to go and hard code a value in here. So what do we do? Well, I'm going to go straight away and say we need to pass in x start, which would be x0. And I'll just leave a little note here. So x0, this is y0, just in case you're looking back at this and you're thinking, what was he talking about? Well, here it is. So our x starting coordinate along with the matching y starting coordinate, then we need our x ending coordinate along with our y ending coordinate. So once we have our x and y positions in place, the way we're supposed to have them, we still need to provide a little bit more information to make sure that these confetti pieces really look good. Now, remember before when I told you that we need to have a list of colors? When our randomization takes place and we generate these ovals, which will be our confetti pieces, we still are going to have a problem of color, because if we don't provide color here, the color that we're going to generate from these create oval by itself, the confetti that we're going to generate from this create oval functionality will not be looking nice. Now, the way that we overcome this issue is to make use of our randomization functionality again through the random package. How do we do that? Now, among all of the keyword arguments we have, you can see there's like 3 pages of keyword arguments. There's absolutely a bonkers amount of keyword arguments you can add here. What we do want to have is one keyword argument that is very useful and a very commonly named keyword argument that we usually use when it comes to filling in the color of stuff. And that keyword argument is fill. Now, fill is a keyword argument that allows us to fill in our ovals, which will be our confetti, with a color. But the problem is we don't want it to be all one color. Now, I know you can chuck confetti in the air that's all the same color, but if we want to get that effect of, having confetti that has different colors or is shining and has different colors in light, we need to have a different strategy of tackling this issue. Now, if you look at the type here for fill, the type it accepts would be of type string. In our confetti colors list, we have a list of strings. So how do we get a list of strings here to be passed into fill, and fill is going to know to use each of these individual colors? Well, the answer is it won't. The only way it's going to be able to have this happen the way we want it is we need to use randomization by calling random and using a special keyword called choice. Now, what choice does for us is that if we pass in an iterable, which is something that is a sequence, we can pass our sequence in here with the string values we want, and random.choice will take care of passing in each of these individual colors for each iteration. So let's say iteration number 1, random choice might choose from this list and say, okay, the first one is going to be a green confetti piece. Then yellow would be the second one, and then red, and etc. And it keeps on iterating until this for loop has reached the 200 count, and then the job is done. We'll have 200 confetti pieces that are all different colors. All right, so I'm going to write a little note here. We're going to use random. We want it to be in the comments. So we're going to use random.choice to randomize the color for each confetti piece. All right. Now I'm breaking it down this way so that you're with me all the way. And also the way I'm speaking, you can pause the video at any point and then come back to continue. So in our random choice here, all we need to do is pass in our iterable, which in this case, this collection type would be considered a sequence. So I'm going to take this and put that here. Good. Now, the final job here is that once we've generated a single confetti piece, our for loop is here for us to generate 200 confetti pieces. So we need to add every confetti piece that we make into this list here so that we can store all of that data we need for further processing. So the final line here, which is we need to add our single confetti, let's make sure we get this right, confetti pieces to our confetti pieces list. Now, this is why a list is called a collection type, because we can use it to collect and store data and then reference it by indexing when we need it, which we're going to do not too long from now. So what do? Well, we need to call confetti pieces, and we're going to use our special method that I taught you called append. Now with append, we can pass in an object. It says of type any, but in our case, we want to pass in a single confetti piece. But what's going to happen is that we're going to add 200 confetti pieces by the time this for loop is done. So we'll say single confetti piece. Now the thing is, with the way that we've written our code here, if we append this single confetti piece, take a look at the type. It returns an integer. Now, the thing is that by appending just this confetti piece, unfortunately, the job is not done, okay? Now, I know that when we generate our confetti pieces here, that we're generating them based on our start X and Y and our end X and Y, okay? But the thing is, for this to work with our confetti pieces, we can't just send over our single confetti piece, because as you can see, the return type is integer, but that's not enough information for us to generate a confetti piece. What we actually need to do is add the additional data that goes along with a confetti piece to make it a confetti piece, which is the directioning. So what we actually want to do is have what is called a tuple added. Now, a tuple is represented with these brackets, as you've seen here in pink. Now, what we want is we want our single confetti pieces to have a solid place to store not just the confetti piece itself, but also, as we talked about earlier on, the dimensions and coordinates. Now, what dimensions and coordinates do we need here? Well, in our case, what we want is not the starting point, but just the ending point. Okay, so we can say we want X end, and we need also our Y end. And you're going to see a little bit more why we need these later on. All right, but for now, take my word for what I'm saying. Now, once we've done this, we've got the generation of our confetti pieces sorted. But the job is not done, because I told you that if we want to work on building UI components, first we need to generate the actual UI components and the underlying maths that goes with them. But if we want to animate them now, the animation aspect is going to require even more maths. Now, the maths is the primary thing here because the UI component is going to move along the definitions of the mathematical descriptions we give. So to do this, we're going to need to set up the animation of our confetti falling to the ground, okay? Remember, when we want to mimic real life activity, we need to think about exactly how that would work mathematically. So if we take confetti or we're standing somewhere, we drop confetti in the air, it's going to start from a higher position and generally fall down to a lower position, which will be the ground. So the question will be, how do we set up this animation structure so that we can actually get our confetti falling to the ground? Now, what I'm about to show you is important programming concepts and also clean ways to write your code, of course, because it's me we're talking about. I'm playing. Anyway, seriously though, if we want to set up our animation for the confetti falling, because at the moment we have the logic for generating our confetti, but we don't have any logic for moving that confetti on our game UI window. Now to do this, we're actually going to need to use a technique which is called inner function encapsulations. Now, inner function encapsulations is a concept that I've coined that term, inner function encapsulations, but really it's just called encapsulation. Now, the reason I'm calling it this is because when we're dealing with functional programming and we have a scenario where we need to, number one, create flexible access to data, but number two, make sure that we don't expose the sensitive data that we're exposing to functions that don't need to know about it. And in this case, that's exactly what we have going on. You see, our display confetti here has a lot of variables that contain a lot of sensitive data. Okay, our confetti pieces list is important. And what we don't want to happen is we don't want to have a situation where we can access confetti pieces or our randomization functionality, so our X and Y coordinates, from outside of this function, not even by accident, because that will be really bad for the UI display. And ultimately, that will destroy the user experience, the UX, right? So an inner function encapsulation allows us to declare a function within a function. And the purpose of that is that we can encapsulate the implementation structure and logic that is complicated and not needing to be global. But at the same time, we don't actually have to use the word global, because the other way to do this would be to have our separate function again, make most of these variables global, but then we run the risk again of these variables being accessed from outside of this function and ruining our UI. So down here, our animate function is actually going to go inside of our display confetti function. So in here, we're going to say animate confetti. So a great positive reason, like I was just saying, why we should use this inner function encapsulation code style is that all of the data that we need in order for us to animate our data, in order for us to animate our confetti, is available to us in respect to this function, globally to this function. So it's local to us, but global throughout this function. So even though we have a new function block here, to demonstrate, if I type in xend here, you see, before I even get to finishing off xend, you can see that the drop down IntelliSense shows us that we can access that variable, which is brilliant for us. Now, essentially, this animate confetti function, all it needs to do is take the data we've already generated and move it around. So it's best to keep this encapsulated. So what would we need to do in order for us to animate our confetti? The first thing that we need to do in order for us to animate our confetti is to have a for loop to manage the coordinate movement. So for our 200 confetti pieces that we want to appear on the screen, we also need to have a matching for loop so that we can loop over the confetti pieces that we've already generated. So we need a for loop here. Now this for loop is definitely going to be for our confetti pieces. But the part that's important here is that we actually do need to create some variables here for our iterations. Now we actually need 3 values. Why do we need 3 values? Well, for each confetti piece, it's going to contain 3 values. We've appended a single confetti piece. We've also added our X end coordinate and our Y end coordinate. So those X and Y coordinates that go along with our single confetti piece all need to be taken into consideration when we're looping over our confetti pieces. Because what we want to do is access each confetti piece and then make the necessary changes to animate the movement of our confetti pieces. Now, our focus is going to actually be primarily on the y-axis. So there's not that much work that we're going to have to do, and you'll see why I'm saying that. So in our for loop, we can create variables to consider all of these different parts. So we need our x-axis, we need our y-axis, and we need, now let's get this in the right order. Since we have single confetti piece X and then Y, let's do the same thing down here. So we'll say, now a single confetti piece, we can just call it con piece. Now try as much as possible when it comes to using for loop variables to think of values that are useful, to think of variable names that are useful. Otherwise, you're going to get into a situation that you don't know what's going on, especially if you're using multiple variables on the left. So we need our con piece, we need the X, and then we need our Y. Now, once we have these, what do we need to do? Well, we need to make sure that we can get the movement of our confetti pieces. Now, what direction of movement do we want to have? Well, without using mathematical terms, what we want to do is we want our confetti to start from a higher position. So, for example, in the air, if we're throwing confetti, and then fall down to the ground. So if we were to convert this into programmatic speaking, what we want to happen is we want our confetti to start from the beginning of our game window UI. So I'll write this here. Confetti to start from the top of the game UI window, and then incrementally move down to the bottom of the window. Okay. Now I know I'm leaving long comments here, but again, I really want you to understand this. So I'm trying to make sure I leave these code comments. So when you're watching this video and you're pairing it along with your GitHub repository access that you have, you can take a look at what's going on in deep detail. Now, in order for our confetti to have any sort of movement, we need to appeal to the canvas. All right. Now you see our canvas, which let's go up here. Our canvas has a height and a width, yes, but it's also the place where our confetti is going to be showing up on. So we need to tell the canvas to make the movement. So down here, we're going to call our confetti canvas. And it's very simple here. We call a function called move. Now move has a xargs argument. That means that we can pass in multiple keyword values into one argument position. So in our case, we can pass in as many values as we need, and it will be counted as one argument. And this will provide the definition of how the canvas should move. So how does this work? So when we do this, the first part is that we need to tell our canvas that we want to move our individual confetti pieces. So we'll call it con piece over here. The next thing we need to do is provide our X and Y. Now think about this carefully. We're not going to provide X and Y as actual variables X and Y. What we're providing here is actual numbers because we need to tell the canvas how to move. Now, just to give you a little insight as to what's going on here, our X and Y over here move by pixels, move by pixels. So for example, if we wanted our confetti to move down by 7 pixels each time, now moving down, by the way, before I continue with the next part, would be our y-axis. Okay, that is going to be our vertical axis. Remember, our confetti is going to start from the top and drop down to the bottom. So we want to move by 7 pixels and we want it to start from the top to the bottom. And we also want this to happen incrementally because we know if we throw confetti in the air, it doesn't just fall to the ground immediately. It falls over a process of time because of all of the different laws of physics apart from gravity, right? Like air resistance. So to mimic this as much as possible, we don't need to change anything on the x-axis because we want it to fall in essentially a straight line in the same place. So x would be 0. And then we can say over here, we want it to move down by 7 pixels each time. So what's going to happen in this for loop is that we're going to get a movement incrementally of 7 pixels down each time. All right, that's great. But the next part is also equally important. Now, what's the next part? Well, once we've given information to the canvas to move, we also need to update these coordinates every single time the for loop runs. So we need to update the actual confetti pieces inside of this list here and provide an update as to what's going on with the y coordinate. Because remember, our y coordinate is going to be randomly generated. So we can say over here, update the state of the coordinates of our confetti. All right. So if we're going to update the state of the coordinates of our confetti, what we need to do is get access to this confetti pieces list that we have. So we want confetti pieces, so confetti pieces. There you go. Now with our confetti pieces, because we have a collection type of a list, that means we have access to indexing. So if I said index 0,
that will return to me the first confetti piece that's been randomly generated in the list of our 200 confetti pieces. Now, our problem is that we don't know when the for loop is running, which confetti piece is going to be selected. And we don't want to also try to force logic to figure that out. Now, instead of forcing logic, we have a much simpler way to do this, which involves using the same list itself. Since this is the data source that contains the information, we can use this same place to grab the information that we need. Now, what are we doing here? If we want to update the coordinate state, what do we need to get access to? We need to get access to the y aspect of our three values. Remember, each of these values here will look like this. So if I was to do a dummy list right now, our confetti list looks like this. So we'll have confetti, x, and then y. And that represents one value within the list. So if I put a comma here and we continue going, we'll have something that looks like this. Now, our aim in this for loop with this second part, which is to update the coordinates of our confetti. Now, to make it even more clear, we want to update the y coordinate. Once we get a structure like this and we want to access y inside of a for loop, the job here would be to update everything. So in this case, confetti pieces index 0 won't work because we're only ever going to select index 0. But we want this to be organic. We want it to select the indexes based on the X and Y information that they have and then update it so that we have a more accurate movement going on. So in here, we can call confetti pieces again and use a very powerful tool, which is our method called index. Now, index is going to return the first value of the index, providing that you give the value. So if you give a value, let's say, for example, we had 10 values in a list, and one of the values was 20. If we pass in 20, this method will look for the number 20 and return the index of where 20 is being stored. Very useful, right? Now, in our case, for value, in order for us to do that same kind of functionality of searching for an index based on a value, we're going to need to pass that tuple structure I was talking about again, and then we can pass in our values. And this is where our expression here will come in handy. Now, in this case, we need to put in our con piece, and then we can provide X and Y. Now, notice I'm following the same structure as how we've appended our values into our list. So we look for con piece, X and Y. We have single confetti piece, X end and Y end. Now, with these matching structures here, in our index, when the loop is running, whenever it notices a confetti piece that has a certain coordinate, it's going to look for this coordinate index, and then we can provide the command of what we want to update the value to, because we need to update the state of our y coordinates. What would that look like? Well, we simply just need to pass in a new expression in this tuple structure for those confetti pieces. Now, the positive thing is nothing really is going to change because we still want to have our confetti piece. With our x-axis, we're not doing any changes on there, so x would remain as it is. The only thing that is going to change is going to be our y-axis because we want to have that incremental movement down. So we're going to say y, we can say y plus 7. So when the canvas is moving by 7, our confetti is moving by 7 on our y-axis, which is brilliant. Now, you're probably wondering, y plus 7 means we're going to move upwards, or are we moving downwards, or what's going on? Now, let me explain something to you here before we continue. Now, if I scroll up here, the reason why we've used a minus number, and I think I'll leave this here. So let's put y minus 200 for y start, is because we want all of the confetti to not be visible on the screen. We want it to have the effect that when we throw the confetti, it's like the confetti wasn't in view and then it starts to come into view as we move down by 7, okay? This is why we have minus 200. We don't want the confetti to be in view
at the beginning. We want it to come into view with our animation to give that nice effect of something falling down. So when we're adding 7, it's helping for us to bring our incrementation of that confetti from the negative point above back into focus coming down. All right. Just in case you're wondering, I wanted to make sure you have a clean explanation to understand that. All right. We're getting there. Now, the third part here is we need to determine whether the animation is finished. How do we determine when the animation is finished? Because in our UI UX concept, the user interface, which is where the interaction happens, but then the user experience that the user has to go together with great synergy. So determining when the animation is finished or determining whether we should continue with the animation is another point. Now, how are we going to figure out when the animation is finished? The easiest thing to do is we just need to work out, let me write this here, when the Y for all of our confetti pieces is above the length in pixels of the canvas. So if we go back up here, at the moment, our canvas height is 200, which represents our vertical axis, our Y axis. So for us to know when the animation has ended, we need to figure out when Y is greater than the length of our canvas in pixels, okay? Now, by doing something like this, the logic that we create would have to be a conditional statement because we either want to continue with the animation or we want to stop the animation and then close the window. So doing this is actually the most important step to make sure that our user experience is 100% the best, okay? So what do we need to do? Now, in our condition, we need to calculate what's going on with all of the confetti, not just one piece of confetti. And so if we want to figure out what's going on with all the confetti at one time, we have a very useful function in Python that is built into Python called OR. Now, what OR does is that it takes an iterable object and we provide a certain condition to it. If that condition is correct or true, then it's going to return true for all the values. And if not, then we will have false. So in this expression of our if statement, we need to do two things. We need to use an if and a for at the same time. Because for the for loop, we need to loop over all of the different confetti pieces, so all 200, and we need to check all the Y values, and we need to make sure that their pixel amount is greater than our canvas. When we reach that moment, we know that that's the time for us to get rid of the celebration and then we can close our tic-tac-toe window and the game is done. So how do we use it if and the for at the same time? So inside of here, what would be the condition? Well, we need to check that Y. Now you notice that in our for loop, because we're still inside of this block, we have access to Y. So we can say if Y is greater than. Now, if you really want to do this, I'm not saying to do it, you can save a variable here, and I'll just show you an example quickly. We can call this canvas height, and then set it to 200. And then we want to go in here and say canvas height, okay? And we could also do the same thing and say canvas width, it's 200. And then we'll go over here and do canvas width. Now, by saving these two values in this variable, we can get access to the canvas, excuse me, went a bit too far, but yeah, we can save our canvas height and width here, and then we can use these heights and widths down in our code. Now, why would I do this? Well, when you have a hard-coded value, the likelihood of getting the number wrong, because we would have said above 200 here, but just saying above canvas height is more readable if other programmers are working with you, and it also allows us to avoid errors that we can get in the future. Because if we accidentally put the wrong number in, our user experience and the actual UI actions won't work as well. You with me? All right. So after this, we want to say y is greater than height 4. Now remember, with our for loop, we only want to make use of iteration values when we need them. Now, at the moment, we only have concern for the y coordinate. We don't have any need for our con piece, which is the confetti piece, or the x coordinate for that confetti piece. So we can omit these and just say underscore, which means we don't want that. Underscore means we don't want that. And then we can go straight to the y. So the only value that our focus is on, the only iterable value from 0 to 199, which is 200 values that we're looking at, is this y. And then we're looking for this inside of our confetti pieces. So in our confetti pieces, this for loop is going to ignore the confetti piece and the x-axis, but it's going to give us a way to work with the logic of the values we receive from the y-axis. And that's all we really need. Okay? Now, in the case where this condition is true, so the expression again is we provide the expression under what conditions, which is this for loop here. If these all return true, then we can continue. Now, just to let you know, if you use the all function and there's nothing in here, it will also return true. So please don't just call all and put nothing in there. It will return true, but that would, of course, be a faulty value. Now, under the conditions that this expression all the way to the end is true. So if true, essentially, what do we want to do? Well, if it's true that all of our confetti has gone past the height of our canvas, well, we're done, right? So what we need to do is then remove the confetti display from the screen. So we're going to call our root, which is how we handle our game UI window. Now in our root here, what we want is we need to use a function called after. Now after is pretty cool because we can call a function once after a given time. Now, this function reminds me of the JavaScript function set timeout. Essentially, what happens is that after a certain number of seconds, we can call a function, we can use milliseconds, and then from that millisecond amount, which we can convert to seconds, is usually we just go for 1,000 milliseconds equals to 1 second anyway. But long story short, when we use this function, we can set a certain time that we want this confetti to disappear from the screen so that we can get a nice UI and UX experience for our game. So we can say that we want the confetti here to be removed after, let's say, 3 seconds. So for 3 seconds, we say 3,000. And I'll just leave a little conversion note here for you guys. So 1 second equals to 1,000 milliseconds. Now, the function that we want to call here is going to be the function that gets rid of our confetti. Now, to get rid of the confetti, we need to get rid of the canvas. If you destroy the canvas, there's no confetti. So we're going to call our confetti canvas, and we're just going to call destroy. So speaking about destroy, in our previous lesson, you saw me use root destroy, and I also had root quit. Now, the major difference between root destroy and root quit is that root destroy is going to destroy all of the widgets in the main window. Okay. Now, quit doesn't do that. Quit doesn't destroy all of the widgets in the window. So it doesn't destroy any of the widgets. It would probably be more grammatical sense here. It doesn't destroy any. Okay. So when we use destroy here, what that does is that it's going to destroy all of the widgets in our main window. But the reason why we would use quit is because it's going to remove any response to the UI. So when we use quit, we can't go back and access the UI to do anything, but it doesn't remove our widgets from the screen. So we still have a display, but that display can't interact with the user. Okay, that's the simple difference. With destroy, it's going to destroy all the widgets in the main window, and then it's going to trigger a shutdown of the UI window. So sometimes we want to use quit, because with quit, we can actually go back and start our game again with the right amount of code and programmatically, of course, play another set of rounds. With destroy, we can't do that. It's going to get rid of all the widgets and then trigger a shutdown. All right. So this is why I would want to use our quit over our destroy here. Now, in the case of our canvas, we actually want it to be destroyed. We don't even want it to just be visible on the screen, because if we use canvas quit, it would stop any interaction with our UI, which, to be fair, we don't even need, because we're not interacting with the confetti, but it actually wouldn't allow us to remove the confetti off of the screen. The canvas won't be destroyed, so we're still going to see it there. It's just going to be frozen until we close the actual game UI window. So you can see here that it wouldn't be very useful in that case. So handling using quit and using destroy is important. And it's also important to know that when you want to use these, you have to make a decisive decision, because it does affect the UI. Now, one more thing that quit does that I did want to add on here that is important is that if you use quit, what it does is that it stops the main loop function. Now, main loop is how we get our consistent view or persistent view of our game UI window down here. So main loop is down here. Scroll back up here. Now, when we use quit, what it does is that it stops the event loop. So there's no more looping going on. So the UI won't update. Let me go to the right place. So what that does is that it's going to stop main loop. When it stops main loop, this event loop, which is what it does, will no longer be able to receive any events. It won't be listening for any events, and it won't be able to act on any of those events. Okay. But the key thing here is that when we stop main loop, it still keeps our window and all of the widgets where they're supposed to be. They're intact. There's nothing that's changed about them. All right. So hopefully that makes sense. I promised I would insert that in. And then now we can, of course, go back to finishing our code. So in this if statement, we want to destroy our canvas. But what if this is not true? What if we haven't reached past the height threshold, if you want to call it that, which is our canvas height? Well, we need to have another expression. What would the expression be? Well, in this case, only two things can happen. So we don't need else if, we just need else. So if this condition doesn't evaluate to true and all of the confetti pieces are not above y, then all we want to do is we want to say root and then after. So let's do this here. If the y direction for the confetti pieces are not all above the canvas height. So if they're not all above the canvas height, well, we need to continue with the animation. The animation is not finished. Okay, so if we don't get to that finish line for all of the confetti pieces y direction, that means the animation duration should still be continuing. Now, what we can do here is play it smart. What we have to make sure that we keep the illusion of is our confetti falling. So what we need to do is create our illusion of continuing our falling. So what we need to do here is make sure that our animation continues to run. How can we keep our animation continuing? This is where having our inner function encapsulation is very powerful, because the function we want to call is going to be the same function we've declared in here, which is animate confetti. So let's say that we want it to happen that, let's say every 40 milliseconds, so something very fast, so not really humanly visible, we want to call this animate confetti piece. Every 40 milliseconds, our animate confetti function is going to be called. Now notice that I pass it by reference and not call the function down here, because we actually don't want to call animate confetti by its function. The return type is none, meaning that this is something that just carries out an action. It doesn't necessarily need to return us any data as well. We just want to pass the reference, which is the memory address, and Python will take care of the rest. Now, once we've done all of this, in our display confetti function, calling animate confetti is conditional based on whether the animation has already started. But in order for us to actually get this animate confetti to start, we need to call it within this function we're in. So we need to call our animate function. All right. And when we call this animate function, this would allow us to begin animating the confetti we have generated. All right. And over here, we're just going to call animate confetti. Very simple. So calling our animate confetti here would call this function. This function will begin to run after we've generated the confetti, because we're in order of generate first with the coordinates, and then movement afterwards of the canvas, and then finally checking to see if that confetti has gone past our height threshold of the canvas. Now, all that's going to happen is that this function will continue to run. Now, the first time it runs, if you're a little bit confused, so let's do this number one. So the first time it runs would be via animate confetti. Now, what about all the other times it runs? This is where this if statement is very powerful. So what's going to happen is that it's going to continue to run our animate confetti function every 40 milliseconds until this condition becomes true. So essentially, it's like we have animate confetti being called many times over. Now, the smaller the seconds, the faster it's going to appear. And of course, we can adjust this. But essentially, now we've got this structure here. Displaying our confetti logic is completely done. Now, we're not exposing any of the sensitive parts of our UI to any outside function. We're keeping it all encapsulated, nice and easy for us to use. All right, guys. So now that we've got to the point of finishing our logic for now, the next thing we need to do is to test it. Now, what I'm going to do is I'm going to change the way my screen appears for a moment so that you can see my Visual Studio screen and also see the game running at the same time. Essentially, we need to test our code here and then see if it's working. Now, I have left a few things in the code, which are going to be pitfalls that I want you to overcome. So you're going to see in a moment what I'm talking about. But for now, I'm going to switch the way my screen appears and share my sound with you as well. All right, so I'll switch screen now. What we want to do is run the game and see what happens when we run it. So let's run the game. All right, here we go. Now, I want you to take notice that one of the refactorings that we're going to need to have to do is that whilst we're running the game, the tic-tac-toe game rounds window shows, which is okay, but this window, this blank random window just shows up, and we don't actually need this window to show up at the time. Now, this window is where our game UI is going to be so that we can actually play the game. But we don't want this to appear straight away. We want it to appear after we've put in the information. I think it will look a lot nicer because this looks a bit random. So that's one feature we got to pay attention to, and we're going to fix that in a moment. All right, so let's go for one round. All right, so it's A and there's B. All right, so let's play the game. So you see, this is the same window as the window that we just looked at that was blank. We want this window to appear after we filled in the details, but not beforehand. So we leave this here. I'm just going to pretend to win. So as you can see here, we have a bit of a problem because our animation is not showing. Now we can see the colors just about over here. You can see some orange and some purple, some green. So the randomization is working, but we have no animation at the moment. So I'm going to press OK and the game is done. Now, what could the problem be? And this is what I want to show you. So in our code here, when it comes to debugging, I like to sometimes leave a few errors in our code so that we can work together on how to fix it, and you can find out the common pitfall mistakes to make. So I'm going to take this in a few steps. I'll deal with the code logic first, and then we'll deal with the making our UI better after. So that would also make the UX better. Now, the first thing to take a notice to would be from the top of our code. So at the top of our code, we have the height and the width, which is fine. Our colors list is fine because we know that's working. Our confetti pieces is working because we do see some ovals appear on the screen, and our range is fine. The part that I can see that we have a problem is we don't have any movement. Now, the first thing that's wrong with our code that we actually need to fix is this line right here. Now, this line right here, maybe if you looked at the code whilst I was writing, you're probably screaming, oh no, we've put the wrong thing in. It should be X star and Y star. Now, let me explain something to you. These single confetti pieces that get generated from our create oval function need to have the starting point as their coordinates, not the ending point. Now, this recursion is when you call the function you've created inside of that same function. Now, there are some uses to this. Sometimes, especially when dealing with complex data that is very large, especially in Python, sometimes we would create a recursion function that breaks the difficult problem of, maybe 1,000 GB long into very small pieces of repetitive processing so that we can keep our CPU cool for one thing, but also we can handle, large pieces of data. So we use a recursion function for that, which means we're going to loop over the execution as many times as is needed to break down a large problem into small pieces and get the job done. Now, in our case, we do want to have some form of recursion, which we have in our if statement. In our if statement, as long as the canvas height has not been crossed yet by the y direction of our confetti pieces, then we can continue animating our confetti. So this is a form of recursion. We want to have our endpoint, which is our end coordinates, only in the create oval function, but the actual coordinates where we want the ovals to start off and then eventually fall down to the ground should be the starting point. So we're going to pull for X start and Y start. And I'm going to leave a little note here. We need the X start point and Y starting point coordinates. Now, if we have the ending point, that means when this animation is running, is not really got the coordinates to actually move anywhere that we want it to move to, which is not correct. All right, what's the second problem we have in our code? So if we run this now again, let's see if we get any difference first, and then after we'll check to see. So we're gonna go for 1, A, B, play again. Okay, so now we have our confetti. If you notice, there's a little bit more view of the confetti on the screen now. Nothing that major, no movement just yet. So press OK for now. So what else could be the problem? Now, the problem here is clearly something to do with the animation. Our numbers are okay. We'll probably change them around in a moment, but the main problem we have is in our animation function. Now, one of the most common pitfalls that I want you to always be aware of is indentation. I find that a lot of developers, writing code and starting out, make this mistake with Python. Now, Python is a programming language that requires you to observe white space and indentation blocks. So an indentation meaning, for example, if you declare our function, we need to have an indentation of 4 spaces to denote the fact that this is the code block logic for this function. That's how Python works. Now, if you look at our code very carefully, our for loop here is to loop over all the confetti pieces and add 7 pixels to them right over here. But our if statement that we have here and our else statement is also inside of the indentation block, which means we have a recursion problem. Okay, so this problem we have here where we're not seeing any animation is because we have a recursion problem. And the way we'll know that is if we were to run this code with this block here and change the implementation of where this function down here is, because another problem we have
is that it seems as though our animation is not even running. So that means that this animation, this animate confetti function is not even being used. So we have an indentation problem. So let me show you what I mean about the recursion problem, because it's pretty obvious as soon as you try to run the code. So we have our for loop here. Now, in order for us to actually get animate confetti to work, and this is one of the important things about inner function encapsulations. If you create a function within a function, you need to make sure that the function is called in the right indentation space. Now, our def display confetti function starts off on the far left of this margin of our window here. So if we want to call this function animate confetti here, it needs to be 4 spaces to the left. Now we're calling animate confetti. Before, we weren't calling animate confetti. What we're doing is something a little bit different, which is called recursion. So every 40 milliseconds, we run our animate confetti function. So if I move animate over here to the left, take a look at what happens now. So do a quick one. Here's A, here's B. Pretend to win. Now take a look at what's happening. If you can see this, hopefully you can. My mouse has turned into the loading symbol for Windows, which means that something is being processed. And if I try to close this right now, let's see if I can actually close it. I don't think I can. You see, it says program is not responding. This means we have a very high amount of looping going on. There's a big iteration of this function. In fact, it's happening as many times as there is confetti pieces, so 200 times. So we need to close this right now. And you see that it says Python is not responding. And that's all because of the way our code is written here. Indentations do matter, guys, and this is one error that I left behind so that you never forget this when it comes to writing code. You see, again, the problem that we have is that our for loop, which has our confetti pieces here, also contains our if statement. So what's happening, instead of evaluating this one time outside of this for loop, we're evaluating it 200 times, which is causing our code to have a very high number of recursions that are unnecessary. So what we have to do is we need to shift this one to the left like this. And now what this means is completely different. Now we're saying that after this for loop is complete and we've moved each piece by 7 pixels each time, now we can check one time for this expression. If that's the case, then we're going to do a root after and then destroy the canvas, and then we can get the job done. Now, another thing I want you to note here. So let's go for, I'll leave a note here. So error 2 is indentation error. Now, the reason why I left this error here is because when you use Python to build applications, and even if you do use AI to help you, and you, let's say, for example, you take the code and paste it to an AI chatbot to help you, it won't always be able to pick up on all the errors. So there is a part where you're probably wondering, can AI, for example, take my job role as a developer? Not quite. There are weaknesses that AI has, and it can't solve every problem for you, which is why I like to make sure that, again, I leave problems that we can work together to fix. So this indentation error is not easy to pick up on unless you understand how control flow works and how conditionals and, again, indentation works. Now, the meaning of our if statement being outside of this for loop now, again, means we're going to run it once. And then once we've run it once, we're checking to see if our confetti height has reached past the canvas height, and then we're going to destroy the canvas. Okay. Now, what else is there? Now, we have a third problem, and it's on this line right here. So let me just put a little arrow. This line right here. Now, what's wrong with this line? Well, as I told you with our animate confetti function, we need to pass a reference to a function if we want to use it inside of something like the after function, okay? We have to pass in just the reference, not the actual function call. The same thing is true for our destroy. Over here, I left destroy with this function call. If you took it away, I'm very proud of you for picking up on my little slyness that I did, but right over here, this destroy function over here shouldn't be called with our brackets. We only want to pass a reference to the memory address where this is stored, and Python will take care of calling this function when it needs it. Okay, so if we run our code, you're probably wondering what happens if we put our brackets here. I'll show you. So let's see what gets happening. Let's see what happens now. So we're gonna go for 1 here. Let's go A and then B. So let's run our code here. Let's pretend to win. Now you see what happened there is that when we called our 3000 here, seconds, after 3 seconds, if you see, our confetti ran away. If I take away the brackets next to our destroy and I run this again, take a look at what happens now. So I'll go again. Let's do this. All right. So when we use the destroy without the function here, maybe you didn't see that. So I'm going to do it one more time. Let's put the brackets back on. Let's do it again. So the brackets are back on now. 1, let's go A, and let's go B. Make this really quick. All right, so that was a very minute difference. But what happened is that when we have the destroy with the function call on, you see that our animation, there was an orange oval that was still showing. It didn't actually have all of our confetti disappearing from the screen. When we call this destroy function, that's what happens. If we take destroy off, and I know this is quite a minuscule difference, but it's important you see this. So let me get rid of that. Take a look now. So if I don't call destroy with the function bracket call, and I just pass destroy as a reference, take a look at what happens now. So 1, A, and B. All right, so did you see that? So what happened is that when we don't call this function, we pass it by reference, it gives our loop here, it gives our if statement enough time to actually allow the entire canvas of our confetti to disappear from the screen. Okay, in this second example here, not passing destroy by reference, okay, allowed all of the widgets to have a chance to be removed completely first and then destroy. So I'm going to leave a little note and say, no pass functions by reference only, not by function. Okay. So that fixes that error over here. Now, once we've done this, I think if we run it all together, we know that it's working now, because when we call destroy without a function call, we see our animation disappearing off of the screen. So now all we've got to do really is focus on fixing how the screen looks. Now, I think the first thing that we should target is to get rid of this annoying box that appears on the screen right here. We don't want that. So I'm going to cancel for a moment. How do we fix that? Well, we need to go to our main logic and take a look at what we have. So when our main function fires, the first thing that happens is that we have a GUI window that appears on the screen. And of course, our dialog box then fires to ask the user the question about how many rounds they want to play. Now, what we need to do is that during the time when the root is triggered, we only want this simple dialog box to be appearing on the screen. We don't want anything else. So we need to make a little bit of a programmatic change over here. So I'm actually going to go over here and we need to get the main GUI window to be invisible until it's time to start playing the game. All right. What we want the screen to do is just to appear to be hidden for now until essentially it's time for us to start the game. Okay. So in a situation like that, we need to get access to our root. Okay. So to do this, what we're going to say is we're going to call root and we're going to use a very simple function called withdraw. Now, what withdraw does is that it withdraws the screen in a way, and then it's going to redraw it afterwards. Okay. Now, when you do this, it's temporal because as soon as we ask the questions about how many game rounds, player information, we have this function de-iconify. Okay. Now, remember what de-iconify does to enhance the user experience. When we use de-iconify, we're using it in a way so that we can keep focus on our screen. But there's another way that de-iconify works. And what that does is that if we withdraw the screen, de-iconify will bring focus back on that screen. Let's test this out and see what happens. So let's run this. You see? So now we don't get that TK window showing up on the screen. We just have how many rounds. So let's try this now. So you see, we have a better user experience. We don't have that ugly screen showing up where when we run the game, the window shows up for no reason. So if we use withdraw, we need to make sure we have de-iconify to bring focus back on the screen. But with the way that we have our UI logic, so our main architecture, de-iconify only fires after we've taken in the player's information, which is the perfect timing for that. I think one other thing we should fix would be the sizing, because I think our window is a bit too small. If you want to play this with your friends and family, you need a good size screen. Now, when it comes to sizing, one of the biggest controlling factors, let's scroll it up a little bit more, to the sizing of our screen would be our buttons. You see, our buttons are controlling the size of the grids because they stretch with the size. I'll prove it to you by changing the size over here. So let's go for, let's say double the size. Let's go for 20 here with our buttons. Take a look at what happens now. So one round, here's A, here's B. So you see, now we have bigger sizes. It looks a bit better right now. I want to close this for now because we don't want to play the game just yet. Let's take this up a bit more. Let's double it again. Let's go for 40 and see what we look, how it's looking. All right, so we'll go again. 1, A, B. Look at that. See, now we have a nicer screen. This looks more like the one that I showed you in the beginning of this tutorial. So it looks a bit better now, a little bit more realistic here. All right. Now, as good as that looks, we have another problem now because we have a bigger screen size here. I think we can take it up just a little bit. I think I'm going to go for 50. I want it to look good. But now our screen is big. If you notice, the animation of our confetti is really small and now it looks pretty strange. So we need to have a change in our canvas size. So to change our canvas, let's go down. We need to change the height and width of our canvas to fit what's going on. So let's take this up to, let's say 500, for example. All right, let's see what happens now. All right, so we have a bigger screen. Let's see what we get. All right, not bad at all. So essentially now with our canvas size, we need to get our canvas to be the same sizing as our screen. So we have a few options. We can keep the confetti size the same and then maybe take this down a bit. So we can take it down from 50 maybe to like 45 or something like that. Maybe push this up. Let's try 600 and see how that looks. So it's one round. Now, by the way, before I continue, if you put a value in here that is not an integer, just to remind you again, we do have error handling logic that comes with the ask integer function. So if I put a in here and press OK, take a look. It says, not an integer, please try again. And it tells us that we have illegal values. So we have logic here already available for us to retry again. So we're going to press A. See, it doesn't work. All right. So let's put a number in, 1. Now, I think also I said 1, but let's try and have multiple rounds and see if our logic works for having multiple rounds before we continue here. So let's try a few things together. So let's go for best of 2 rounds. So I don't bore you with my tic-tac-toe gameplay. Let's try this out. So, all right. And there you go. So you see the game restarts itself. So because we have 2 rounds, you see now it has an update and says that player A, which is the naught, has 1, and player B, which is the X, has 0. So let's try and make the X win now. It's 1-1. You see, the game continues. Why does the game continue? Remember what the code logic says? Let me just move this to the side. When it comes to checking our code logic here in our if statement, we add 1 to the score. Okay, we show who won the round with our message box, then we reset the game, and then we check overall win. Now, when we go down to check overall win, let's go down a bit. What's the logic for checking the overall win? Now, even though we've had 2 rounds of games so far, and this is round number 3, the logic here is that we need to make sure that under the circumstances where the player's score, which is the same amount as the number of rounds, so greater than or equal to, under that condition, we can start to check who the overall winner is. Now, we can't check who the overall winner is because none of the players have reached the same score as the number of rounds, which is 2 rounds. So the logic is very smart here. So if there was a draw 5 more times, the game will not end until someone makes it to 2. And this is where we get this logic where if player score of naught is greater than cross, then obviously the naught is the winner. If not, it's the cross. Okay, but this logic here of greater than or equals to, or of course for the cross as well, is greater than equal to the number of the rounds that we have, works out really well. And then you see that we have our message box and then we do root quit. Now root quit, the reason why again we need it is because it's going to stop the main loop event listener, so we can't get any more events, but at the same time, it will still display the board. We can't interact with it anymore. The buttons are disabled, which means the state of our buttons, which I've shown you. Let's go up a little bit. So our buttons here get disabled, which is what we want. And then when we start the game again, it becomes normal, state normal, which means they can listen for events. So you see, after 3 seconds, the canvas gets destroyed. We're in this page, we can't click on anything I'm clicking. You can hear the Windows sound, we can't interact. But now take a look. Now it says that congratulations, you have won the game. Now you see in our control flow in our UI logic, it automatically clears the board. So that function that we called to clear the board, to reset the game. So remember, if we go to reset game, we just link that there. You see what happens? We call create board and it programmatically clears the board, which means it clears the 9 list objects and sets them back to none again. And then we reset all of our buttons to put the state back to normal and the text back to empty. So no noughts, no crosses. Perfect. So you can see our code logic works out very well. Now with our animation here, I'm just playing around with the sizes, but if you want to, which I encourage you to do, I want you to play around with the design and change the colors, change the size of the animation. You can change the duration. If you want to, you can even change the amount of, let's go back up here. You can change the amount of confetti that appears on the screen. Maybe you want to have more confetti on the screen. You can knock yourself out with the numbers. Okay, but I really hope you've learned a lot. And I want to say a big thank you to all of you for following through to the end. I appreciate all of you. I love you guys sincerely. And I'm going to be making sure I always bring you top tier content. So we officially have we officially have come to the end of the Python Developers Course 1.0. I'm very proud of you again. And I really hope you watch all these lessons again. Don't make this a one-time thing. Practice, test out your skills, write the code yourself about looking, and make full use of our GitHub repository because a lot of code will be there that you can take for yourself and build upon. So until the next time, guys, I'll see you in the next video. Take care, guys.